Hey,
Hello. Are we here?
hello. Yes, looks like we're on
This is
stage.
great. I like the music that the team chose this year.
Yep, yep. It sets the mood and the energy. It's really nice.
Well, welcome to Posette, an event for Postgres. I'm going to pop our welcome slides here, and we are going to get started and dive through and go through some logistics and tell you what to expect today. Um, there are 42 talks in Posette this year. There's 4 separate live streams. This is live stream 1. There will be another completely unique live stream in the Americas Friendly Time Zone tomorrow, same time. That's live stream 3 with 2 different hosts for that. And then there's 2 live streams that are based in the European Friendly Time Zones and Middle East and Africa. And those are live streams 2 and 4. And you can check it all out on the aka.ms Posette-schedule link that's showing in the bottom right there. Looks good? My name's Claire Giordano. I am head of Postgres open source community initiatives here at Microsoft, and I'm so excited to be part of today's live stream. And
I'm Krishna Kumar Devi, KK. I'm engineering manager for Postgres open source engineering team here in Microsoft. I'm excited to be part of this, doing this first time. Looking forward to learning from Claire. Yep.
awesome. Okay, so I think you all probably know that this Posette conference is brought to you by the Postgres team at Microsoft, but there is a lot of community participation, and I'll pop up some cool photos of all the many people involved in just a second. Why do we do this? I love in-person Postgres conferences. I meet a lot of people. I learn a ton about the technology and about the whole process for developing and evolving this database. But we also wanted to make some of the great Postgres content accessible to people anywhere, anybody with an internet connection, making it available virtually, because we know not everybody can travel. They might not have budget, they might have elderly parents or young kids, or whatever the reasons are that are preventing them from going to as many in-person conferences. So there's a place for both in the world, but that's a good part of why we've created Posette, to share all of this expertise with you virtually. There is a code of conduct for this event, even though it is virtual. And it is all the things you would expect, right? To be considerate, respectful, thoughtful about other people, be open and curious to other points of view, friendly and welcoming. There are a lot of people that are engaging on the virtual hallway track for Posette, which is happening on the Microsoft Open Source Discord. I'll share the link in just a second. And so whether the conversation is happening there or on some of the social platforms, we just ask that you adhere to the code of conduct. And if you see any issues or want to report an issue, you can go to the link that's showing in the bottom right, aka.ms/Posette-conduct. Sound good?
Cool.
All right. Today's live stream is available with live captions in English. So if you're watching on YouTube or on the Posette site, you should be able to use the settings key and select English and watch with some pretty high quality captions that have all been QA'd. And then after the event is over, all of those captions will have been translated to 13 other languages. Oh, and I don't have the list of languages in front of me. I'm sorry, KK. I know you're going to ask, aren't you?
Yep.
I'll go dig that up
Cool.
before the next
We'll
live
figure
stream.
that out and post it out. Yep.
Okay. If you are live posting the event, please use the hashtag PosetteConf hashtag. Did I just say hashtag twice? So that way other people can find whatever it is you're sharing, whether it's pictures or screenshots. And you can also follow at PosetteConf on several of the social platforms, notably X, formerly Twitter, and Mastodon, as well as Threads. So I said I would pop up some faces of the many people in the community who have contributed to Posette. This is a pretty heartwarming slide.
Yep. Very, very thankful for all the speakers, keynote speakers, and folks behind the scenes as well. We have really gotten an amazing set of speakers this time. Some of them are repeat speakers, some of them are new speakers, and the whole how this selection process happened and things like that. There's a blog which we have published out in the links that we'll provide as well on it. But just excited in general. Hope you enjoy and get to hear all of the speakers that.
Yeah, there's 44 speakers total. That includes the keynotes as well. And yeah, just an all-star cast of people. A lot of these talks are about the Postgres core technology, but there's also talks about the ecosystem and Azure database for Postgres and extensions, and including Citus, of course. And yeah, it should be pretty fun. Oh, time for some gratitude.
Yes. So thanks so much for first of all this conference. The kind of work that goes into selection team is like you have to balance a lot of aspects of how the papers are selected and things corresponding to that. So I would like on behalf of everyone, I would like to thank the selection committee here. So I would like to thank Alicia Kuhachik, Claire Giordano, Daniel Gustafsson, Melanie Plaggeman for an awesome work about selecting papers and keeping the balance. And most of like all of them are experienced in dealing with a lot of these things, like having done many conferences in the past. But it's very special this time when you look at the conference papers that have been selected, you will really realize the kind of work that they have put into these selection. Thank you.
Thank you. It was a lot of fun. Only 184 talk proposals to review. We also want to thank the organizing team, Teresa Giacomini, Chair, and Aaron and Adi and Aaron in the background doing just a ton of work to make it all happen. And we also want to make sure everybody knows about the virtual hallway track. So there's a Posette Conf channel on the Microsoft open source Discord that you can get to at aka.ms/open-source-discord. And all the speakers for the various talks have committed to be there in the Discord for Q&A while their talks are being live streamed, because all the talks are pre-recorded. So even though it's a live stream of these pre-recorded talks. And so that's actually kind of cool that you can go and be watching the speakers talk and ask a question then and there on Discord. So please pop on over, say hello, introduce yourself. And there's no such thing as a bad question. So all questions are good questions. And yeah, hope you enjoy the conversation. I think we're getting a prompt that we need to move this welcome along so we can get to the keynote. So I also want to just let everybody know there is some swag available, limited supplies. So don't wait, definitely go to aka.ms/posette-swag. You're going to need some codes that will be distributed in banners during the live stream as well as on the Discord in order to put in your request. I know that the socks in particular are very limited in supply. There's a whole bunch of sticker packs available too, which is kind of cool. All right. There's a cloud skills challenge. So for those of you interested in Azure database for Postgres, there are 2 cloud skills challenges that you can compete that are organized by Microsoft Learn. The deadline for both is June 24th. So you don't have to do it today, but you only have a couple of weeks, and you can register using the URL on the bottom left of the screen, aka.ms/posette-csc. So definitely worth checking out. If you complete those challenges, I think they have 20 of those cool hoodies and t-shirts available for distribution I assume it's some kind of a lottery based on everybody who submits. Okay. Someone mentioned an ultimate guide. Maybe it was on the Discord. So obviously, if you're here today, you'll be watching the 11 talks that are in today's live stream. But we also categorized all the talks on this ultimate guide. And
so we have just quickly, right? Like we have 4 amazing keynote speakers. We do have AI is a thing. So we have like 7 AI tracks, core Postgres related stuff, ecosystem talks, which are extensions and related Postgres talks, and then 8 talks on Azure database for Postgres, and 4 Postgres community talks as part of this. And Posette Gate has more details around this.
Awesome. Okay, so our live stream speakers, our keynote speakers, we're super excited about. We're about to hear from Charles Feddersen, and tomorrow, or rather tonight, or depending on where you are in the world, live stream 2, the keynote speaker is Regina Obey, who is an expert in PostGIS and the open source geospatial world. Live stream 3, Sarah Novotny, who's going to share her learnings and experiences working in the Kubernetes world, to see how some of those experiences might influence those of us in Postgres. And then live stream 4 is a history and walking tour of Postgres from Thomas Monroe, who is a Postgres committer who works at Microsoft, absolutely brilliant technologist based in New Zealand. So we're excited about all of these. We're going to dive into Charles's keynote in just a sec, but I want to quickly tell you about the surveys. There are 2 QR codes showing on the screen. We'll pop this up a few more times during the day. But as you watch talks, you can fill that talk survey out multiple times, like once per talk. So if you have immediate feedback, speakers love it. So please feel free to use it. The event survey on the right, that's a one and done kind of thing. So you can do that as you're done participating in the event, just to let the organizers know how they did with the organization. Cool.
One quick tidbit on that: we should refresh after every submission. We should refresh so that a new talk, if you want to submit the talk survey. Yep.
Yeah, for the talk survey, it's kind of one talk at a time. So if you want to give feedback on a second talk or a third talk or a fourth talk, you just need to reload the survey and do it again and select from the pull down menu a different talk. Exactly. Okay. So we're going to look at the schedule for the live stream, so we can go ahead and do that really quickly. I just wanted to say that if you go to aka.posette -schedule, you'll end up on a page that looks like this, and you can scroll down and you can look at all of the talks that are coming today. We've got some great speakers, some great topics in the lineup, and each of these opens up, and then even from there, you can click on to get to the speaker page. And in some cases, speakers have filled out speaker interviews, which is kind of interesting, get to learn more about their background. But right now, I think we want to get into, the keynote. So let's go ahead and introduce Charles. Charles Feddersen is my boss at Microsoft. He is Partner Director of Product Management, which includes Azure Database for Postgres, the managed service. It also includes product leadership on all of our open source efforts for Postgres. He's originally from Australia. You'll detect a small bit of an accent there. And he told me last night as I was preparing that he's pretty boring. But when it comes to increasing Microsoft's investments into Postgres, I think he's anything but boring. And his talk today, his keynote today, is titled All the Postgres Things at Microsoft, the Posette Edition. And with that, let's go.
Hi, everybody. My name is Charles Feddersen. I'm the Director of Product Management for Postgres at Microsoft. In my talk, in 25 minutes or less, I'm going to try and cover a variety of things that Microsoft is doing in Postgres, both our commitments to the open source aspects of Postgres and also what we're doing in the cloud. I hope you can join. Hi, everyone. So today, I'm pleased to talk about all the things that we're working on with respect to Postgres at Microsoft, or at least most of them, given the time that we've got. This is actually an updated talk from or an evolution, if you will, of a talk that I gave at Prague last year at PGConf EU. Now, before we get started, I'd like to spend a moment on Posette itself, because this is actually the third year hosting the virtual conference. As I'm sure you're aware, it used to be called CitusCon, but when Microsoft acquired Citus about 6 years ago. And it was quite notable at the time, I think, because Microsoft wasn't broadly recognized as a significant Postgres vendor. And then post-acquisition, of course, we continued to invest heavily into Citus, which inevitably led to the branding of CitusCon. But at the same time, we were starting to contribute more into different parts of the Postgres ecosystem as well, and of course, core Postgres itself. And so after a couple of years of running CitusCon, it became apparent to us that we needed a conference that offered a broader scope. And so last year, we decided to rename the conference to better reflect the totality of the Postgres work we're doing at Microsoft. Citus, of course, remains core to our work, but we're also contributing to other parts of the Postgres ecosystem and, of course, Postgres core database itself. So we spent a lot of time brainstorming and debating names. In the end, we decided to abbreviate what the actual intent of the Postgres conference would be. Posette stands for Postgres Open Source Ecosystem Talks, Training, and Education. Our intent is that the conference provides a platform for the entire Postgres community to talk about anything related to Postgres under a brand that is inclusive of all of Postgres. And judging by the community entrance we've had in the conference this year, we feel like we've made a really good decision here. Now, moving on to the agenda, I'm going to split this talk into two parts. The first part is about some of our recent open source work, and then I'll talk about some of the latest capabilities that we're lighting up in Azure Database for Postgres Flexible Server, which is our managed offering in Azure. First, however, I'd like to acknowledge some of the work that our organizing committee has done, and they've put together an awesome conference. Events like this don't come together overnight. And I remember when we were talking about the conference name probably 8 or so months ago now, the team really picked it up from there and has accelerated ever since until they're landing the conference here. I'd like to thank Teresa, Aaron, Ari, and Aaron, who have been working around the clock, and probably a little more around the clock than I would have preferred on a few occasions, to bring this virtual event together. I think it's come together fantastically well. You've done an amazing job, so thank you. Now, on the topic of thanks, I'd also like to thank our speaker selection team of Claire, Alicia, Danielle, and Melanie, who had probably the most difficult job, where they had to evaluate the 184 talk submissions that we received and finalize that into the 38 talks that were accepted. For those who submitted, we know it takes time and effort to put a quality submission together, and we're grateful for the effort and the interest that you've had in speaking at the conference. This is one of the hardest jobs to decline speakers who have really interesting content to share. We've already started talking about how we can expand the conference next year to make it even bigger and enable us to accept more talks from the community. And speaking of metrics, just to expand on that a little, I mentioned the 184 talk submissions. They actually came from 120 unique speakers. It's the most submissions we've ever had in the 3 years. And I'd like to think that, as I mentioned, it's in part due to the rebranding of the conference to be a little more explicit that it's open to all of Postgres. Ahead of the event, we had over 8,000 website visitors to the Posette site, and over 4,000 people have explicitly added the event, and hopefully a lot of them are joining today. We feel really good about these numbers, and at the same time, every conference sets a bar for the next year, and we're looking forward to trying to exceed that next year. Now let's switch gears to some of the things that Microsoft's contributed to open source in the past 12 months. At the top level, the best place to start is always with numbers and data, right? We're database people. In the past year, as of about the end of April, engineers at Microsoft had actually made 353 commits spanning a wide variety of features and functional areas of Postgres. And this includes work done solely by the committer, work that was co-authored by a committer at Microsoft with somebody else outside of Microsoft, all committed on behalf of another person in the community who actually authored the patch. And I think that last category is the best because it's reflected in the second box, where 27% of the commits that Microsoft engineers made were on behalf of other people. And I think that's really important because it reflects how community-led Postgres development is and how it enables Postgres to benefit from the larger engineering scale of a big population of developers while also maintaining the checks to ensure the quality remains high. Additionally, 331 commits were authored or co-authored by a contributor at Microsoft, but some may not have been committed, of course, to Microsoft engineers. So the numbers don't perfectly overlap there. These range from some of the more high-profile features, such as streaming I/O and query planner enhancements, through to smaller but no less useful improvements, like performance improvements in PG upgrade, wall optimizations, and maintenance of Postgres continuous integration. Now, with respect to streaming I/O and the query planner, etc., I want to expand on these a little, because the streaming I/O improvements are another forward step towards asynchronous I/O in Postgres, which has already been a multi-year effort. In Postgres 17, streaming I/O enhancements can combine page reads, which enable a single read of up to 16 pages, or 128 kilobytes, rather than single pages of 8K only. Incidentally, it was during this performance testing feature that Andres actually discovered the backdoor in XZUtils, which ultimately made some headlines in a few places, as many people know. The work for Streaming IO will show up in performance for some features like sequential scans, and the analyze command will also be more performant in Postgres 17 due to the work that we've done on Streaming IO. And as I mentioned, the ultimate longer goal is asynchronous IO, and work continues for that into Postgres 18. Now, with respect to the query planner, the changes in Postgres 17 can improve performance quite significantly for queries with the union clause, because Postgres will now be able to use pre-sorted input to eliminate duplicates, whereas it previously used things like a hashtag or another approach. There's also improvements in the redundant is not null queries as well. With respect to the performance and developer ecosystem, Microsoft has also made contributions. These include vacuum improvements that have reduced the size of the wall by up to 30%, and writing and syncing while records may actually improve by about 15% or more in performance. There are also memory utilization improvements to sort and minor performance improvements to memory allocation. There are also performance improvements for queries involving highly partitioned tables. And as I recall, this is actually one in particular that was inspired by a real-world bottleneck that we hit with a customer that was trying to run Postgres in Azure over highly partitioned tables and was seeing performance impediments. And finally, amongst many other features that I don't have time in this session to talk about, there are performance improvements made to check the phase, in the check phase of PG upgrade, which can yield up to 2x faster completion time. And that's important because the check phase is often repetitively run as you're preparing to move things around. Outside of core Postgres, we've also contributed to Patroni. There's been a couple of version bumps on that one in the past 6 months, commonly used for HA. We've contributed to PG Bouncer, widely used for connection pooling, and PG CopyDB, which is a tool that we actually use ourselves quite extensively internally. It effectively automates moving data between servers using PG Dump and PG Restore. And we've made a load of improvements to this, particularly for scalability, and I know there's a lot more planned in the future as well. Now, moving on a little bit more, I want to talk about what we're doing in Azure Database for Postgres Flexible Server. This is Microsoft's fully managed Postgres service in Azure. And some of the recent announcements that we've made in Build are some of the things that I'll focus on today. I also talk about one big notable roadmap feature that we're working on in the next couple of months. Now, it may actually sound a little counterintuitive, but the sheer popularity of Postgres and the breadth of use cases it addresses actually makes it non-trivial to build a cloud service that addresses all of our customers' needs. There are so many different personas and use cases. From a demand perspective, it's a great problem to have, but it also makes us think really carefully about how we can address all of our potential customers. Developers love Postgres for its extensibility, application portability between different Postgres platforms, and rich ecosystems of SDKs for building apps. And of course, I should call out the AI capabilities. A PG vector that enables you to store, index, and query embeddings is a particular point of interest for developers right now, and we're definitely seeing that. On the other hand, Postgres popularity in the enterprise is also surging. So you've got developers and you've got the enterprise, and that's especially in the cloud. But the feature checklist for onboarding Postgres into the enterprise is incredibly different to what developers are looking for. I think this slide tries to show you that. It always starts with security, followed by high availability, disaster recovery, and the one common thing that everyone looks for is performance. So what makes this so hard to build? Well, because every engineering team has finite resources. And when the opportunity is so large to address such a diverse customer base who want to build so many different things using different parts of Postgres, we've got to think so hard through what we can build to help both ends of this customer spectrum and everybody in between to be successful on the platform. Now, to address these diverse requirements, our investments in Flexible Server in Azure over the past 12 to 18 months, have really been anchored in two distinct pillars. The first is what we call enterprise readiness, which represents basically that adoption checklist that I just mentioned. And the second, I'm sure unsurprisingly to everyone, is AI. At PGConf EU last year, I gave a short talk where I mentioned that Postgres had a head start on the database industry for building AI apps due to the convenient and perhaps coincidental existence of the PG vector at the time that ChatGPT took off. That statement definitely held well so far because we're seeing a lot of new apps building on AI functionality. But all of these apps still need enterprise readiness when they get to become production workloads. And that's where we think about enterprise readiness. So when I talk about enterprise readiness, I'm talking about the functionality that customers need to run production workloads. Regardless of whether you're a big enterprise, a small enterprise, all of these things are important. Sensitive data must be protected. Uptime is critical. And so this is where we've placed our investments recently. The cloud is one place that makes this so much easier. I'm probably going to date myself here a little bit, but once upon a time, I remember configuring, RAID on disk arrays, installing redundant NICs and servers, trying to eliminate every single point of failure between the CPU and the power socket in the wall. There's probably a few people who can relate to these as well. The requirements for high availability and data security have not changed. We just try to make them much easier in the cloud so that you get them out of the box. So let me expand upon these a little bit. First, we added first-class support for Microsoft Entra ID, formerly known as Azure Active Directory, which enables companies who have standardized on Entra ID to use the same login for their users when they're connecting to Postgres. And what's notable about this is Postgres in Azure is actually the only Postgres service that offers Entra ID today. With respect to network security, we actually take a two-pronged approach to this by implementing two different types of network security depending on your configuration preference. The first was virtual networks, which enables you to effectively embed or inject the Postgres service into your existing virtual networks that you had. And recently, we announced the general availability of Private Link, which provides dedicated Private Link at endpoints for connecting to your Postgres servers in Azure. And since the launch of Private Link, we've seen incredibly strong uptake from customers who are using that as their preferred secure networking configuration. For data encryption, customers can use service-managed keys provided by Microsoft, or they can use their own managed keys. We call them customer-managed keys. And they can be stored in key vaults, which are either the more traditional vanilla key vault, or even using HSM secure key vaults, which stands for hardware security modules. The service supports Azure Defender, which protects from a variety of SARs, but in particular brute force attacks. And high availability is provided using synchronous failovers between availability zones, which protect from zonal outages and automatically fail over with zero data loss. You can enable geo-recovery or failover by promoting a replica into any other region of Azure. And we recently shipped virtual endpoints with planned failovers. So now you can do this without any change to the connection string in the application and without any data loss as well. Now, performance I'll expand upon in a minute. But finally, Azure Policy is a capability that enables you to define policies on how the service can be used, and Azure Advisor, which gives you recommendations on optimal configurations for the service. It may seem pretty simple when you represent these big enterprise requirements in only 10 icons on the slide, but in reality, there's a ton of engineering effort on us that goes into delivering these capabilities, and we know it removes a lot of heavy lifting from our customers as well as they're productionizing their Postgres workloads. Now, by far and away, the most common test for any customer when they're evaluating a database is performance. Performance is a defensible measure. It's incredibly easy to measure. And it doesn't matter whether it's the first workload that you've ever run on this platform or your experienced customers and you just want to verify a particular workload before you migrate it. Performance is always one of the most critical measures. One of the things that we've done recently is introduce RDMA to be the default protocol for connectivity between compute and storage. And we also introduced the premium of SSD v2, which will bring to general availability a little later this year. And this increases your storage to 64 terabytes and your IOPS up to 80K. But when it comes to designing the database schema itself, this is where the art is. There are no free lunches in defining database schemas. There are always trade-offs. One of the closest things I have ever found to building databases, the silver bullet, if you will, is indexing. But indexes are hard to maintain, particularly at scale. At the Build conference a few weeks ago, we announced the public preview of automatic index recommendations. And this is an incredibly powerful feature because it profiles the totality of your Postgres workload running in flexible server on Azure and advises on the index to create or drop. The index recommender can either create new indexes or delete existing ones, whether redundant or used, as you can see on the screen here. Because the feature analyzes the workload at the actual database layer itself, it doesn't matter whether you're being invoked from a function or the code's written to a function, it's hard coded into the application code, or dynamically built by the application at runtime. Automatic query tuning analyzes a production scale. And whether you have hundreds or thousands of tables, potentially tens of thousands of different queries submitted to the database every day, there's a huge productivity gain for developers or administrators who no longer need to manually profile or debug workloads to determine missing indexes. This feature was jointly developed with Microsoft Research. We're really excited to put this feature directly into the service and into the hands of our customers so that they can start to turn it on, see how they can potentially optimize their workload, and get immediate out-of-the-box gains from using Postgres in Azure. Of course, I couldn't talk about Postgres in Azure without talking about AI. AI has had an absolutely profound effect on the technology landscape over the past 18 months, and Postgres, the database, has found itself right in the middle of it, with this huge head start over other database platforms, due almost entirely to the PG Vector extension that enables Postgres to natively store, index, and query embeddings, as I mentioned earlier in the talk. This feature enables you to run a similarity search using embeddings, which could be used as a basic search result, using where you calculate the distance between embeddings, or using as contextual input into a language model in a more RAG-based application pattern. Last year at Ignite, we announced the Azure AI extension in Postgres, which enables customers to invoke models out of the Azure OpenAI service. And this is powerful because it gives you the choice of models that you want to run for your workload. And we're already seeing customers experimenting with different types of embeddings depending on the nature of their data. It also supports integrations with the Azure AI language service for scenarios such as sentiment and summarization. It integrates with Azure AI Translator for translating text, and Azure Machine Learning, where you can bring your own ML models, generate predictions using the data that you've got in Postgres. And in May, just gone by, we announced the general availability of the Azure AI extension. And so now it's available for you to use in production with the guarantees that come with being a generally available component. However, sometimes performance is the most important element. Like I said, every database is a drag race. And so your applications that you build need to have the best performance they can, and that includes creating or modifying embeddings. So build in May, we introduced a new way of creating embeddings using Postgres in Azure. We introduced the new extension called Azure Local AI, which leverages Microsoft's open source E5 embedding models, which are available on Hugging Face and other places, running locally in the Postgres service itself to generate embeddings in single-digit millisecond latency, as opposed to the remote invocation that we used previously. You can see in this video that the remote AI embeddings are running on the left, where it's making a call to service. That's what we shipped about 8 months ago. And on the right, the local model that we shipped in May, where the model's running in the engine. On the left, we're going to run about 600 times. On the right, we're running 800 times, as you can see in the commands. I don't know why we did different numbers, but immediately you can see the performance difference. On the left-hand side, we sustain around about 15 to 20 transactions per second, and it's still running, although it just finished. The right-hand side finished in a fraction over 3 seconds, with an average latency of about 4.1 milliseconds. When you get down to such low millisecond times, you can start to really confidently put these embedding creations in your OLTP application and know that it's going to sustain the throughput that you need. Now, before I wrap up, I'd like to share one other significant feature that we're working on right now and we're planning to ship soon. DiskANN is another amazing innovation coming out of Microsoft Research that provides state-of-the-art vector indexing. In May, we announced support in our NoSQL platform And we're working right now to bring the disk ANN vector indexing into Azure Database for Postgres Flexible Server very soon. So watch this space. Now, one of the most interesting characteristics about disk ANN is that it maintains its recall quality as data is added or modified to data. Basically, it maintains the quality of search results when you're running those similarity searches. What you can see in this chart is that the recall in HNSW, which is the current effectively state-of-the-art in PG Vector, declines as the index is changed, which means that embeddings are added or modified. Disk ANN retains that recall, which means your queries continue to return the most relevant information for your AI apps, which is really one of the most important considerations for building similarity search, but all for returning those results to your RAG-based applications. So that pretty much concludes what I had time for today. As you can see, Microsoft continues to be very heavily invested in Postgres, both in open source, where we made a couple of headlines earlier this year, as I mentioned, with respect to that backdoor. Also, the surrounding ecosystem of applications that I talked about, PG Bouncer and Patroni and PG CopyDB. There's a great blog that Claire Giordano and my team authored a couple of months ago now. Perhaps maybe we can put the link on the screen. I don't know about that. That gives you an exhaustive view of everything that we're doing in Postgres and Microsoft. We're also really active in a lot of the open source community events. I know we've got big events coming up in New York and I think in Greece this year. Microsoft should be out in full force in those as well. I look forward to seeing hopefully a lot of you there as well. We also continue to invest heavily in the cloud. We want to continue to make our cloud service more performant, more feature-rich, ideal for the enterprises who want to adopt it with that really high security and compliance bar, and a great place for developers who want to build those new apps and leverage all of the amazing AI capabilities that are lighting up in Azure. I appreciate your time today. Thank you again very much to all of our organizers and our speaker selection team. I think you've done a phenomenal job. As I mentioned, the conference has come together great. Thank you everyone else for joining. I think there's some great talks here. Please enjoy the rest of the conference. Thank you.
Well, that was fun.
That was
Nice,
awesome.
nice job, Charles. There's lots of conversation over in the Discord, which is great. And I think that's always a big part of any conference, whether it's in person or virtual, is that hallway track, if you will. I want to remind everybody that if they want to give feedback immediately after the talk, some people wait till the end of the event. Other people like to do it right away before they forget and their stack overflows. So there are the QR codes for giving feedback about talks. So there, my reminder work is done. Also, if you're wondering, where is this virtual hallway track that you're talking about? Where is the Discord? aka.ms/open source Discord is where you can find people, and you have to go to the Posette Conf channel once you get there. And that's where people are chatting about today's live stream. And all the speakers have committed to be present there in the Discord while their talks are being live streamed in particular. So if you have questions for them about what they're presenting, it's a great way to reach them in real time.
Cool.
Sound good?
Yep. So it was awesome to listen to Charles, and he took us through a lot of enterprise related stuff, AI, open source work that is going on, the new things that are coming in Discane, and those were really exciting to hear, and hope everybody enjoys.
I didn't know he was going to mention my blog post that I wrote about all the things.
I was about to say that we should post it out in the in the hallway track itself. A lot of folks would be interested in hearing about it, Claire.
What was interesting to me is after I published the blog post, I got a message on Mastodon from Alvaro Herrera about how I had overlooked one of Jelte Fennema-Nio's contributions into PG-17. And so anyway, I was arm twisted into going back and revising the blog post to make sure to add that commit into the mix. So it was nice. People were pretty excited about all the work that's in Postgres 17.
For people who don't know Alvaro, he's one of the top committers and an awesome human being altogether from all our experiences.
All right. So what's next, KK?
Yep. So next is tuning parameters in Postgres versus tuning your queries from Henrietta Dombrovskaya, who is a database architect at DRW Holdings in Chicago. Um, uh, she runs the user group in Chicago. There is an optimization, PG query optimization book she has written. Out of all of that, the closest thing that I relate to Hedy is that she is the creator and founder of PG Day Chicago, which I was fortunate enough to attend. That was an awesome thing, awesome conference. There's also the mix of folks who came into that was really insightful. We got I got to talk to people who are really trying out Postgres, who are already experienced in Postgres, who were Postgres hackers and some committers as well. So a variety of people attended Postgres, PG Day Chicago. I was very thankful for all that organization that she had done as well. So looking forward to understanding more on tuning parameters with her talk.
Well, and I know we both live in California, but I saw you at PG Day Chicago.
Yes.
We don't, I work at home. We don't normally see each other. So we got to get connected there. Hedy did a fabulous job.
The traffic was better in the cloud, traveling in plane versus Bay Area traffic. Cool.
Shall we go? Shall we do
Yep.
it? All right.
I think let's go.
Hello, my name is Henrietta Dombrovskaya. I am a database architect at DRW Holdings in Chicago, and also I'm a local organizer of Chicago PostgreSQL user group, one of the largest Postgres user group in the Western Hemisphere, and probably the longest continuously operating. And today I will be talking about Postgres parameters. The title of my talk is Tuning Postgres parameters versus tuning your queries. And why you would like to listen to it? Well, because in this talk, I'm going to debunk one of the most popular myths about Postgres, which is that tuning parameters can solve all your performance problems. Spoiler alert, it would not. So let's see. I spoke a lot about different things in Postgres, but I never ever presented any talks about tuning parameters. Other people did, I never did. So why I'm doing it now? Well, I was tuning databases, tuning queries for all my professional life. And I never questioned what does it mean, tuning your database. So I thought I knew what it means until I started working for Enterprise DB. And then I turned out that I actually did not know what people mean when they're saying, okay, tuning your database. So that's what I found. It turned out that tuning means tuning parameters. And I am coming to the customer with expectations I'm going to help them tune their slow running queries and stuff like this. And instead, I'm presented with the question, how we can tune our parameters. And that was completely unexpected. So why I never ever did it before? I can tell you why. Because, there are several reasons for this. So first of all, quite often, believe it or not, I was not in the position to tune parameters because I was not a DBA. I was a database developer. Quite often I was a consultant. Yeah, that was kind of beyond what I was allowed to do. So I always tuned specific processes, specific queries. And also I knew that no matter what parameters are, I can still do my job the best possible way. So it kind of never occurred to me that that is such a necessity to do something with parameters. Still, what I found recently, that people strongly believe in the magic of parameters. So what people think, that somewhere, we do not know where, but there is this sacred knowledge of, okay, so there's the magic set of parameters, and you need to apply it for your Postgres instance, and everything will start working like amazingly this very moment when you do this. So people still believe it. And it's easy. You feel it's so easy. It's so tempting to think that there is something in the world which allows you to tune your parameters and everything will be working. All right. So what I'm going to show you today, I'm going to demonstrate to you that whatever you're doing with parameters almost does not matter. I'm not saying that tuning parameters is useless. I'm just saying it's not that important that you might think. So I wanted to give this kind of talk for a while, basically since the time I learned that people believe in magic of parameters, and I always have had this situation that it's very difficult to demonstrate why parameters do not help. So why it's so difficult to demonstrate? Because when you tune the queries, you are tuning individual query execution time. And when we're tuning system, we're talking about improving the whole system for output, which is way more difficult to show, especially in a presentation. It's very difficult to model real-life workload. It is very difficult to model real-life concurrency. So building example like this is not an easy task. However, there are well-known facts, which I knew for a very long time, and these are the facts, that tuning parameters can improve performance maybe 10%, 20%, in some cases up to 50%. Actually, recently, I was able to tune one database which was completely over the charts, parameters were all wrong, and I improved the execution time 5 times, but that's like the personal record. However, when you tune individual queries, you can improve performance several tens of times. And it's worth noting that tuning application can improve performance up to hundreds of times. So again, those are well-known facts which are kind of like difficult to demonstrate in real life. So we will give it a try, and to demonstrate it, I will use query example, which uses Postgres database. So that's QR code for the GitHub. So if you are curious, if you want to replicate all the things which I'm doing here, you can install this database on your local Mac, on your Docker, or whatever you want. And here we go. So in this Postgres database, we are modeling the airline reservation system. And we have customers who are using it for purchasing tickets. And we model it also so there are people who are running reports, like running flight manifests and doing all sorts of things. So this query is a report. And let's say we just installed Postgres there. We did not create any extra indexes or anything. So it is what it is. So what we're doing here, we are selecting all the flights which are flying from JFK Airport to O'Hare Airport between August 8th and August 12th of 2023. And for each of these flights, we capture the flight actual departure and the number of passengers. So like normal query. So we run this query with default parameters by changing nothing. And what we see here, so default parameters in Postgres: shared buffers 128, work memory 4 megabytes, and that doing max parallel workers per get is 0, so no parallel workers. So the execution time is 2.5 seconds. You might say, oh, what's the big deal? This is actually a big deal because it's not gigantic database. So what you can see here, you can see that there are lots of reads, there are lots of stores. So you see that execution plan is not really perfect. So let's see how we can improve this execution by tweaking some of the parameters. So let's start from parallelism. So I think, okay, we want to add parallel execution, so we are increasing max parallel workers per gather to 2. So what we got here, yes, indeed, actually, we increased and we see that Postgres uses this parallel processing. So how does execution time change? Not significantly. It's becoming shorter, so now it's 2.1 seconds, but still it's not like drastic improvement in the execution. So let's look at other things. So let's increase work mem. So here is the thing which we're trying to improve. So we still have like 2 processes, and we still see that there are lots of sorting and things going on. So we're increasing work mem. Now we increase work mem to 500 megabytes, and the execution time is 1.8 seconds. It's improvement, right? Yes, it's improvement. We had like 2.4, now we have 1.8. But that's basically we reached the rock bottom. So now no matter how much we increase work mem, we are stuck on 1.8 seconds. And by the way, you know what? In real systems, so remember we're talking about the whole system optimization. So through output should be like something significant. So we cannot allocate 500 megabytes of memory for each process, because then we will run out of operation system memory very, very soon. So, okay, second thing. So remember we saw lots of these buffer reads. So now let's increase shared buffers. And if you're modeling it on your local Postgres, you know it requires restart, but okay, we can do it on our local Postgres, so now Docker container, all is good. So we increase shared buffers to 1 gigabyte, and we try different work mem, 4 megabyte, 100 megabytes, 500 megabyte. So execution time improves. It's like 1 second now. All right. So we had 2.4, 2.1, 1.8. It's like 1 second now. Amazing. But again, here we hit rock bottom. So no matter what we are doing, actually funny story, when you increase shared buffers even more, you will get a little bit slower performance. But again, there are reasons for this, but let's not focus on it. So basically, we cannot make it less than 1 second, which, believe me, is pretty long time for this query. So we used all the possibilities how we can improve this query performance using parameters change. Okay, so let's try something different. Let's look at the execution plan again. If we look here closely, we can see that we have heap scan for the departures between August 8 and August 12. So let's create an index. We're creating index on actual departure. And when we create this index, now we notice that execution plan drastically changes. Now it uses index. And all of a sudden, execution time, look at this, 0.7 seconds. So we made improvement. We actually were able to decrease it for less than 1 second. Amazing. But still, can we do better? Actually, we can do better. So now we still have something else to improve in this execution plan. So we are improving this heap scan on the number of passengers. So by building the index, we are creating index on the passenger table by booking ID. And now you can see the execution plan start to use this index. And now the execution time is 60 milliseconds. So all of a sudden, with this one correct index, we improved execution time 10 times. So we could not reach it with the parameters changes. And now guess what? What do you think will happen if now we will go back and return all our configuration parameters to default settings, which are actually very approximate, not so good. So can you guess what happened? I bet you guessed, right? The execution plan will remain the same, and the execution speed will remain the same. So now we got it back and nothing really changed. So, all right. So, does it mean that parameters are completely useless and you should not spend time even trying to improve them? No, it definitely does not mean it. So what is the role of configuration parameters? The role is to communicate the hardware characteristics to Postgres, because Postgres runs on a machine, and Postgres itself, when it runs, has no idea what are the hardware characteristics it's running. So by sizing configuration parameters properly, we can help Postgres to plan execution better. Let's look at a couple of examples. Imagine that you have 16 gigabytes of RAM on your machine, and shared buffers are still default shared buffers. So the size is 128 megabytes. So what will happen? Postgres won't be able to use it. So if you would look how it uses memory, so it will still swap blocks on and off, and it will take more time. So memory will remain unused. On the other hand, if you will give Postgres the parameter shared buffers for gigabytes, you will see that execution will improve dramatically because now it can use all the memory which it already had. It just did not know. Then on the other hand, work map, which is very important. That's how much each individual session can use when it plans like joins, hash joins, sorting and stuff. So work map, we still need to make sure that it's sized this way that we never run out of the operating system memory. So we can do, work map 200 megabytes, and we can create a max connections, set up max connections to 1,000. So what will happen if all of a sudden we will actually have 1,000 connections and each of them will use 200 megabytes? We will run out of memory, and that will be also not a good idea. Or another parameter, let's look at the random page cost. So what does this parameter mean? This parameter means that how slow would be for Postgres to read data randomly, meaning using index rather than doing sequential scan. Because, okay, we want to use indexes because they help us to select specific records which we want to read. But also it means we are not reading this sequentially, but we are reading it in random order. So when Postgres set up random page cost 4, what it meant that at that time, disks were much slower than they are now. And what we are doing nowadays, the first thing we are doing by changing this random page cost from 4 to 1.1, because now we are saying that Postgres can read disks randomly very fast. In this way, we help Postgres to choose execution plan which is better than it used to be. So this is the goal for the parameters. Parameters help us to use everything we have, but it does not help us to increase performance of specific queries. Now, last thing I wanted to mention. What we have when we're saying that application changes can actually make our applications to run really, really much faster, maybe hundreds of times. And yes, I always talk about my norm system, which allows you to completely rewrite the way application talks to the database, but it does not have to be something drastic. So, for example, oftentimes I see in the applications people use like this approximate condition, and do we really need it? Or you are fine, you can use equality. And you know what? When you start using equality, all of a sudden you can use indices and execution time drastically improved. Or like, for example, very often when people want to select the time, which is within one date, instead of using created date between this and that, they are using truncate created at to current date, and then what happens? The index on created at cannot be used, and queries are running way, way slower than they should be. Other examples are committing each record after insert, or the other example on the other side of the spectrum, not committing until the batch ends. So all of these changes, they seem to be really minor, but at the end of the day, those are the ones which really makes applications run really fast. So that's what I wanted to share with you. So again, moral of the story, we are not abandoning Postgres parameters changes, but when we tune queries, we are getting much better performance gains. Thank you so much.
Well, that was awesome.
Yep.
Lots of discussion about work mem over on the Discord on the hallway track.
The way that talk is aligned, right? Like parameters versus query tuning versus application tuning, the way that Eddie structured it, just too good. Right?
Yeah. She's such an expert, and it's wonderful that she shares her expertise so willingly at conferences, both virtual and in person. Okay, so we have a video trailer that we're going to share before we introduce the next speaker, and this will give you just very short 20-second snippets of the talks that are coming in Livestream too. So let's dive in. Let's watch this trailer. I haven't seen it yet, so I'm really excited to see what Isaac put together.
Cool. Let's go.
Hello, I'm Regina Obey, and today I'm going to talk about the open source geospatial community, Postgres, Postgres, and how Postgres joins the two.
Hello, I'm Heikki Lindengas. I've been working on Postgres and traditional databases for a long time. Today I'm going to talk about the vector data and how vector data is different from other kinds of data.
This talk might be interesting to you if you happen to work with PostgreSQL, if you want to learn how to employ recent developments in machine learning models into your PostgreSQL applications.
I was a former intern in Citus in 2022, and a part of this talk will actually address a part of the work that I did as an intern in Citus. Mind you, I was completely new into databases. I never heard about PostgreSQL, and I barely knew anything about any software engineering practices. So if you are also a beginner, please stay tuned for this talk because it might be interesting for you.
Hello everyone, I'm Marco Slot. I'm a software engineer at Crunchy Data, and I'm going to be talking about data-intensive Postgres, 3 ways to scale, or rather 3 different types of workloads that you might struggle with on Postgres if you have a data-intensive application.
Hello, my name is Silvano Coriani. I work in the Azure Postgres team, and I'm here to present about high availability and disaster recovery for Azure Database for Postgres.
So I'm Chris Ellis. I'm kind of head of technology here at Next Team, and at Posette 2024, I'm going to be talking about JSON-B with Postgres still needs some form of schemas, right? And this is a talk very much about dealing with those kind of situations where you don't really know what data you're storing all the time, or you're just dealing with kind of quite complex data structures that you don't really want to just map into tables.
And the story that we are going to see is not the typical presentation with the slides and bullet points. This one is a storytelling, so it's a different format. And we were going to go together with Monica De Bea, a tremendously talented support engineer, who is going to investigate together with Kevin and Dirk about a problem that Dirk has with his project with synchronous replication. So we are going to go step by step until we find a solution to Dirk's problem.
And we're going to be discussing neurodiversity and how it affects interactions within the workplace and the IT community in general.
And I had just given an internal talk about my ADHD diagnosis and how I've been basically coping with something that I, had all of my life, but I only found out about fairly late in life, right? And asked if we could do a talk about it together. And we talked some more and figured we should submit something to Posette.
Today my talk is about how we can accelerate migration to Postgres on PLP/GSQL when we are migrating away from commercial engine like Oracle or SQL Server.
Hi, my name is Ryan Booz, and I'm excited to be talking about PostgreSQL partitioning at Posette this year. Now, as our databases continue to explode with more and more data every day, partitioning is key to really understanding how to manage both performance and maintenance of your database. And I can't wait to talk to you about it.
Oh, that was good.
Exciting talks.
I haven't seen most of the talks yet, so yeah, getting these little teasers is kind of fun. Okay, so for people who want to submit survey feedback about talks like Hetty's right away, rather than wait until the end of the day until everything blurs together in their mind, I just dropped the ak.ms links back up there for survey feedback. But really what we should be doing right now is introducing the next speaker, right, KK? Am I on track?
Yep.
Okay.
Yep. Let's.
All right. So Jelte Fennema-Nio is a principal engineer on the Postgres team at Microsoft. He's based in the Netherlands. He has worked on the Citus extension for years, and he's also a PG Bouncer maintainer and a Postgres open source contributor. Jelte is going to be a co-host for Livestream 4 of Posette this year, along with Boris Mejias. And his talk title is about prepared statements in combination with PG Bouncer and Odyssey and Supervisor. And we should just dive in. Let's go.
Hi, I'm Jelte. I'm a principal software engineer at Microsoft, and I'm also the maintainer of PG Bouncer. And I'm going to talk to you about connection poolers and their support for prepared statements. One of those connection poolers being PG Bouncer. If you have no clue what connection poolers are or prepared statements, or if you do, for any of you, this talk is perfect to watch. So yeah, we're going to talk about comparing connection poolers and their support for prepared statements. But wait, what are connection poolers, for those of you that don't know yet? Well, in short, we want to solve this problem. Postgres gets many connections from different clients. And when it does, it goes boom. Because Postgres doesn't like many connections. That's what this slide is supposed to tell you. You're not supposed to read any of it. You can if you want. My slides will be available. But the gist of it is many connections is bad. So that's why we have connection poolers. And a connection pooler sits in between Postgres and the client. So when a client connects, it connects to the pooler instead of to Postgres directly. And when it then sends a query, the pooler will open a connection to Postgres, and it will forward that query over that connection to Postgres. And then when a client opens another connection and sends another query, in this case delete, that delete is not instantly sent to Postgres. Instead, the pooler will wait a bit until the select is finished. And only then it will send the delete over the same connection that it had previously opened. So this way, the same connection can be reused multiple times, and Postgres has fewer connections connected to it, even though your client can still open as many connections as it previously did. All right, so now we know what connection poolers are. But what are prepared statements? That was the other part of the title of the talk. Well, prepared statements, they are similar in the sense to Postgres, to connection poolers, is that they improve performance, but they don't improve performance by reducing the amount of connections. Instead, they improve performance by sending the same query if you want to send the same query more often. Because if you send the same query many times, but slightly differently, Postgres needs to do parsing and planning every time. In this case, you would send a select, and the ID is almost the query is exactly the same, but only the ID that you're filtering is going to be different. And still, this parsing and planning needs to be done over and over and over. So instead, with prepared statements, you do a prepare and you give it a name. The prepare is you give it a query, the select where ID, and you give it a placeholder. In this case, the $1. And you give it the name myAwesomeQuery. And then you can execute it by passing an argument to this prepare statement. So it's basically like a function, only for SQL. And the benefit of that is that now parsing and planning happens only once. It happens in the prepare phase and not in the execute. So now you only do one prepare and one parsing and one planning, and you have less CPU usage on Postgres. But why is it difficult with transaction pooling? Because it sounds nice. The more performance is always good. But why can't you combine the two? Well, it's kind of hard because connection poolers specifically transaction poolers, you reuse the same connection to Postgres. And prepared statements, they are unique at a connection level. So if you do a prepare p1 equals select on one connection to the pooler will open a connection to Postgres and will forward that. And then Postgres will remember for connection 1, p1 equals select. But then the second client is going to send prepare p1 equals update. And the pooler is again going to forward that on the same connection, just like we saw before with the select and the update. But then you get this error saying p1 already exists because on the same connection, the same name cannot be reused. The same name can be reused on different connections, but not on the same one. So now the other client goes away after this error, it disconnects, and we wait a little bit. And then the pooler will close the connection to Postgres. It does this to reduce the chance of leaking memory or other things. And that helps a lot with with making sure that memory usage on Postgres doesn't grow for very long-lived connections. And it will send p1 execute. And the pooler will now forward that execution on a new connection. But because Postgres doesn't know about it, you get an error. So what options do we have to fix this? Nowadays, all these connection poolers support prepare statements in some form. PG Bouncer is one connection pooler. It's almost the oldest one. There's only one older than this, but it's not a transaction pooler. Odyssey is the one after that. PGCat is one of the new kids on the block, and Supervisor is really new. Odyssey is the first connection pooler that introduced the design that made this prepare statement problem go away. The way it does it is by doing this. When it gets prepare p1 equals select, instead of forwarding it directly to Postgres, it will keep a mapping in the pooler layer. So it keeps its own little mapping. C1, connection 1 has p1, and that means select, and we will give that its own unique name as p1. And we will use that name to prepare it on Postgres, not the name that the client gave. So Postgres will now store it as connection 1, sp1 equals select. Now when the other client comes along and again sends p1 equals update, that is saved as connection 2 has p1 equals update, and then we will give that the name sp2. And then we prepare sp2 update. So now we don't get this error saying p1 already exists because we gave it unique name. We gave each statement a unique name. Success. And then there's the other problem. If we wait a little bit and the connection again goes away and Postgres removes its cache, what happens if we send exec p1? Well, Odyssey will open a new connection and it will forward prepare sp1 equals select. Instead of instantly forwarding exec p1, it will first prepare the statement that it needs to prepare for it to be able to execute p1. So now on connection 2 to Postgres, we have again sp1 equals select, even though the client never executed p1 equals select while this new server connection was created. And then only after it's created, exec sp1 is sent to the client, to Postgres. And again, success, no error this time. So now we have something that works, but we also want it to be fast. So let's try and optimize this a little bit. One huge optimization that can be done is reusing identical prepared statements across connections. And this is done by Odyssey and PG Bouncer. The way this is implemented is by sending, again, prepare to Odyssey, and then storing that in Odyssey again, in the connection pooler, and then preparing it and sending it to Postgres. And then when a second client comes along, preparing the same query, possibly with a different name, instead of creating a whole new entry and a whole new unique identifier, instead this P2, which is the same query, the same select query as P1, it will link to the same identifier and the same query. This reduces memory in Odyssey, but it also reduces the amount of prepared statements that need to be prepared on the connection. And this is a problem that PGCat has. It will re-prepare every statement, even though it was already prepared, on every connection for every client, every time it needs to execute it. It thinks all prepared statements are unique. And that causes a lot of memory bloat because of this duplication of prepared statements. So there's another thing we need to talk about, which is protocol level versus SQL level prepared statement support. There's two ways of sending prepared statements to the server. One is using the parse, bind, and execute messages. Parse is basically prepare this SQL string and give it a name. Bind is, these are the arguments, and execute actually executes the statement. And these happen at the protocol level. So they are part of the Postgres protocol. The SQL statements are instead prepare and execute. And you can just type them in pgadmin or pSQL and do prepare and then some query and give it like prepare some name and then a query and then execute. You can do the name and it will run that query. And these two different types of prepared statements, they're used for very different cases. The protocol messages, they're used almost exclusively by language drivers, programming language drivers. So if you have JDBC or for Java or PsychoPG for Python, any of them that can create prepared statements, they will use protocol level prepared statements. The only people or the only users sort of that use the SQL prepared statements are humans. They can type them themselves in the SQL command. But all these clients, all your applications, they will use protocol level prepared statements. And there's one big problem. Supervisor only supports SQL level prepared statements. So kind of the least useful of the two to support for any high performance application, because the prepared statements that you use as a human, generally you don't care so much if they're already prepared or not. You might want to execute the same query a few times, then it might be nice, but it doesn't happen super often. But applications can benefit a lot from this, because they oftentimes execute the same query over and over and over again. Like, for instance, getting user information, and just different for different users. And it's actually quite interesting that Supervisor only supports the SQL level prepared statements, because all the other three connection poolers that I showed before, pgcat, pgbouncer, and Odyssey, they support only the protocol level. They actually don't support the SQL level ones, mainly because then they don't need to parse SQL statements. And parsing SQL statements is not easy, so you need to spend CPU to do that. And not doing that is kind of nice, because then all the rest goes a bit faster, and your connection pooler has less overhead. But this is not everything. There's so many edge case bugs. While I was working on getting the prepared statements PR in pgbouncer merged, I ran into so many issues. Every client I tried to try the PR with found some other issues. And this is one of them. This one, I think, is on the Odyssey repo. This one is also one that can occur. basically you get you prepare statements that should exist, don't exist, or the client gets some messages back that it doesn't expect, or there's some other weird issues that happen. So there's quite a bit of weird issues. I reported a bunch of them to the other connection poolers, and I fixed all of them in PG Bouncer. But I'll try to explain a bit how these issues actually happen, and I'll show one on Odyssey where I know why it's happening. Most of them are caused by query pipelining. And what that is basically, instead of sending only one message at a time to Postgres, a client can send multiple messages in a batch, so that it doesn't have to wait for the latency round trip, so that it can send a few messages and then it can wait for a few responses. And normally that's all good, and Odyssey will work great with that. But if there's one case where it doesn't, and that's this case. So we've prepared two statements. P1, it's a typo, and P2 is a select. And we're gonna send the same message that the client sent to Odyssey directly to Postgres. The sync message is basically saying this batch is finished. So first it's gonna do the prepare, sp1 equals typo, then a prepare sp2 equals select, and then batch is finished. And we will also store that on this connection, we've prepared both of these statements. We didn't show that before in the previous slides, but because it wasn't super important, but it's very important here. So Odyssey keeps track what prepared statements have already been prepared on what connection to Postgres. This is important because it doesn't want to rerun the prepare. If otherwise it will get an error. But in this case, we get a different error. The error is typo is not a query. It's invalid syntax. So what then happens if the first prepare fails, the second prepare is actually skipped by Postgres completely, even though it might be super valid. Postgres will skip any messages since the first error until the next sync message. Until the batch is complete, everything after the first failure, it will just skip until the end of the batch. So now no queries are actually prepared at Postgres. But if we now prepare a new query on the client, prepare P3, and we want to execute it too. And then we're done with the sync again. We now have the same nice trick. We link these two queries together because they're the same select. So P3 will get the same identifier as P2. And Odyssey thinks, well, SP2 is already prepared on this connection. So I'm just going to execute SP2 and sync it. I'm going to not do any prepare because that would fail because it's already prepared. But Odyssey is wrong. It's not prepared. And Postgres says so. So these kind of errors are what you get. Statements not being prepared when they should be, or the other way around. And one really cool thing is PG Bouncer doesn't have any of these bugs. The prepared statement prepare has been out half a year, and there have been bugs reported or missing features. I fixed all of those, and now I think they're all gone. Hopefully, if you find any, please report them. But all of the test suites of client libraries that I ran, they all pass, at least in regards to the prepared statements. All right, so correctness is nice, but I mean, we also want it to be fast. If it's super slow, I mean, maybe we can handle a bit of incorrect problems in some edge cases or some weird errors sometimes. Maybe that's not a big deal. So, which one is the fastest? Well, that's sort of hard to say exactly, because PG Bouncer is a bit of a strange beast. PG Bouncer is a single process connection pooler. So it only uses a single thread. And that's why it's normally not super fast, as you can see in these slides, in this graph. is a lot slower than ODC and almost as slow as Supervisor. But pgcat is for some reason much slower. I reported this issue, and many other people found many other people in other benchmarks have actually different results. It's more closer to ODC, so it's a bit of a fluke. But I couldn't get any better results on my machine with the tests I was running, and because pgcat and ODC, they're both multi-threaded, so they are normally. pgcat is normally closer to ODC, and ODC is quite fast. A lot faster than plain PG Bouncer. But there's also multi-PG Bouncer, which is spawning multiple PG Bouncer processes at the same time and having and that way using multiple cores. So instead of having one process with multiple threads, you have multiple processes. And that's actually even faster than ODC. But this isn't even all without prepared statements. This is just normal queries. This is just as a baseline. So let's take a look at prepared statements and compare it against this. And you can see pgcat is now actually fast, sort of like we would expect, similar to ODC, a bit slower, but at least sort of in the same ballpark, not extremely slow. And in all of the cases, prepared statements are quite a bit faster than the normal not prepared statements. With plain PG Bouncer, because it's so slow normally, it's actually really, really fast. It's more than twice as fast with prepared statements. And in multi-PG Bouncer and ODC, they're 30-25% roughly faster than the normal statements. So it's really good. But as you can see, if you have multiple PG Bouncers, you can get the best performance with that. So, which pooler handles prepared statement best? Well, as always, it depends. If you can spend the effort to use multiple processes with PG Bouncer, then that's a great choice. If not, ODC is probably fine. You might hit some rare errors, but in most cases, in sort of the happy path, you shouldn't. pgcat has some weird perf bugs, and the memory bloat for prepared statements is really not great. So I wouldn't recommend that if you want to use prepared statements in combination with a connection pooler. And Supervisor is really, it's not really a choice at this point. It's no client is using the SQL level prepared statement, so there's really no point in using it for prepared statement because it basically doesn't support them. All right, thank you. Thank you for watching. Have a nice day.
Well, that was lovely. Thank you very much, Jelte.
So the details that Jelte brought out, right, like that's appreciated in the Discord channel as well, like how to objectively look at this, the different options that are there. If you're putting into production, what to think about, right? Like that's the takeaway that I got from this kind of. How about you, Claire? What was exciting about?
Well, I always enjoy Yelte's talks, even when he sounds tinny. I don't know what was in his room when he did the recording that made it sound tinny, but he knows his stuff. And so there's always something to be learned from it. There was a comment, though, that wasn't really about the mechanics of prepared statements and how they work with connection poolers, but that really resonated with me in the Discord chat, and it was from Elizabeth Christensen. And it was about a conversation that she and Jelte had at PGConf Dev a couple weeks ago in Vancouver. Yep. And it was about the naming for PG Bouncer. So inquiring minds are curious. Like some people were speculating, Jelte was thinking that it had to do with a bouncer at a bar. And then Elizabeth thinks that it harkens back to like old school web traffic routing.
Bouncing packets from, like network
where traffic
stuff.
is bouncing back from web servers. So anyway, if anybody knows for real, please join that Discord and comment in and let us know. But in the meantime, I think we have another video trailer to watch. Now, this is from Livestream 3, which is going to be happening same time as today's live stream tomorrow. So in America's friendly time zones. And I think there are 10 talks in that entire live stream, and we'll see little 20-second snippets of each. Are you ready, KK?
Last trailer was just too good. I'm just looking forward to watching this.
Okay. All right, let's do it. Livestream 3 trailer.
Hi, I'm Sarah Novotny, and I'm a longtime open source community contributor. I've worked in projects and communities like MySQL, Nginx, and Kubernetes, to name a few. And today I'm going to talk about Kubernetes and the different things that I have learned and loved from that project.
2 years ago, I gave a talk at CitusCon called Explain the Postgres Query Optimizer. And today I'm giving the follow-up to that talk, building on the basics of Explain the Query Optimizer, talking about all the other things that the optimizer does that I didn't get a chance to talk about 2 years ago. So I'm looking forward to this talk, and I hope you enjoy it too.
I help customers migrating their workloads to Azure, and I've been working with many customers around the world across different industries in complex PostgreSQL implementations, and I've been helping them in resolving their performance and scalability issues.
Hello, I am Pamela Fox, and I'm talking about PG Vector for Python developers. PG Vector is a great extension that you can use in order to store vectors in your database and then do distance operations on them. It's incredibly useful if you're doing any sort of similarity search, especially for generative AI applications like retrieval augmented generation, in order to search and chat with items in your database. So come to my session to learn more about PG Vector for Postgres and Python.
We are here today to walk you through a presentation on PostgreSQL physical replication, the internals of this, recent developments, and what sort of future work can be done around physical replication.
Hello, my name is Grant Fritchie. Today I'm going to talk to you about using Query Store to understand performance inside your PostgreSQL database. This is really important because unless you know what's happening inside your database and you know how your queries are behaving, tuning those queries and getting them to run fast is going to be really difficult. But Query Store inside of your Azure Postgres database will absolutely help you get it done. Come to the session, find out how.
Hello, my name is Taylor. I'm here to talk to you about Postgres, specifically task queues in Postgres, specifically how to implement and use them for great benefit so that you do not have to use something like PubSub or Airflow or Kafka, whatever those other things are. You could just use Postgres. It's very nice. So yeah, let's get into it.
My name is Denzel Ribeiro. I'm a principal product manager at Microsoft working on the Postgres service. And today I'm going to talk about 6 things you can do with the Azure AI and Azure Local AI extensions, which are first-party extensions. They greatly simplify building Gen AI applications on Postgres.
And today I'm going to give a talk on how to use Postgres views to revitalize your complicated or outdated data models. I think this is very relevant for software developers who are working in startup environments where your data model is constantly changing.
My name is Varun Dhawan. I'm a product manager with Azure Postgres team at Microsoft. Today, I'm going to talk about top features that make Azure Postgres great for developers. I believe this will be an interesting talk for anybody who wants to start developing on Postgres, whether community Postgres or Azure specifically on Azure Database for Postgres.
I kind of want to go make popcorn.
This was like
Yeah.
a real good movie trailer. Yep.
Yeah, it just gives me a little bite-sized inspiration to go watch these videos tomorrow as well and participate in the next live stream. Just a reminder that you can join the hallway track on Discord at aka.ms/open source Discord. And the speakers are present while their talks are being live streamed. A lot of people think the talks are live.
Yep.
And
It
but
just
they,
happened in the Discord, right? Someone was asking the echo we need to fix, but hey.
yeah, but that echo happened 2 weeks ago in
Yep.
Yelte's case. So Yeah, the speakers are present on the Discord while their talks are being live streamed. You can ask them questions. Please come join us. We'd love to have you there. So I wanted to pop that up. And then I think it's time to introduce our next speaker.
Yep. So I'm very excited to introduce Paul Copplestone, who's CEO of Supabase. This talk is also part of why Posette is so interesting, in the sense that there's a lot of engagement from the startup community. And Paul, as a lot of the folks know, is the CEO of Supabase, co-founder of that. He has been an serial entrepreneur in the past. He has a lot of visibility in the community, where he educates other folks on Postgres ecosystem. And all in all, an awesome human being from the talks that you listen to, as well as his journey, where he's has this sense of business and talks about other things like meditation and stuff. So it's like a calm, peaceful, but at the same time business savvy person, right? Which is like awesome to listen from. Let's get going on everything you need to know about Postgres Row Level Security. As all of us are interested, security is something critical, and let's listen and learn from Paul. Let's go.
Hi, I'm Paul, the CEO and co-founder of Supabase. Today I'm going to cover everything that you need to know about Postgres Row Level Security. I'll cover how to use Postgres Row Level Security, why you might want to use it, and some neat performance tricks. Let's get into it. So, as I mentioned, we're going to cover in this talk everything you need to know about Postgres Row Level Security. I've got a handy table of contents down the bottom, so if you're watching this in video format, you can just skip ahead. First of all, who am I? My name's Paul Copplestone. I'm the CEO and co-founder of a company called Supabase. What is Supabase? We are a Postgres hosting company. And if you use us, or if you're familiar with us, you'll know that we also host a bunch of tools that make it really easy to use Postgres. In particular, there is a tool called Postgres, which is a really cool open source project. And it helps you to serve a RESTful API on top of any Postgres database by automatically translating the database schema into a RESTful API. Postgres leverages Postgres very heavily, including the role system and row level security. And this is the reason why we have become very familiar at Supabase with row level security and have a few sort of insights over the past 4 years. We are also an open source company, and we've now hosted and launched over 1 million Postgres databases. So let's get into, before I get into it, just a trigger warning, I use some lowercase SQL in this. That's largely because the profile of customer that we were targeting in the early days was not so much of a database developer, so we decided to consolidate on lowercase to make it more approachable. So if you like uppercase SQL, I'm sorry. Okay, so what is row level security? You can think of it as really authorization for Postgres. And auth comes in 2 flavors, both authentication and authorization. And authentication tries to answer the question, is a user or role allowed to access a database? And then if that is true and they are allowed to access the database, authorization answers the question, now that they're in, what specifically are they allowed to access? And in this case, with Postgres, you can write some SQL function that can determine either a true or a false around certain sets of data that a user can access. I actually usually explain this to developers, or at least this helped me in the early days, was by using this mental model that row level security is an implicit where clause for your queries. For example, let's say that we are selecting from a profiles table where I'm actually only allowed to see my own profile. In this case, I have forgotten to put a where clause in. So ideally, I would have this
this security clause, which specified that me, user 1234, is only allowed to access this. And so this is what Postgres row level security is. You can attach a policy. I've got a very simple example, which I'll go through in a second. But the main thing that you need to know is that this where clause essentially is, this policy is essentially giving us this sort of where clause filtering. This means that if a user, in this case, user ID 1337, tries to access the profiles table and they don't actually have access to any particular row, then the RLS policy will get assessed for the profiles table. And because it does not return true in this clause, then they will essentially return an empty data set. So why would you use row level security? There are numerous reasons. The most obvious, of course, is security. And in security, there's a concept called defense at depth. And this really means that you add multiple layers in terms of your security. So you might have security at your front end, inside your application, your API, your middleware, all the way down to your database. The reason why I really like it at the database level is that it increases your default security posture, in that everything that's built, typically a Postgres database is kind of the bottom of the stack. And so that every application on top of the database will at least have the default security model of your database. So we think it's really important to put some data security at the database level, and then any tool which is accessing the data will at least take that security posture. The second reason is that you might increase performance in some cases. So in this case, typically what happens with an application is that it has to make, on the left-hand side, 2 requests to 2 different services. So an app might first make an auth request to an auth service, and that will validate that a user is allowed to log in and get their permissions. And then it might make a second request to your database to get the data itself. Now, if you can bundle that all into a single paradigm, then you essentially cut down one whole network request. So if you use it in that way, it's actually extremely fast. The other reason, and probably one that resonates for a lot of people listening to this, is just that you might be a bit of a Postgres maxi. We have a bit of a database-centric development workflow in Supabase, and that's one of the ways that we recommend using Postgres. It's not for everyone, quite honestly. But for those who really like SQL and really like the features of Postgres, then using row level security is a very neat way to develop applications. Okay, so let's go through the ins and outs of using an RLS, using row level security. It's actually quite basic. So here I have a table called profiles. All I need to do to enable row level security for this table is call altered table profiles, enable row level security. This means that anyone trying to access the table will get denied access unless they have a bypass RLS policy. Or you might be a super user, or you can be the table creator. For this reason, actually, I generally recommend that you enable RLS for most tables anyway, and it increases the default security posture of your role creation. You then have to specify bypass RLS, and you have to be a bit more explicit with your security on the database level. So even if you don't plan to write RLS policies, it's generally worth thinking about at least using row level security, turning it on for all of your tables. That's pretty much it. So let's go through the anatomy of an actual policy. First of all, we're going to call create policy, and then we give the policy a name. I generally like to use a small descriptive name in quotes. You can also use snake case as you typically would for Postgres objects. If you do use a name like I have here, then just know that it has to be relatively short, otherwise it will be truncated. Then from there, you will attach the policy to a particular table. So you just specify the table name and the schema. You will either have a permissive or restrictive policy. I'll go through this in a sec, but by default,
all policies are permissive. Then you specify the operation, which can be select, insert, update, delete, or you can have all. I actually don't recommend using all. That is the default if you don't specify this. I really recommend that you create a policy per operation, and I'll get into the reasons why soon. Then the policy, you can attach it to a Postgres role. I also recommend doing this for granularity and sometimes for performance. So you don't have to, but I really enjoy having very granular policies. Then finally, you can either have, you specify the actual clause inside either of a using or a with check. And I'll go through an example where we have both of these to explain it more in depth. But just from a high level, using, I like to think, we'll check the existing value that is in the database. So I'm going to validate against what is already there. And a with check will check the incoming value specifically for inserts and updates. So if I've got a value that's coming in, I want to check whether they should be allowed to insert this. First of all, we'll just focus on a using clause here for our select. So I will drill into this using clause here. Here I just have I'm selecting an auth function. This one actually exists inside Supabase. It's very common. This one's going to return my current user ID, UID, and then I'm going to validate it against the column inside the profiles table user ID. So what would this look like? Stepping through a really, really small example. Oh, yes, and it should always return a true or a false. And if it returns true, then I'm allowed access, false not. So here is my profiles table. I have 3 rows, user ID 1, 2, and 3, and I am user ID 3. So here I have my statement, and the select clause will actually validate that I am user ID 3. It will return that. And now we're going to assess against each row whether 3 is equal to the user ID. So first row, 3 is not equal to 1. Second row, 3 is not equal to 2. Third row, 3 is equal to 3. It will allow me to select this particular row. Now, I promised that I would show you also how to use these two, using and with check together. This is very common on a update statement. So first of all, we might, I've just copied and pasted exactly the same clause as I had before. But what we want to do is first check whether the user can update their own rows. So that is using the using clause. And then I actually want to also make sure that whatever value they're updating it to is also their own user ID. Otherwise, they might be able to change their own user ID within a particular table. So this is generally the way that you start building your policies. They're very granular and a lot of copying and pasting. There is an important thing to know about policies. You can actually specify 2 policies for one table. So here I have one policy for a select statement on which will deny access, returning false. And I have another one which will allow access, returning true. So you might ask, well, will these be ANDed or ORed together? The answer is that actually the access will be allowed by default. They will OR together. So there's one caveat to this. If you have a restrictive policy, then they will be ANDed together. Now, I find this very complicated. So my general recommendation around row level security is that you try to keep it really simple by creating one policy per operation per role, and then you put all of the conditions within that one policy. It really doesn't matter too much in terms of Postgres, but it really helps on the mental model for security, trying to make sure that you can focus in on one particular use case and write all of the logic inside that. Okay, so a few do's and don'ts for Postgres row level security. The first do, this one actually took us a few years at Supabase to realize. If you are calling a function inside your RLS policy, then you should try to wrap it in a select statement. You can see I've got a select and I've also got these brackets. The reason why is that on the right-hand side the auth.uid this function will be assessed for every single row, versus if I put it on the left with a select, then the Postgres planner will actually call that value first, and it'll only call it once. So generally try to wrap any function call into with a select statement. Also, as I mentioned, try not to use the default for all. I really recommend keeping your policies as granular as possible. So one per operation: select, insert, update, delete. The other thing is that here is that auth.uid function that we were actually calling, and this is roughly what it looks like inside Supabase. It's going to return the user ID from a JWT. Generally, you want these, or as much as possible, you want to write these functions so that they're stable, not volatile, and specifying that they're stable for the Postgres planner. This means that if they are volatile, then they have to be assessed per row in the database, so they'll get called many times. So for performance reasons, if you can make them stable, then they can be assessed once at the start of the query. Then if you are also using these functions, I generally recommend putting them inside a private schema and then creating these functions with a role which has bypass RLS. Then if you create them with that and you have security definer, it will assume the security posture of the person creating the function. If it is security invoker, and that role does not have bypass RLS, then actually anything you call within, let's say you're selecting the permissions from a permissions table, it'll also apply the RLS trickling down through each of the function calls. So because we just want to return a, say, data set, we can actually, in this case, use a role which can bypass RLS to return back the data set. And then inside the RLS policy, use the dataset to assess a true or false statement. And then finally, I know that I said, or I think second to last, I know that I said that you should, you can think of it as an implicit where policy, but for performance, you should always still specify your where statement when you're selecting from a table. I thought it was very cool at the start, actually, that you could just write blanket select statements and that it would only return the data that you had access to. But actually for performance reasons, you want the where statement because it will cut down the amount of data before applying the RLS rules. So it's very fast if you just have that filter to start with. Then finally, Postgres now has support for RLS in views. The way that this works is once again through security invoker versus security definer. So you can now specify views. I think it's from PG 15 and above with security invoker true. What this means is that if you are a security invoker false, whoever created the view, it'll assume their level of grants. Security invoker true will assume the RLS rules of the role, which is calling the table. So in this case, if my view is actually referencing private profiles, it will apply the RLS rules that we have attached to the profiles table. So generally, I recommend using the statement from actually almost always these days. There are a ton of tips and tricks. I've just covered a few of them, but we have some docs inside the Supabase docs with benchmarks of each one of the things that I've gone over and a few more, and how much performance gains each one of these actually will give you. Finally, I just want to give some shout outs. A lot of this content is derived from Steve, who is the maintainer of Postgres and works at Supabase, and also Gary, who did a lot of the performance benchmarking of RLS, and basically a lot of the community around Supabase who have really leaned into RLS. So just a big shout out to them. Finally, if you are looking for a Postgres database, then do check us out, and you can launch a new database with database.new.
That was awesome.
Nice talk.
Thank you,
Yes.
Paul Copplestone. Paul makes row level security seem simple, and it just made me start thinking about the fact that that's part of the benefit, the value prop, if you will, for Supabase, that KISS principle on steroids of really making things simple, easier to understand, easier to use.
I think that's also the reason why Paul was mentioning, right? Like converting non-developers to be able to use Postgres, the keeping it simple principle built into Supabase seems to have helped them a lot to bring that forward. And there were like a lot of folks who were appreciating the slides themselves, right? Like do's and don'ts put in a very structured way where you could think of it in production and look at this and understand what kind of things you should do for row level security improvements.
Yeah,
It was
that
an
side
awesome.
by side. Do
Yeah,
this, don't do this.
that was a hit. I mean, throughout. Cool.
And when you talk about people liking it, we're talking about the virtual hallway track, which is on Discord. You can
Yep.
go to aka.ms/open source Discord and go specifically to the Posette Conf channel when you get there. Also wanted to remind people that if you want to give feedback about talks as they happen, that talk survey can be completed once per talk, and speakers love it. They can't get better without feedback about what to improve. And of course, they put a lot of blood, sweat, energy, lost sleep into creating these talks. And so any positive compliments are also very much appreciated. And the event survey is more of a one and done for the organizers. And we do love that too. Let's see. Oh, swag. Okay. This is important. I have a banner. Let me see if I can pop it up. Okay. So there you go. There are limited supplies of some really cool swag. There are some socks. There are even more sticker packs. And so these codes that I just put up on screen, Posette-stickers- the numbers you see on the bottom there, will work for about 25 people if you go to aka.ms/Posette-swag. And there are more codes being given out on the Discord on the hallway track. So, but definitely worth trying to get because it's fun and it's cool.
It's as soon as I hear the word swag, both Claire, yours, and Teresa's, like the sticker and the socks is what pops up in my mind, right? From Citus time onwards, in all the conferences that we have got into it, it's awesome.
Well, and you would expect speakers to get kind of gifts. Like this is one of the gifts that went to speakers last year in year 2 of this event. It's this beautiful hand crocheted pink elephant. But I think it's fun when attendees can get some cool stuff too. Okay, let's move on because we've got some great. Well, first the Cloud Skills Challenge. I saw that Sarah Conway over on the Discord has already completed one of these skill challenges. But if you are looking to skill up on Azure Database for Postgres, these have been created by the Microsoft Learn team and should be pretty useful. And let me turn off the banner so that you can actually see that URL, aka.ms/Posette-CSC for the Cloud Skills Challenge. And gosh, I feel like we're doing a lot of promotions, but we need to show more about upcoming future live streams. And we have this video trailer about all the talks that are coming in Livestream 4, which is on Thursday morning in CEST time zone. So that's Europe, Middle East, Africa friendly time zones. So let's check it out.
My name is Thomas Monroe, and I'm going to be talking to you about the Postgres project, or PostgreSQL, where it came from, what sorts of things it does, how it is made today, who makes it, and a bit about how I myself got involved in it and how you might get involved in it if that's something that you're interested in, or if not, how you might use it.
If you're planning to partition more than a single table in your Postgres environment, this is the talk you have to see, because if you partition multiple tables, you have only one chance to do it right, and this talk gives you all the information you need to do to build a great environment, which is really fast forever and ever. So, welcome to Partition Your Tables for 20 times better performance.
So hi, my name is Tomáš Vondra. I do work for EDB. I'm a long-term contributor, developer, and also a committer. And I'm here to talk about performance cliffs, which is a performance issue affecting a lot of people that may not be aware of that. I'm going to explain how the performance issue actually happens and why.
I am a senior software engineer in a team which is responsible for internal database as a service platform. And today I want to share with you our findings and experience when adopting and supporting our internal CDC solution based on logical decoding.
Hello everyone, my name is Hans-Jürgen Schönig. I'm the CEO of Cybertech, and hopefully for this year's conference I've prepared some really interesting performance stuff you've never seen before. So if you're seriously interested in performance, check out this talk and learn something that is way beyond just adjusting some Postgres configuration parameters. Have fun.
Hi everybody, I'm Luigi Nardi. I'm the founder and CEO of dbTune. Very excited to be here at Posette. Today we'll be talking about auto-tuning Postgres. So if you are interested in learning about the configuration of your Postgres instance to achieve high performance, this may be the talk for you.
Hi, I'm Karen Jex, Senior Solutions Architect at Crunchy Data, and I'm speaking at Posette about why you don't need a database backup policy. You're probably wondering why, as a DBA of over 20 years, I'd be telling you that you don't need a database backup policy. So hopefully this talk's going to be interesting to anybody who has data that they care about and want to keep safe.
Hello everyone, my name is Taras Kloban. I am Senior Solution Architect at Microsoft, and today I want to present a solution which we created for a tight NATO hackathon to advance drug search and also show how we utilize for this Postgres and the Azure AI extension.
Hello everybody, my name is Federico Campoli. I am a freelance PostgreSQL consultant, and today I will talk about PostgreSQL running on top of ZFS, a powerful file system but with a bad reputation. So if you are a sysadmin or DBA and you are searching for an alternative for performance and scaling up your system, you may be interested in my presentation. Thank you.
Hi everyone, I'm Paolo Mecchiore. I'm the CTO of 20Tab and I'm a member of the Django Software Foundation. I use Django since a long time to do my web project, and today we'll see together how to integrate semantic search using Postgres and pgvector.
Very cool. That was awesome.
The details, the depth of the series of talk was awesome in this trailer, right? It just popped out.
Yeah, maybe I'm going to have to pull 2 all-nighters in a row. Or all the videos are getting published on YouTube after the event. At the tail end of today's live stream, I'll include that playlist short URL that people will be able to use, because I don't expect everybody to pull multiple all-nighters in a row. So yes, everything is going to be available on YouTube, ungated. You'll be able to watch it at your leisure at 1.5x speed if you want. But we're so happy that so many of you are here for the live streams. Okay, coming up next, Elizabeth Christensen. So Elizabeth works at Crunchy Data. She's from Kansas in the United States. And I first met Elizabeth at PGConf New York City. And more recently, we were together at PGConf Dev up in Vancouver. She published a blog post about a couple months ago about her very first commit to Postgres, to the documentation. And this talk is based on Elizabeth's experience and learnings about the process for contributing to Postgres. And with that, I say, let's go for it.
Let's go.
Hi, I'm Elizabeth Christensen from Crunchy Data. I'm from Lawrence, Kansas, and I'm going to talk about open source Postgres and how code gets into the Postgres code base. And if you wanted to put a patch in, the process of submitting patches. So I'm from Crunchy Data, and we do Postgres on managed cloud, in Kubernetes, and self-hosted. I'm on the board of the United States Postgres Association, and we do a lot of education and events. And I also host a meetup near my house in Kansas City. If you're ever in town, we'd love to have you. And I also help host the PostGIS Day event. If you're interested in geospatial data, it's a super fun
remote all-day event in November. So I'm here to talk about the process of getting patches into Postgres, and I was lucky enough to get my first patch in recently, and this is a little snippet from the patch that I actually got in. And this is what my patch looks like. It's a documentation patch, and it went into the hot updates documentation page. So a little bit about why I wanted to submit a patch and kind of why I'm passionate about talking to you guys about open source contributions. So I think that documentation is really important. I write a lot of documentation at my day job at Crunchy, and I think that docs are important for helping new people come into the software, kind of making things accessible. And the Postgres docs are sort of well regarded in the open source community. They're very good. They're very thorough. They're a very good reference manual. They don't have tons of examples. They don't have tons of tutorials, and there's kind of other things that can be built out. And so there's some opportunities in kind of the Postgres docs, right? Things where things might be unclear, or you might need to connect, one update to some other piece of documentation. So that's kind of where the patch that I submitted comes into play. So another thing that's important to me is that the Postgres is a really diverse ecosystem of lots of different kinds of people, right? So for Postgres to continue to be the go-to open source database in the future, we need architects and data scientists and people that are building products and DBAs, and we need lots of different perspectives to make the whole ecosystem really healthy. And that's true for the code base, the documentation, and all of the events and other community things happening with Postgres. So let's talk a little bit about just the code base and kind of how the whole thing works. And then I will kind of, after we go through that, I'll explain how you can kind of get into that yourself. So the Postgres code base itself is kind of, I made a little version calendar. This is something I update sort of regularly for myself just to kind of keep track of where everything is. So I'm recording this at the very end of May, and you'll see this in June. And Postgres 17 was just released in public beta today. And so as soon as Postgres 17 is in public beta, Postgres 18 is open for commits. And so the next commit fest that happens and the next things that go in will be in Postgres 18. We're currently on Postgres 16 in production. That was released in the fall. And there was just Postgres 16.3 that came out as a minor point version. So the Postgres release team is doing a great job of releasing a new version of Postgres every fall and then doing several minor point versions kind of as the year goes on. The actual Postgres code is in a couple places. One is in GitHub, and you can see this link, and the other one is in a Git URL. Both of these places will let you pull down the Postgres code and the docs. And if you do that and pull in the code to your local machine, you can see the docs, and they're sort of done in a kind of special format, and you'll see a little HTML stuff for those files. I thought this was kind of cool. One of my very first jobs in tech was tagging HTML, so I felt really at home when I saw this. And if you get into the other code that kind of runs the database itself, you'll see that that's all C code, and you can open up those individual files and see kind of what's actually under the hood and running the whole Postgres database. The actual code store that the project uses is at the Git URL. And that is kind of where everything is. And then there is a certain group of people, the committers, that can actually push new code into that Git repository. So committers are people that have been a part of the Postgres code base for a long time. They've had several patches. They're sort of known and trusted individuals, and they can get your code in. So, and when you're talking about the sort of Postgres code and how things get in and kind of get actually released and into the hands of users, the committers are the people that will commit the code. And then there's a release management team that will, they will sort of coordinate the releases, decide which pieces go in which minor point versions, which pieces go in the bigger versions. There's a lot of work going on there. And then there's also the Postgres core team. And that group does a lot of communication about new releases and sort of overarching decisions about kind of how the whole project itself is going to work. So the sort of big picture release process here is that you've got new code coming in, something's happening with that. You've got committers that commit it. You've got a release management team that kind of plans a release. And then you've got a packaging team, and they sort of get everything ready, running on the operating systems that are supported by Postgres. And then the core team will sort of coordinate an announcement. So all of these people are obviously amazing, and it's incredible the amount of work that goes into these release processes. So let's talk a little bit about getting your own ideas and your own code into Postgres. So the first kind of place that you're going to be starting is with an idea, right? And so for a lot of people, this is going to be something that you've had a problem with. Documentation is a common place where people start committing to a project like this because you're probably a user. You've probably looked for something that you couldn't find. And there's a Postgres wiki with a to-do list. I'm not sure how up to date that is, and I'm not sure if people pick stuff off of that or what. It seems like there's a lot of older things on there. But the big thing to sort of take away from, patch ideas is just talking to people in Postgres. So my patch that I got in came up after a conversation that I had about some research and work I was doing with hot updates, and I kind of realized there were a few missing pieces, and there was some things that weren't clear, specifically about how the Brin indexing works with hot updates. So those conversations are going to be really important, right? You're probably not going to just have a patch idea, put that patch straight into Postgres. You're probably going to go through some iterations and conversations. So the sort of big picture Postgres patch process, which I'm going to go through kind of step by step here over the next couple minutes, is sort of your idea, lots and lots of discussion about your idea, how that could be implemented, the best way to implement it. And then there'll be, obviously writing the code and testing and sort of the rest of the process. So once you have an idea and you're ready to sort of experiment and see if you can get some development going to write some code to put into Postgres, you'll need to build Postgres locally. This is a little, depending on your setup, can be a little bit of a challenge. There's some good docs as part of the Postgres docs themselves. And there's two kind of build systems that Postgres is currently using. One is the make build system, and then one is the Meson build system. I'm pretty sure that kind of the way that they want to go is towards the Meson build system, and that worked really well for me on my Mac. So those are the kind of steps I'm going to show you. So if you're gonna want to run the Postgres docs themselves, you'll need to be running a project called DocBook as well. And that's kind of the thing that makes all the docs work. And it also makes the docs go into a PDF, but it's sort of foundational to getting the docs actually running. You'll run the Meson and you'll do a setup, and it'll kind of build stuff for you. And then you'll get into the Ninja, which is part of the build system. And so these two pieces, the Meson and the Ninja, will help you start up whatever piece that you want to run. So if you're going to do a Ninja build of the docs, you'll tell your system to Ninja build the docs, and then you'll be in the docs locally, right? So you'll be just running a local copy of the docs, and you can edit those HTML files that I showed you before, and then you can kind of preview your changes and see how everything looks. If you're wanting to build the actual Postgres database itself, you'll also use this Meson and this Ninja build system, and you'll run a test, and then you'll create a directory for whatever version you're building. You'll initialize the database, and then you'll just pSQL straight into that local copy of the database. So very similar process, and that's kind of how you can build whatever copy of development Postgres is running, and you can go ahead and kind of test that out and actually use that database if you wanted to. So once you've got, your idea, you've put a little code in, you'll need to do some testing. Postgres comes sort of pre-packaged, these build systems with their own regression tests. And that's what you'll run when you run that Ninja test program. Those are pretty robust. There's a lot of stuff built into those regression tests, and depending on kind of what you've put into the code base, those regression tests might take a while to run. And other people are going to also probably run regression tests on your code. So we'll talk a little bit about that too when we get to some of the next steps. When you're kind of going through this process of testing your code, thinking about what you want, you'll want to pay pretty close attention to the Postgres coding conventions. There's lots of notes available on a wiki about submitting a patch. The other thing to keep in mind is that, Postgres is a 30-year-old project, and it has a lot of history and kind of, there's ways that things are done. There's kind of specific ways that things are talked about if you're using the docs and if you're coding. And so definitely you want to kind of follow the existing conventions, right? You're going to want to look at how things actually have been done in the past and kind of work with that. This is not a brand new open source project where you're going to be able to kind of come up with a bunch of your own new stuff and kind of rock the boat, right? This is not that project. This is a very stable project, and you'll kind of want to look at how things are done and then kind of make your things kind of work within that system. So let's say that you've got your idea, you've got your code, you've run your regression tests, and you're pretty happy with how everything looks. The next step is to kind of get this in a patch, right? So this is going to be the actual thing that gets submitted to the Postgres community, and the Postgres community is going to kind of review and decide if they want to implement. So a patch process is different from like a pull request system. I have only ever worked in a pull request workflow. I've never worked in a patch workflow before. So this was kind of new to me. I'm, used to just projects where, okay, I have something I want. I'm going to open a pull request and, it'll wait in a queue and hopefully somebody will review it. But the patch process is a little different. And that's where you'll use, Git, and you'll create a patch file. And that patch file just gets passed around, right? And that patch file will get passed around to a reviewer or a committer. And you can pull in patch files. You'll, create a new branch, and then you'll pull in a patch file and test that against the development version of Postgres. So to make a patch file, you'll just use Git, and you'll tell it, that you want to create a patch file. And it'll look something like this. So it'll have a long name. It'll be .patch. There'll be a large header at the top, and it'll kind of tell you some of the metadata about what's in it. And then it's kind of a diff file that follows there. You'll want to kind of look at how other people have formatted the header piece of the patch file. You can just edit this directly, like after you've created your patch file, if you want it to look a specific way. But this is a good way to kind of sort of in that coding conventions conversation, right? Making things look like other things have looked in the past. Take a look at that header. And so if you're, once you submit this patch, you'll literally submit this file. And then if you're doing a review or doing stuff for other people, this patch file is what you would pull in to test in a development version of Postgres. So Postgres works, the community and sort of the code base itself works with mailing lists. There's quite a few mailing lists for lots of different things. I think there's a couple dozen mailing lists. I am not on a ton of them. I'm on the docs mailing list, mostly because I'm kind of interested in what's happening with docs. If you're a beginner, the novice mailing list is a good place to start. It's got kind of beginner questions. The general mailing list is also just kind of general questions, things that are going on. And then the hackers list is kind of that's where all of the patch file discussions and like the big picture kind of coding stuff is happening, right? And I'm not on the hackers list because I'm not involved in a lot of coding discussions, and I don't plan to be involved in Postgres at that level anytime soon. If you are like me and you're like not wanting to get thousands of emails a day about like underlying Postgres code, all the archives and kind of all of the mailing lists are online, which is super cool and helpful. So if you start a thread, it'll kind of be there, and then it'll be sort of hyperlinked, and you can see kind of the whole thread of what's happened in that particular discussion. And so every day the mailing lists are archived, and like if there's things going on that I have, or things that I'm kind of interested in, like if somebody I know has a patch, or there's a feature that I'm kind of watching to see what happens with, you can just kind of find that or bookmark that particular discussion. And then that way you don't have to like wait for emails. You can just find it when you're curious about it. And so, yeah, each of these threads has kind of its own URL, and you'll kind of see, you know, sort of the whole history of what's happened. For my particular case, you can submit to the hackers list, even if you're not actually reading it. So you can put sort of patches into the hackers list, and then because they reply all, you'll get emails back about your patch. And then you could also, if you wanted to check on the URL, you could do that too. So the hackers list is definitely not for new people. It's definitely not a place you want to hang out if you're trying to understand what's going on in Postgres. I definitely recommend kind of working with somebody that's, you know, more familiar with patches and more familiar with the code process. I was really lucky. One of my coworkers, Stephen Frost, who has been contributing to Postgres for a long time, kind of helped me through my first patch process. So definitely, if you can find someone that can kind of help you sort of make sure that all your stuff is right and that you're saying the right things, you know, that's definitely helpful. So to get your patch submitted, you'll email that patch file to the hackers list. And then there's a second step, which is adding your patch to a commit fest. So Postgres, like kind of the way that they decided, since this is a mailing list and there's lots of stuff happening, they have these periodic sort of commit fests, which are basically a commit fest is just a list of things that could potentially go into the code base, things that have been submitted, and then who's reviewing those and what the status is. So this is sort of another way that they're trying to make sure that, you know, patches and, you know, contributions don't get lost. So if you go in to the commit fest URL, you'll see there's a whole list of commit fests from the past, and then there'll be one commit fest that's open. And so that'll be kind of right now, I think the June commit fest is open. Some new things can go in there. And then if it's brand new, you'll just put it there, and then it'll have it'll be waiting for review. Your name will be there, and it probably won't have a reviewer. But as things kind of get reviewed, you might have one of the contributors or one of the major contributors, or, you know, someone involved in the project add themselves as a reviewer. And then, you know, if a committer is going to look at your project and potentially get it committed, they'll be listed there too. The commit fest log is kind of an interesting place, since I don't kind of keep up with the email, and the email thing is like too much for me. The commit fest lists are kind of a fun place to see like what's happening, right? Like who has what patches in and where they're at. So, you know, if you're interested in what's going on in future versions of Postgres, that's kind of a cool place to look. Okay, so we've gotten as far as getting our patch submitted, and sort of the next step that happens is that a review will happen, right? So hopefully someone in the Postgres community is going to look at your patch and see what's going on and review it. They're going to look at it for coding conventions, those kind of things we talked about before. They'll look at the unit testing and regression tests, and Postgres has incredibly high standards. This is not a project where things easily make it in and you'll submit a patch file and it'll be committed the next day. This is a project that has incredibly high standards, a long history of stability. It's used across the globe by, Fortune 100 companies and banks. And so anything going into the code base just, has to have a lot of eyeballs, and it has to be very, very reviewed at a very high level. So just a couple tips. If this is your first time submitting or you're thinking about submitting, be prepared for tons of feedback. I am used to having pull requests reviewed pretty extensively, and Postgres is kind of another level, right? Like it's even in the documentation, there will be a lot of discussion about even just the grammar and the wording and how things are linked together. And so, it's best to kind of just let the sort of discussion happen, right? And not take things personally and not sort of, this is not a hill you want to die on if this is your first Postgres patch, right? This is a learning experience for you to kind of learn how the Postgres code base works and sort of how people think. And so that's a better sort of mentality if you can go into it with that. And then, this goes for every time any of your work is reviewed in tech, but, it's hard to not take things personally, especially if they're things that you wrote or you're passionate about. But nobody in Postgres means it personally, and they really just want this to be the most correct. And, they're really going for accuracy and technical competence. And be patient. Some of the patches take quite a while to actually get into the code base. And it can be tricky to find a reviewer, and then it can be even trickier to actually find a committer that has time to review it and put your commit in. And so, it can be a long process. So yeah, let's assume that everything goes the way that you wanted and you kind of waded through this review process, and you sort of, in my case, there were several ideas about kind of updates to the documentation, which I was happy to have input on. And then a committer sort of picked up the patch and said, all right, if we're all in agreement, I'll commit this. And so once you get a commit, it's sort of in, right? Of the recent commit fest, I just kind of took a look at sort of what had happened. And, there's in any commit fest, there's, 300 or so, north of 300 patches submitted. Some of these are bigger features, so the numbers are a little bit trickier. And about 26% of things are getting committed, right? And so there's a whole bunch of stuff that's got feedback, a whole bunch of stuff that's moving to a future commit fest. Because it's not something they had time to deal with. But very few things are rejected outright. So if you see I was kind of encouraged to see that most things are sort of returned with feedback, or they're moved on to the future, which kind of means that they're not dead, but, they may need some work. But, 26%. So if you don't get your first patch submitted or your first couple patches submitted, you're probably in pretty good company. So what happens next? After you get your patch submitted, is it just goes straight into that Git mirror, right? And so it'll be there, and then other people who are developing on. So if you put a patch in and it goes into Postgres 18, anybody then who pulls Postgres 18 down will be able to test the things that you've put in there. And then everything is kind of packaged, and, we talked about that packaging and release process before. So, and then the docs, the actual Postgres docs that appear in the Postgres docs URL are updated every minor release. So if you do something for a future version, it'll be up there in that next version. Or if you do something that's like back patched to an existing production version of Postgres, just the next time a minor release happens, your docs will be up there. So if you're looking to kind of do more and dip your toe into actually contributing to Postgres, I think there's a lot of great resources. Sort of the Slack is really good. If you're not talking to people on Slack, there's a lot of good discussions on there. The local meetups are great. You'd be surprised how much cool stuff happens at local meetups and interesting people like coming in and out. The PostgresConf New York conference, that'll be in the end of September, I think, beginning of October. Usually it's in the fall. A lot of the major contributors will be there. There'll be several committers there. So if you're kind of shopping around patch ideas, that's a good place to start. There's an annual event in Chicago every year happening in the spring. And that's always a fun place. And then the Postgres Association PGUS is also a great resource. We have a lot of events, and we would love to have you as a member. It's $25 a year. And thank you so much for your time today. I had fun putting this together, and I look forward to chatting with some of you. And if you'd like to find me on some kind of social media, I am SQL Liz.
Wow.
Interesting talk.
A talk that's near and dear to your heart with the kind of work you do. So for people watching the live stream, you may not know, but KK is an engineering manager who manages our team of Postgres open source contributors and committers.
So I've contributed to Linux, Kubernetes, and other places, but when I arrived, started getting into Postgres development, this was a talk which would have made a lot of difference, for folks who are really starting, right? I was fortunate enough that someone like Daniel Gustafsson was there to kind of guide me through the whole process and make it so, easy and fluent. But the way that the mailing list work, what kind of collaborations you need to build, how to go about the patches, splitting it, and the commit fest, semantics of how to operate on that, all of that really popped out in Elizabeth's talk, and I'm looking forward to what people will gain from this, which is in my opinion, going to be awesome. Hopefully, this will help us scale contributors in the community and kind of make it easy for everyone to start working on the patches.
Awesome.
Cool.
Well, thank you, Elizabeth. Before we jump into introducing our next talk, I just want to remind people that the swag is available. I'm going to pop up a new set of codes because the codes I shared a few moments ago are now all gone. So there are swag supplies for another 25 people if you go to ak.ms/Posette swag and you use the code that I'm showing on the screen right now. So sticker packs, there's a whole bunch of those that are available, and there are some of the cool Posette 2024 socks available too, although supplies are limited. Okay, so let's go ahead and look at introducing our next our next speaker, who I believe is...
So let me introduce Jaehyun Sim. He is head of engineering in Ikigai Labs. He enjoys working with data warehouse, lakehouse, all the scalable parts of the distributed system, as well as Kubernetes. And interestingly, he's also studying system design and engineering management at MIT. So someone who wants to learn and who is also doing stuff. Awesome to hear from Ikigai. And on one of the most hot topics, AI and Postgres-powered AI running on, end-to-end AI platforms with Postgres on Azure. Let's get going.
All right.
Hello, everyone. My name is Jaehyun Sim, and I want to talk about Postgres-powered AI, running end-to-end AI platform with help of Postgres on Azure platform. I'm currently leading engineering team here at Ikigai, and I want to share our story because it will give you a lot of insights if you're trying to build and develop an end-to-end AI platform using complex data types and complex AI workload. So why don't we dive right into it? As I said, I'm leading engineering team at Ikigai. Been here with our company for about 5 years, developing our AI platform from top to bottom, and currently I'm living in Boston. I wanted to quickly talk about our mission to give a more context to our audience. we want to bring AI to anyone, meaning there are a lot of AI tools that's being developed out there, but we feel like there are not many solutions that is targeting for the old enterprise data problems, which is for tabular data and structured data. So we want to design a solution that is specific for multivariate tabular data and then time series data. And we want to talk about how we made it happen. Where we started is we wanted to make an AI platform, an end-to-end AI platform that is specifically built on AWS as a SaaS offering, like 24/7 running types of SaaS offering. We wanted to enable business users and data scientists work seamlessly on one platform, meaning they can hop onto our hosted platform and then they can edit data, ingest data, and process the data pipeline, analyze by visualizing and interacting with what they came up with, and all this good stuff. While we're doing this, we faced a few challenges because we wanted to label ourselves as an enterprise AI platform. To explain the types of challenges we faced and how we mitigated them, first I wanted to explain how we implemented our AI platform using Postgres, and then introduce the types of challenges we actually faced, and then talk about the timeline, how we mitigated them, and how we actually adapted to the Azure's environment. This is how our AI platform architecture looks like, and I want to start by explaining why we chose Postgres when we actually start implementing this platform 5 years ago. So the first thing is we all know Postgres is fast and scalable, but then why we wanted to put extra focus on was predictable portion. We're SaaS offering, so we are running our platform as a hosted service 24/7. That means it has to be reliable, and Postgres' reliability on the performances, it came in really handy. And the second big thing was we wanted to maintain SQL database. It's easier to use and familiarity, but also we want to leverage the power of JSON support that Postgres has, because we needed to work with unstructured data a lot using raw data from the user side. And we're going to dive into this a little more later. And another thing is a great community support. And when I say great community support, it's mostly language support, the programming language support, and the open source support. And we're also going to dive into this later as well. When we define how we want to support AI ML workload in our platform, we always talk about 4 different pillars: data ingestion, data processing, and the actual AI ML workload, including model training and inference, and also data interfacing at the end of the pipeline so that you can analyze with the results. And we're going to dive into each section and how we're going to talk about how Postgres enabled such workload and the steps in the pipeline. In our data ingestion, there are 2 different types of way of interacting with data. The first thing is the data connector. You can connect to different data sources that lives outside of the platform in secure and scalable way. And Postgres play a lot of part here because different types of data sources, for example, Google Sheet or Google Ad connector, they have fundamentally different types of requirements and metadata. And we wanted to still utilize SQL so that we can handle multiple rows, scalable and easy to use interfaces in programming language. But also at the same time, their definition looked too different. Do we want to leverage different types of database on top of our metadata just to handle these things? We didn't want to. So Postgres is a good choice that we can utilize because Postgres JSON support is not only fast, so we didn't really lose any performances, but that we can be really creative because you can actually also query on top of the keys that is inside of the JSON field. So it enabled a whole lot of the basic needs that we had for unstructured data without changing any infrastructure. And also on top of that, the open source tool that we're using, Airbyte, also utilized Postgres as internal states and metadata management. So it was a big plus for us because we didn't want to manage like different types of database inside of our platform. We wanted to kind of unify one primary database choice. Also, our dataset management, we enable users to host their dataset inside of the platform. When they do that, they store different types of metadata storages, including file types and data types and data format. And these things come in really handy because when user wants to download their data, we have to do a different types of processing to support them. And yes, so so we also leverage the JSON support for this, and also inside of our Postgres database. And data processing, to be fair, data processing, there are not a lot of benefit that we got from the Postgres itself, but one thing. In our platform, there are two different ways of executing user pipeline, which is remote cluster, a high volume pipeline run using remote cluster called Ray, and a low volume interactive workload using the local Python executor. The problem is the same pipeline can be ran in two different scenarios at the same time concurrently, and those two pipeline runs has to access the metadata that is stored in the Postgres all the time. There can be race condition. There can be there can be race condition, but then because of ACID compliancy that Postgres enables, we didn't really have to worry about it, and also we didn't have to come up with a whole lot of locking mechanism just to support this concurrent way of running two pipelines. Moving over to AI ML workload. So this is, I guess, the best part that the biggest part that we got benefited from using Postgres as our metadata data table. In summary, a need to handle unstructured data. We wanted to handle unstructured data, but still want to use traditional RDBMS experience. This was this is the place where we actually felt this to the heart. So we have our models trained and making predictions in our platform. And for all those models, different types of model have different sets of hyperparameters. And different hyperparameters looks very different. If you compare traditional linear regression models and ARIMA-based time series model, they're going to have just night and day. They don't share any variable together, and their structure looks too different. So we're facing the same problems again. And all models, different definition requirements, they're stored in DB. We maintain the performance by utilizing Postgres's JSON support. And on top of this, each models, they can have different versions, and different versions can be utilized at the same time. So the problems that we had for concurrency problems, race condition types of thing on the data processing, that benefit that we got from Postgres also applies here as well. So multiple rows use it at the same time, and also each row having their own hyperparameter definition truly enables us to work with different types of model concurrently in one platform in a scalable manner. And finally, data visualization with Postgres. In our platform, we leverage multiple different types of open source tools so that we can provide the familiar interfaces to our users with the result they have from their pipeline runs. So first thing is data interaction. We're utilizing this open source tool called Jupyter Hub. And what it does is that it spawns the IPython notebook so that user can interact with the snapshot of the data in between of their workload, in between of the steps inside of the pipeline by just using the Python code base. And also we enables data visualization using multiple different types of dashboard vendors, including Superset or Plotly Dash. The good thing is that all this open source tool, including Jupyter Hub and Superset, utilizes Postgres has an option of internal state and metadata management as a Postgres database. And also for IPython notebook, for data interaction part, their definition is in JSON format, the IPython notebook's definition. So we can store that inside of a Postgres table with the notebook metadata. And for data visualization side, they have a different types of metadata that is stored with our dashboards metadata, and different definition between superset dashboards and dash dashboard. These get stored inside of our Postgres table as well, leveraging the unstructured data support of Postgres. So now we covered how Ikigai built end-to-end AI/ML workload handling utilizing Postgres, but then are we ready to solve the enterprise level problems? So the answer was no. And I wanted to explain what kind of challenge we faced. So coming back to the previous slide where we wanted to bring AI to anyone, including enterprise users, the problem that we face is that we wanted to operate on enterprise data, as in your own data, instead of enterprise setup. And the problem is not all the enterprise wanted us to provide a SaaS offering. They didn't want to get their data, they didn't want their data to leave their environment or their platform, and they want their data to stay there so that we can install our platform in their environment. So there's two methodologies here. So how we started is that we make our hosted service as a SaaS offering, meaning we have our platform implemented on top of AWS, and your user has to come on our hosted website and utilize our service. But then we wanted to switch over to BYOC, which means that bring your own cloud. What we would have to do is we're going to have to make our platform that is portable enough so that it can be installed in any different types of environment, which is an enterprise user's environment. And by doing this, their data doesn't have to leave their environment, and they can still leverage the power of Ikigai's AI platform. So our decision is that we wanted to make our platform better and by making it portable, but what's going to be our solid target? So we want to make our Ikigai platform compatible with Azure first, because as you can see, Azure, not only Azure is really popular in industry, but also we actually have two concrete customers that's asking us that they wanted us to wanted to install our platform on their Azure environment. So we decided to explore the possibility how we can transition our heavily AWS-based Ikigai platform on top of Azure. And while doing that, what we wanted to evaluate is that the flexibility of the platform. So far, our AI platform was very, very focused on the two aspects, which is scalability and interactivity, as in user can still interact with their data and their models while maintaining the powerful scalability of the pipeline. But we wanted to add another pillar to it, which is a flexibility. Our platform should be flexible enough in two different ways. One, it should be able to install in any types of user environment. And two, they should be able to adapt to any different types of requirements that user introduces. So these are the evaluation criteria that I set it up. Interoperability between complex requirements, adaptability for infrastructure limitation, and compatibility with open source tools. So the first two criteria is more focused on, can we survive in enterprise environment with, let's say, Azure version of our platform? And a third thing is more or less of how we can adapt to future changes of our platform. And let me start by the first criteria, interoperability between complex requirements. So this was actually interesting. This came up because of one interesting ask from our customer. We installed our platform in their AWS environment, actually, but then they had their LDAP structure they wanted to bring in from their infrastructure, and we should support that structure inside of our user base, which we didn't have. So this was a pretty big ask. And then when we talked to another customer, they have another single sign-on request that we had to conform to, and it was a whole mess. And what we wanted to, how we evaluated as our platforms be flexible for this type of environment was pretty simple. We wanted to make our code base, like Python code base, to be adapt to these things. but then we didn't want to change any existing infrastructure to it. And thankfully, that goal was met because we decided to store all these different types of metadata and the requirements on the user's own credentials and authentication strategy inside of the Postgres unstructured database and unstructured fields inside of the database. So we didn't really have to change a lot inside other than the actual Python code base that supports those functionality that they have. And the good thing we had is that since there was no infrastructure changes and like no more layers of a database that we added, we actually didn't lose any performance while we're adding these more supports and more supports. The second criteria that we had was adaptability for infrastructure limitation. So the big challenge was that we had to, when we get into enterprise users' environment, they have a specific need. One thing was, one ask that we actually got was this one customer didn't want to use API gateway in their cluster. And the one customer has very specific vendor they're working with all the logging. And we had to change or actually create entire new solution to support this API gateways, data lake engines, and logging structure. And that took us over a month to just conforming with their requirements. But then surprisingly, anything that is hooked up to the Postgres for our complex microservices and data processing pipeline itself, and all the open source tool that is actually user-facing didn't have to change at all. And when they do, they actually ask us to use specific version of the Postgres at most, but that was pretty easy to conform with, and then we didn't have to change any infrastructure other than just changing the version of the Postgres database. So that was a big lift for us. So one lesson that we learned is that if it is hooked up to Postgres, we really don't have to worry about it. The last thing is a compatibility with open source tool. And as a Kubernetes person, my background is more in the cloud computing. When I take a look at open source tools and the possibility of using those, I always take a look at two criteria. One, are they cloud native? And two, if they require internal state management database, and if so, do they support Postgres? Since our platform is built on top of Kubernetes and our primary choice of database is Postgres, we didn't really have to change our criteria from the criteria that I have from my own. And then looking at the community size of the Postgres and Kubernetes, we really didn't have to worry too much about it because, to be fair, all this new technology and all these new open source tools, they do support Postgres and Kubernetes. So at the end, we didn't really have to compatibility with open source tools. So what I found out is just using Postgres itself like boosted our flexibility without us knowing. We didn't have to really change much to meet our initial goal that we lay out. So we were truly ready to move over to Azure adaptation project that we planned without changing too much on the infrastructure itself. The at most thing that we changed was the Python code base to adapt to different types of authentication strategy. But other than that, we didn't have to change too much. Yeah. So now, as a last step, we're going to talk about our Azure compatibility journey. The challenge that we faced was that we expected was we have to find one-to-one mapping of all the AWS services that we're using, including S3. They have to move to blob storage, and DynamoDB has to go to Cosmos. And all this thing, they have a different way of maintaining. Even though they look same, they have a vastly different requirements and some deltas in the functionality. So we need to check those features are there or not individually. And also at the same time, we need to check the performance. If you're losing any performance just because we're switching to other vendor. It turns out what we actually have to change is interesting. So yes, we did have to put a lot of effort on the things that I just mentioned. API gateway, AWS API gateway, to Azure's API gateway or API management. They didn't have a WebSocket support, so we had to change a lot of code base to it. And all the logging system was pure pain. But what was surprising for us is that the actual infrastructure that supports AI ML workload that I explained, the 4 pillars of AI ML workload infrastructure, those didn't change almost at all. Like those complex data type management and user interaction and visualization and data processing between 2 different substrates, those part that was hooked up to Postgres. And since Postgres is not changing when we're migrating from RDS to Azure SQL, we didn't really have to touch actual core part of our platform. At most, what we have to change is how we set up the infrastructure for our computing cluster, and also just Azure SQL instance itself. But other than that, we didn't have to change anything. So there was a pleasant surprise. So in short, yes, everything but AI data and AI workload had to be changed, but then that was within our expectation. So the actual timeline of our migration was pretty impressive, knowing that our platform took 4.5 years to implement, but the migration took around 3 months. So we started our technical spec at the end of September of 2023. Development for all those Azure service versus AWS service in Python codebase is done around starting in November. Infrastructure manifest, including Helm and Terraform, that was done around December. And we had our first Azure cluster deployed, first AKI platform on top of Azure environment deployed and functioning at the end of January. To summarize it, so Postgres is an excellent choice of database for AI platform implementation, as I mentioned in the starting of this chat, because it enables flexibility, portability, and performance and ease of use. And I highly encourage anybody who's planning to implement AI platform from start to bottom to consider Postgres as your primary choice of database. Thank you. And that's all I had to say. And thank you for joining today.
Wow.
This was quite interesting to hear how some of the base aspects of Postgres, right, remain same even if when you're moving from totally a different platform in cloud to like another platform like AWS to Azure. That was quite interesting to hear, Claire. What do you think?
I think it's always interesting, too, to hear from a customer perspective. You've seen that a number of the presenters today have been developers on Postgres or contributors to Postgres. And one of the things we've tried to do is mix it up and also have user talks and customer talks. So, and then there's obviously a whole bunch of AI-related talks as well, because it is one of the hottest topics.
The coolness of the selection is really showing up, Claire. This is super great talks.
So one of the things that we are supposed to do in between some of our presentations today, I'm going to pop some slides up here. Well, first of all, reminding everybody, virtual hallway track on Discord, aka.ms/open source Discord is how you can get there to be part of the conversation and to ask speakers questions while they're giving their talks. So they have all committed to be there during their individual live streams because all these talks are pre-recorded a couple of weeks ago. But next, I think we had just a few extra minutes, and I wanted to find out how many people have heard of this podcast that our team produces, currently called Path to CitusCon. And it's intended for developers who love Postgres, whether they work on Postgres or whether they use Postgres. But it's monthly, and we've had 15 episodes so far.
Yep. It's amazing talk for people who are interested in like Postgres in general, right? Like we tend to, there are topics from developers coming and sharing their stories to, okay, how they got introduced into Postgres and many things, which was totally insightful when watching some of those talks.
So for the first year, I co-hosted it with Pino DeCandia, who's actually going to be one of the live stream hosts for Livestream 3 here at Posette. He's a wonderful human being, and we had a lot of fun. But when he first signed up, he signed up to do a couple episodes and maybe a few more after that. And he stayed for a full year, which I really appreciated. But as of the last episode, I am now hosting the podcast on my own. And I just wanted to give a shout out to all of the people whose faces show up here who have been guests on the podcast, and thank them for their contribution and just opening up. Like, a lot of these folks have shared their origin stories about how they got started as a developer or in Postgres or working on Postgres monitoring. There's just been a lot of interesting conversation. There was an episode with
I remember.
Andres. Go ahead.
Go ahead, Claire. Yeah.
Well, I was going to say there's an episode with Heikki Linekangas and Andres Freund about how they got started as developers. And then what was interesting is after Andres discovered the XC backdoor and got a lot of attention, shall we say, the number of views on YouTube on that one went up precipitously because people were all trying to learn more about, well, who is this engineer and how did he discover this?
Nice. And some of the things, right, like in those talks, there are talks about AI and how, we kind of like, I think our last talks were like talking about some of those aspects, but like Heikki's talk, I remember like about productivity in terms of like how he is able to, churn out code. Like we look up to him as one of those people who's super productive. And he was like mentioning about, I have a laptop which I'm on the kitchen counter while cooking dinner. I do this, which is like awesome thing to hear that, he is a real human being and not like super human. So that was very exciting conversations, Claire. Thank you for taking a chance of making this happen. And thanks to Pino too for co-hosting this. This has been really great.
I think one of the things we think of when we're choosing guests, inviting people, and producing the episodes is the goal is to create something that is useful to people who work with Postgres, developers, users, all of the above, and something that will, in some cases, inspire them, but in other cases, just give them like actionable tips and recommendations and links and resources. And so the show notes is always like chock full of links, things that came up in the discussion. Also, shout out to the folks over at Oxide and Friends, Brian Kentrell and Adam Leventhal. They do an awesome job, and this podcast was inspired in part because of what I was observing them doing, and it was just a lot of fun. So topics are things like becoming expert in Postgres. I think that was the Chris Ellis episode, or my journey into monitoring, how I became more expert in performance benchmarking, how I got started. So it's a little bit of the human side of Postgres. And I think the thing I wanted to roll out today, most people don't know about this, is that we're going to be changing the name of the podcast. So in July timeframe, I think it's no longer going to be Path of CitusCon. We're going to move everything over, and the new name is Talking Postgres. Yep. So when
that perfectly makes sense, because that is what has been happening, right? So we're just renaming it to more different way, but
yeah, I was just getting a lot of flack from people like, this podcast has nothing to do with Citus. This podcast has nothing to do with CitusCon. I'm like, I know. It started as a pre-event for last year's CitusCon, but then has morphed into something completely different. It was pretty cool when we were at PGConf EU. One of the attendees walked up to me somewhere during one of the coffee breaks, the hallway track, and literally said that the podcast had changed his life, that we had these sessions where we talked about the toothbrush test. And when you're brushing your teeth in the morning, are you excited about the work that you're going to be doing that day? And he realized that he wasn't excited about the work he was going to be doing that day. And so he made a switch. And I
Wow,
just thought
that's
that was
really impactful. I mean,
I
real
thought
life. Yeah.
I thought it was heartwarming, and anyway, it just made me feel good about all the effort that we put into producing it. So the new name, we'll be talking Postgres. If you go to that short URL right now, though, obviously you still land on the current podcast name. And I hope some of you subscribe, check it out, listen, give me feedback. I want to know how to make it better. Give me suggestions as to future guests, all that kind of stuff. Okay, so before we move on, I want to quickly throw up the swag codes again, just in case people would like to get some of those cool sticker packs from Posette, possibly some Posette socks, although I think those are in very limited supplies. And so you can go to ak.ms/Posette swag and enter the codes that you see on screen. So
The swags are awesome. I'm repeating again because I have a ton, and I love it whenever I go to a conference getting these swags. So please go ahead and get your swags.
Okay, will do. And then let's go ahead and introduce the next speaker. I want to welcome Andrew Atkinson to the stage here at Posette. It has been such a delight for me personally to get to know Andrew. I think I first met him at PGConf New York City last year, which is going to be happening again this year in late September, if you haven't already checked it out. Andrew is the author of a book, High Performance Postgres for Rails, and he's a regular on the Postgres conference circuit. I think it's fair to say. He also served on the talk selection team for PG Day Chicago earlier this year. So for those of you who went to Hetty's event in Chicago, he definitely had a role in helping select all of the great talks that were shared there. He's on a mission to help Rails developers optimize their applications on Postgres. And if you ask him if he prefers UUID or BigInt, I think he's on team BigInt. And with that, let's dive into SaaS on Rails on Postgres.
Hi, everyone. My name is Andrew Atkinson, and I'm a software engineer and book author. I help companies with Postgres and Ruby on Rails. And my talk today is called SaaS on Rails on Postgres. It's all about building multi-tenant SaaS applications and the capabilities that we have to scale up and scale out with things like Active Record, horizontal sharding, and Citus. And this talk is really going to be aimed at back-end engineers using Ruby on Rails and Postgres, DBAs, and infrastructure engineers. Okay, so the overview of the presentation is, first we'll define some terms so that everyone's kind of on the same page. We'll look at SaaS, multi-tenancy, data isolation, and sharding. We'll be working with a multi-tenant SaaS B2B Rails app that uses Postgres, and we'll explore some options for scaling up with traditional Postgres. And then we'll also look at recently added capabilities in Active Record and Citus later in the presentation. And we'll look at options to scale out beyond a single instance. So for those unfamiliar with Ruby on Rails, let's just provide a little background on that. So first we have the Ruby programming language, which was created back in 1995. It's open source, it's a general purpose language, and it's implemented in C like Postgres. And then the Ruby on Rails framework came around back in 2004, almost 20 years ago. And it's a web app development framework. And then within Ruby on Rails, we have Active Record, which is most commonly associated with the ORM, but it also provides capabilities for managing the schema as well. So if we add columns and that sort of thing. And then Active Record has multiple databases support recently, including some newer capabilities around horizontal sharding, which we'll look at. So in our scale out overview section, we're going to move beyond a single primary Postgres instance. And we're going to look at Active Record horizontal sharding and look at Citus. I did want to call out this great visual website called Database Sharding Explained by Mahdi Yusuf, which is linked here, which has a lot of great diagrams about these different sorts of architectures. Okay, so we're going to work with a Rails application called Rideshare. It's a Ruby on Rails app using Postgres. Currently, it's not set up as a multi-tenant application, and it's just using a single Postgres instance. And some of the code samples that we'll be referencing in this presentation are available at that repository URL if you go to pull request 198. So folks are probably familiar with Postgres, and we introduced Ruby on Rails a bit. Let's just talk briefly about software as a service and some of the terms there. So software as a service is a delivery model, and SaaS apps typically generate or typically receive and process a lot of data. So there is some architectural planning that's required to process all of that data while still offering good performance and availability. Customers for SaaS apps could be businesses, which we would call B2B, or consumers, which we would call B2C. And B2B SaaS apps might have customers in the dozens, hundreds, or thousands of sort of range, where business to consumer sorts of apps might have thousands or millions. So it's worth kind of thinking about your customer profile. And SaaS apps are going to have common needs: authentication, profiles, plans and subscriptions, and other items here on this slide. And we're not going to really get into these as part of the application design, but I did want to recommend for those that are unfamiliar with these, within Ruby on Rails, there's a number of great software packages that can be added: Bullet Train, Jumpstart Rails, and Business Class, which address some of these common needs, where if you're getting a new Rails SaaS application going, this could be a great place to look to help accelerate your development. So we have a Rails SaaS application, and we want to add multi-tenancy to it. So for our tenants, we're going to actually call them companies. Tenants is a general term that could mean companies, accounts, customers, and we're going to use the term companies. So we'll have a companies table where when we add new companies to our platform, they'll have corresponding records. And then for table data that is related to that company, they'll have a company ID foreign key column on those other tables. So what if we weren't using multi-tenancy? Well, in that case, we would likely, as we add new companies to our system, we may want to, if we needed to isolate their data and possibly their compute, we would create a new database to store their data. And then we would optionally run that database on an entirely separate instance for that company. And while that does give us greater isolation of both the data and the compute, we're going to incur more infrastructure costs to run that separate instance, or more load on our current instance. And then we're going to incur more of a maintenance burden if we're running multiple instances. We need to monitor them, we need to upgrade them, that sort of thing. So let's continue on with adding multi-tenancy to rideshare. So we'll add a companies table, and we will be adding this company ID foreign key column to our table data that we now want to associate with specific companies. So for example, one of the tables in rideshare is called trips, and here we see company ID being added with a foreign key. And what we're trying to do with multi-tenancy is we're trying to gain efficiency in our infrastructure with fewer tables, database schemas, databases themselves, and server instances. And besides that, we're trying to gain flexibility as well. One of the advantages to building in this tenancy information is we can more easily identify our tenant data, and that can give us flexibility later if we want to move tenant data to its own instance, if we want to copy tenant data to a lower environment. We may also have external legal requirements for our tenant data, and again, being able to easily identify it is going to allow us to have some flexibility there. Besides identifying the data, we may want to limit access to certain tenant data. Postgres, let's explore some native capabilities with Postgres. So Postgres has row level security built in. And what we would do is we could create a role or a user object for our companies, which are our tenants. And then we could create a policy per table where we want to limit access that checks the current company ID against the role that is accessing the company. And by using this combination of roles and policies, we can then limit access to the table. Again, our client application will need to set up the to use the proper role when it's accessing the table. And if you want to check out a bit of code samples here related to row level security, check out the pull request I mentioned earlier. So we're still exploring some of the capabilities with traditional or single instance Postgres before we go outside of that. But since we are running on a single instance, we might run into some challenges. What are some of those challenges that we should anticipate? Well, we can't really allocate our instance resources like CPU cores, memory, IO operations to our individual tenants. And we'll have a shared set of additional resources like database connections and a single buffer cache, also called shared buffers, that will contain data from different tenants. So our observability for tenant operations might be more challenging because we're working within the single instance. We may also need to significantly over-provision our instance if we have really variable workloads between our tenants. An optional thing on the schema side, again, we're still working with a single database, is moving to composite primary keys. So currently we have traditional single column primary keys defined, for example, for our trips table. What we could do is change our primary key definitions to include the company ID that we've added. And it's worth mentioning that composite primary key support was added to Active Record 7.1. So with our Rails application running that version, we'd be able to take advantage of that. An example of what that would look like here is in the top is a traditional setup with a single column primary key. And on the bottom, we have a composite primary key with the ID and the company ID. Another capability in Postgres we could leverage for our multi-tenant design is table partitioning. And if you're not familiar with table partitioning, there's a few types that we can choose from. What we're looking at here is the list type. And what we would do is we could create a partition per tenant, or per company ID in this case. And what we would do then, besides creating that partition, we'd make sure that all of our queries in our client application have that company ID column as part of their conditions, which is our partition key. And we are going to run into some caveats that we'll need to work through, such as if we have existing unique constraints, and we want to be aware of increased planning time as we add more partitions. But our big benefit here for multi-tenant apps, if we've identified our tenants and they each have their own partition for data, is later on we can more efficiently and easily detach their data and archive it if they're no longer on the platform. And we can do that using the detach concurrently operation, which was added to partitioned tables in Postgres 14. So again, within single instance Postgres, we also can create schemas per tenant. So in our case, if we're adding new companies, we might create a new schema object. And within that schema, we'll have that company's tables. And the data in those tables would be specific or exclusive to that tenant or that company. And in that way, we can also even limit access to schemas. So let's look a bit outside of Ruby on Rails itself and Postgres itself. We can bring in another Ruby gem. We're going to look at two Ruby gems here. One is called Access Tenant. If you're not familiar with Ruby gems are the shared library code in the Ruby ecosystem, and they can be added to existing Ruby applications. So Access Tenant gem is going to help us with that row level multi-tenant data. So again, in our trips table from earlier, where we have a company ID column, we can set up Access Tenant to work with that. And then Apartment Ruby gem, it's not as well maintained based on what I looked at recently. So I put a little warning there, but it offers us schema-based data isolation. So if we do pursue a design where we've set up a schema per tenant, we might want to look at the apartment gem. So this is a little bit of a table representation of a recap of some of the things we've seen so far. So we're working within the same database on the same instance, and we're considering mostly data isolation here. We looked at table partitioning, which if we set up list partitioning and we have tenants identified as with their company ID column, and we've set up partitions per company ID, then we have kind of row level data isolation. We've looked at per tenant schema designs where we'd create a schema for each company that we add to our platform. And then we looked at 2 Ruby gems, apartment gem, which adds that schema isolation, and access tenant gem, which adds that row level support. And then we looked at row level security in Postgres, which allows us to add a security layer on top of row tenant data. So with that covered, then we've covered a number of capabilities related to traditional Postgres. And what we'll do next is look a bit beyond single instance Postgres. Before we do that, though, it is worth mentioning with Postgres, we have physical and logical replication options. So it's worth exploring that because we'll have a less complex topology. And with physical replication, we can send some of our workload there. We can send our read-only queries to our physical replicas. And there's even some interesting new capabilities with logical replication where we can take advantage of active-active replication with bidirectional replication. There's an example I have here linked that shows how to avoid primary key conflicts where you're receiving active writes on 2 different logical replicas instances. But this all being said, these are still the capabilities with kind of traditional single instance Postgres. We don't have multi-primary type of capability or sharding capability. There is a wiki page on the Postgres wiki about kind of a work in progress sharding design using foreign data wrappers. That's interesting. But we don't have this capability natively currently. And for that reason, it means row level or schema level sharding, where we might distribute pieces of our database to different nodes, isn't available to us out of the box with Postgres. So let's look a bit beyond. We'll look first on the application side. So the Active Record Framework, like we discussed earlier, it gained this new feature called horizontal sharding in 6.1, which was released in 2020. So horizontal sharding is a generic mechanism or a general purpose mechanism that allows you to set up shards how you'd like to define them. And what we can do with that is we can apply a multi-tenancy design to shards. So we could create shards per tenant or per company in our case. And with that code, those code samples I mentioned earlier, there's a bit of a demonstration there if you'd like to check that out. Here we'll just set up a company 1 shard, which is what's listed here. And in this case, what we're going to do is the kind of routing and mapping aspect is all going to occur in the application. So the Rails app will identify a tenant, and we're going to look at an example where it uses the HTTP request subdomain to do that. And we're going to have a setup where for each shard, we'll have a shard per company or per tenant. And those are going to be different databases with our application. Each database is going to have the same schema design. And these shards could be run on the same instance. However, for greater scalability, what we could do is run the databases on separate Postgres instances, all being read to and written from the rideshare application. So these are just some real basics about how you might go about setting this up. These are mostly just from the Active Record documentation. We have a shard record Ruby class on the top that's going to have our shard configuration. And then with Active Record multiple databases support, we've already configured in a YAML configuration file all of our connection strings to all of our different databases. And what we're seeing here is our company 1 shard. It's got both a writer or a writable database, and then it also has its own replica, which we can configure. And then in the bottom code portion, we see this shard selector, which is functionality that's built into horizontal sharding, and then this shard resolver. And what that's doing is it's taking the request subdomain, it's looking up the company, which is our tenant, and it's finding the company shard. And then we're going to keep that information throughout that session. So horizontal sharding is one option with application level sharding. Another option is Citus. Citus is a distributed Postgres deployment for horizontally scaling. And here what we're going to be doing is looking at sharding at the Postgres level. So we're going to have a series of nodes, and nodes will have a coordinator node, and then we'll have one or more worker nodes. And shards can be placed on the worker nodes. And as we add more worker nodes, we may want to reshard so that our shards are evenly distributed amongst our worker nodes. Citus is an open source extension. Some people call it a super extension since it changes the operational model quite a bit. And besides running it on your own, you can also take advantage of hosted services like Microsoft's Azure Cosmos DB or Crunchy Bridge. So Citus has some new concepts to learn. It has the concepts of distributed tables that we'll look at. And the code samples here are on the newest version available of Citus, which supports identity columns. And here we're setting up again our companies table and our trips table using identities. And we're going to look first at row level sharding with our company ID. And like we saw earlier, we've already kind of designed for multi-tenancy. However, if we hadn't done that, we would need to do something similar here and add this company ID tenant identifier column. Citus calls that a distribution column. And it's important to do because with that information, then Citus can take advantage or can perform a co-location functionality to make sure that shards are on the same nodes that have the same distribution column. So besides distributed tables, we also have reference tables. And reference tables are going to be, here what I've done with Rideshare anyways, it's going to be our smaller tables that will be replicated to all workers. And there are some caveats around changing primary keys and foreign key definitions. And it's also worth noting there's another Ruby gem called Active Record Multitenant that adds Ruby helpers for some of these SQL functions that we get from the Citus extension. So on the top here, we see we're creating two reference tables using these functions, create reference table and create distributed table. On the bottom, we're creating distributed tables for the trip request table and trips, both specifying our company ID distribution column. It's really important that we also change on our application side. We make sure that the distribution column or our tenant identifier column is always part of queries. On the top in red, I've shown how if we don't do that, we'll have a much slower query because each shard will need to be checked for whether it contains the data or not. On the bottom, we've set the company ID, and in looking at the SQL that's logged on the instance, we can see that it can immediately go to the correct shard for that table behind the scenes, and it's a fast query. So that was row level sharding, just the very basics of it. And Citus last year in 2023 added a second option called schema-based sharding. And with schema-based sharding, we don't need the distribution column that we've been talking about. Instead, what we do is we create a schema per tenant, and then the schemas themselves become the shards. So the tables in the same schema are then also co-located on the same node, and that way joint operations and foreign keys work like how we would expect. So what we see here is we've enabled the schema-based sharding option, and then as an example, we've created two schemas for two different companies, and we could then use the search path in Postgres to make sure that if we don't have schema qualified tables, we are reading and writing to the correct tables. The client application would need to do that, or we can also use schema qualified tables. So here's an image from the Citus blog. This is just showing two worker nodes on the left and right. And then on each worker node, we see three schemas on the one on the left and two schemas on the one on the right. And each of those schemas map to a particular tenant. And then within those schemas, we have three database tables, messages, threads, and users. So this is just showing a bit about how we might distribute our schemas across our worker nodes. So that's our brief look at different sharding options. Let's just recap a bit. Horizontal sharding in Active Record is going to be application level sharding, and it's going to allow us to separate out row data for our different tenants, which are companies in our example here, to their own databases, and those databases could run on their own instances. And the application is going to be responsible for identifying the correct shard, sending reads and writes to the correct place, and that sort of thing. Or alternatively, we could then, we could make a different choice where we decide to shard at the Postgres level by using Citus, we have two options there, row-based or schema-based. And that's going to be outside of our app for the most part, apart from distribution column query changes. And then we can either create schemas per tenant or per company, or we can identify rows and take advantage of row-based sharding. So let's wrap things up here, and I can provide a little bit of generic advice. With single instance or single primary Postgres with replication, we can take things very far in terms of scalability. And the benefit there is we retain all the normal sort of functionality with primary keys, foreign keys, joint operations. And these days, it's possible to get quite large instances with CPU, cores, memory, I/O operations. That being said, we should collect usage metrics about our query patterns, our data growth patterns, especially for shared resources on our instances, like our CPU, cores, memory, connections. And we want to identify those patterns and that data growth, and we want to measure its performance and plan for future states. And we want to consider costs, both infrastructure costs and engineering time, if we adopt one of these distributed database technologies. So some additional considerations here. Consider designing for multi-tenancy, even just to make identifying your tenant data easier, because in my experience, that gives you a lot of flexibility to move data around, copy data, that sort of thing. Depending on how you're hosting Postgres, check for its extension support. If you wanted to use Citus, it would need to be a supported extension. And then consider app level and Postgres level solutions and how they match the skills on your current team and sort of the maintenance plans your team would have, or how you might acquire those skills outside your team. And keep in mind that your application schema design will evolve. So with distributed databases, we'll be needing to make those incremental changes to every copy of our database, and that's going to be a bit more complex. So keep that in mind as well. Here's a lot of the resources that I used for this presentation today to prepare for it. These will be available to you. And I just wanted to quickly mention that I have written a book called High Performance Postgres for Rails. It's available for sale now from Pragmatic Programmers. Thanks for your time today for watching this. I'd love to connect on Twitter or LinkedIn. I've also got an email newsletter at pgrailsbook.com, and I also blog at andyatkinson.com. That's all I've got for you, and thanks again.
Well, that was pretty wonderful. Thank you, Andrew.
The way in which this talk summarized everything, right, to a practical set of advice, this is super, interesting view, right? Like what can, like single replication can take you so far, and here is what the gaps are, and here is what you can do with Citus, and also the people and human aspect of this, right? Like the skill sets and other things. I really loved this talk, Claire.
Yeah, there's a lot of learning going on. I wish if I weren't live stream hosting, I wish I could be scribbling notes and doing that whole sketch note thing for some of those talks, because it's a way for me to like internalize and carry away those lessons so they don't go in one ear and out the other. But I've got a job to do, so I'll stay focused on that job.
One other night out for that one. Recording notes.
Exactly. Now, I want to remind everybody that as you watch the talks, if you want to fill out a survey about just that particular talk right away, the talk survey is the way to do that. You can submit survey feedback on a talk and then another talk and then another talk, just one at a time. Works fun. The event survey link is on the right, and that's a one and done thing. It's about your entire experience across the entire virtual event. So please, feedback is a gift, and we would appreciate it. And then I think it's time to introduce our next speaker.
So I'm happy to introduce Kanchan Bharati, who works as a senior product manager on Postgres team in Microsoft. I've worked with Kanchan for quite a few years now. We were in the trenches together when Azure Flexible Server scaled up, and the service part of it. So his passion for data and his, like the intention of driving innovation all comes out in day-to-day work that we see, get to see from him. It's also like he has this dedicated way in which he tries to think about customers, and that drives a lot of decisions in Azure in general as well. So welcome to Kanchan and the talk, what enterprises like about Azure database for PostgreSQL on flexible server.
Let's go.
Hey everyone, thanks for joining. I am Kanchan Bharati and I am a senior program manager here at Microsoft in the Azure Postgres product team. Welcome to this talk on what enterprises like about Azure database for PostgreSQL. This session would be really helpful for the customers who are planning to migrate their on-premises workloads, especially Postgres workloads, into Azure, as well as our single server customers who are planning to migrate from single server to flexible server. So let's dive in. And as part of the session today, we will dive into managed service features, especially in our flexible server offering that our enterprise customers love to use. Some of these features include high availability, security, reliability, connectivity, performance, etc. Apart from this, I'll spend some time on discussing our AI capabilities on flexible server and how you can leverage PG Vector and Azure OpenAI. By the end of the session, you will learn why Azure database for Postgres flexible server is becoming more and more popular with our enterprise customers. So why PostgreSQL? PostgreSQL has a rich history that spans over 3 decades, and it is loved and supported by open source community. In 2023, it is ranked as one of the most popular databases in Stack Overflow developer survey. In fact, it is consistently featured in top 5 most loved databases in DB Engine rankings. And here at Microsoft, we are deeply invested in Postgres. But when you think about databases at Microsoft, Postgres probably might not be the first name that comes to mind. Microsoft is known for building world-class databases like SQL Server, Synapse, Cosmos DB, but many don't know that we are equally invested in open source workloads. Today, over 60% of our virtual machines run on Azure use Linux cores. We have 47,000 customers trusting Azure and choosing to run their open source workloads on our databases. We are deeply invested in open source Postgres in terms of our open source contribution as well as the managed service that we run in Azure. Last year, we started publishing a half-yearly blog that details everything that we are doing at Microsoft with respect to Postgres. The latest edition was recently published in the month of May, and it is a great way for us to share all the important activities that we are doing with the community, both with respect to our open source contribution as well as managed service. On a very high level, we have 5 committers, 9 contributors, and we have released more than 60 patches in the last 12 months. This blog also provides you high-level details about all the upcoming work that the team is doing as part of Postgres 17 release. I highly encourage you all to go and read this blog and provide your great feedback. So when we think about managed service on Postgres, we have 2 important set of customers, enterprises and developers. When we talk to enterprises that are migrating their workloads to cloud or simply evaluating managed services to migrate to, they talk to us about security. They talk to us about availability, reliability, etc. They want to have a trusted platform where they can run their mission-critical workloads day in and day out. On the other end of the spectrum, we have developers who need cost-effective access to bits. They want all the latest versions to be readily available so they can start testing it. PostgreSQL is a phenomenal database, but it can be even more powerful if it can leverage capabilities that exist in cloud. These capabilities could be fundamental capabilities like cloud storage or all the latest innovations happening in AI with PG Vector and Azure OpenAI. Here are some of the high-level benefits of using Azure database for PostgreSQL. You get maximum control for your database, like with your network isolation with VNet and private endpoint. You can tune your Postgres flexible server using server parameters. You can customize your maintenance window based upon your business requirements. Additionally, in terms of resiliency and availability, we allow you to configure zone redundant HA that gives you 4 nines uptime SLA. Apart from this, we also support fast failovers with zero data loss. And for your latency sensitive applications, you have the ability to co-locate your application and database within the same availability zone. Coming to our developers, we give ways to start and stop servers, use bustable compute to reduce their total cost. And also, one of the most important factors is we allow customers to use community version of Postgres, which is not a fork. So there is no vendor lock-in. So if you want to migrate your Postgres workload from on-premises to Azure or vice versa, you have the flexibility to do it. We recently conducted a case study with Enterprise Strategy Group to examine the potential cost savings of migrating on-premises Postgres workloads into Azure, and we saw 62% cost reduction when migrating these workloads. In fact, if we add the modernization layer on top of it, the customers are seeing more than 84% total operational cost reduction. This is a perfect example of how Azure managed OpenShift databases can reduce your total cost of ownership when migrating your workloads onto Azure. So let's dive into high availability and disaster recovery. So here is the Postgres flexible server architecture. If you see, we deploy Postgres flexible server on a Linux VM, and we store the data in the premium files, Azure Premium Storage, which maintains 3 copies of the data. So the data is highly redundant, and just in case if one data block gets corrupted, you can always rebuild the data copy using the other 2 blocks. Apart from this, we give you the flexibility to co-locate your application within the same AZ. So your application could be running on an Azure VM, AKS, or app service. And we stored all the database backups in highly durable zone redundant storage. So just in case if the complete AZ goes down, you have the flexibility to do a point-in-time restore using the ZRS storage into a different availability zone. Now let's talk about compute and storage. With a flexible server, you get 3 types of compute tiers: burstable, general purpose, and memory optimized. Burstable compute tier gives you 2 gigs of memory for 1 virtual core, and this is usually suitable for workloads that don't require full throttle of CPU. Coming to your general purpose, this is most commonly used by most of our customers. It gives you 4 gigs of memory for every 1 virtual core. Finally, at the high end of spectrum, we have memory optimized queue, which is suitable for faster transactional processing or workload that require high concurrency. And you get 8 gigs of memory for every virtual vCore, and you can scale up to 672 gigs memory and 96 virtual vCore. Coming to storage, we offer 2 types of storage with flexible server: Premium SSD and Premium SSD V2 that is currently in preview. You can scale up to 64 terabytes of storage. You achieve up to 80,000 IOPS and 1200 Mbps of throughput. If you see on the right, you notice that with 160 gig storage size, you can achieve IOPS of 80,000 and a throughput of 1200 Mbps. This is really important now because just to achieve higher IOPS, you no longer have to provision a disk which is, a bigger, drastically reducing your overall cost for your storage. The new Premium SSD V2 in Azure is simply stunning. When we compare it with our existing Premium SSD V1, SSD V2 are 4.5 times faster, allows you to reach up to 4 times more IOPS and scale up to 2 times the current size, which is up to 64 terabytes. But the most important benefit of using Premium SSD V2 apart from performance is its ability to scale in 1 GB increments, resulting in a lot of cost savings for our customers. As I mentioned, this is currently in preview worldwide, and we are expecting to do a GA release later this year. One of the other important features that most of our enterprise customers really love is the ability to perform near zero downtime scaling. With this capability, customers are now able to change their server size with flexible server with a downtime of under 20 seconds, which is typically very tolerable for any application making connections using sufficient read-write logic. So let's talk about backups. As you know, backups are really important for any organization. And As a managed service, we do the undifferentiated heavy lifting of managing this backup, running the backup, configuring, and retaining them based upon the credential customers have configured. With Flexible Server, we provide two types of backups. One is the automated backup, and the second one is the long-term backup. With the automated backup, you have the ability to retain your backup from 7 to 35 days. And when you configure automated backup, we take daily disk snapshots and archive the WAL files to Azure Blob Storage. But we do have enterprise customers, like financial customers, banks, etc., that have a compliance requirement to retain the backup for more than 35 days. In some cases, 1 year, 2 years, and up to 10 years. And to meet this scenario, we have rolled out a feature called as long-term backup that gives our customers the ability to retain the backup for longer duration using Azure Backup Vault. In terms of RPO, Geo Backup provides up to 1 hour of RPO. So there could be a data loss up to 1 hour when you're using Geo Backup. And with automated backup, you get a RPO of less than 15 minutes. But if you have to meet aggressive RPO timelines, then we recommend using read replicas. In terms of durability, Zone Redundant Backup provides you 12 nines durability, whereas Geo Backup provides you 16 nines durability, because Geo Backups are actually copied to another geographical location. So you have multiple copies across 2 regions. So they are protected from regional failures as well. So coming to restore, customers now have the ability to perform cross-subscription and cross-source group restore. For instance, you have your production instance in one subscription and development instance in other subscription. You can perform restore easily using a point-in-time capability. You can perform it to same VNet or a different VNet, and you can perform to latest restore point, a custom restore point within your retention window, as well as you can perform a fast restore, which is basically restoring a full backup, just to recover your data very quickly. So whenever you perform this restore, first we restore the snapshot, then we apply the WAL file, basically replay the WAL file to complete the recovery process for you. Here is a zone redundant HA architecture for Flexible Server. Whenever you enable zone redundant HA for your Flexible Server instance, we spin up one more Postgres instance on a standby. You have the ability to choose the availability zone. If you don't choose it, we randomly choose one of the available zones. And whenever you do it, we choose the identical compute and storage, and the data is synchronously replicated using native PG replication. And data has to be committed at least 2 places before the acknowledgement is sent to client. So as data is synchronously replicated, there is 0 data loss. And additionally, in the event of unplanned outage or whenever we are doing planned maintenance, there is an automatic failover to the standby instance. So this gives you a 4 nines uptime SLA. Coming to our disaster recovery, we offer 3 types of disaster recovery. Out of 2 are completely managed by our service, and 1 is customer managed. Geo Redundant Backup and Restore is a low-cost DR solution, but comes with a higher RTO and RPO. But if you have a DR requirement where you want to have a lower RPO and RTO, then we strongly suggest you to use either read replicas or logical replication. Let's dive into Geo Redundant Backups. The Geo Redundant Backups are available only in Azure paid region. So if you have your DR in a non-Azure paid region, then you should use read replicas or logical replication. Geo Redundant Backup is a low-cost DR solution because there is no server in the DR region. Only the backups are copied to the DR location. So whenever you enable Geo Backups, what we do is we take the daily full backups and the WAL files and we ship them asynchronously to the DR site. Let's see that in action now. So just assume you have deployed a Flexible Server in ECS 2, and the daily database backups and continuous WAL backup files are copied to the paid region, which here is Central US. And just assume there is an outage in ECS 2. As the backups are already copied to Central US, we will perform an on-demand restore, spin up a Postgres instance with the attached premium storage, and we will recover your data. So this is a low-cost DR solution for customers, and many customers love this because they don't have low RPO requirements, and this is usually suitable for many of our customers. But just imagine you have a different requirement where you want to make more aggressive RPO timelines, or you want to have a DR in a non-Azure paid region. So with read replicas, you have the ability to achieve that. You can have your production instances in US and maybe your DR instances in Europe or Asia because you have business units set up across the world. Apart from this, read replicas also gives you the flexibility to offload your read traffic, so you can reduce your load on your production system. as the data is asynchronously copied between replicas. The good thing is there is no production load. So basically, there is no production overhead when configuring read replicas. With read replicas, one of the challenges that we had earlier last year, especially for our customers who were performing frequent drill, was the inability to fail over and fail back very quickly. So whenever they were doing this GeoDR disaster recovery drills and they failed to standby server, they had to reconfigure the replication, wait for the replication to catch up before failing back, which was time consuming and resulted in a lot of customer frustration. We took that feedback and we worked relentlessly and rolled out this feature called as multi-region disaster recovery as part of Ignite last year. And this gives our customers the ability to run multiple machines under single virtual endpoint across multiple cloud regions. Now, as part of any planned failover and unplanned failover, you could switch back from primary to replica, and we drain the replication so there is zero data loss. And once that is done, application continues to run without any need to make any application config changes. So this is a really important feature that many of our enterprises really love and already using it. And it is very simple to use. If you go to your replica plate, and as you see on the right, there are two actions, promote to primary and promote to independent server. And you choose promote to primary and do a planned sync data before promoting. That allows zero data loss while using this feature. Finally, this is one of the very, very important features that I think more than 5,000 customers have already tried, which is called as in-place major version upgrade. If you ask any database administrator or a developer, it is a painful process to upgrade from a lower version of PG to a higher version of PG. Either you use a PG dump and restore or use the migration method using logical replication, which is time consuming, involves a lot of effort and also a business downtime. With in-place major version upgrade, we simplify this experience. With one click of a button, you can upgrade from a lower version of PG to a higher version of PG. The beauty of this feature is this is not the size of data operation, which means that even if you're migrating a 1 terabyte or a 20 or 32 terabytes data, most of the upgrades usually finish in less than 20 minutes. And there is no need to change any server name or connection strings. And if there is a failure, just in case, the data is automatically rolled back. So there is no user action at your side. And one of the other important benefits of using in-place major version upgrade is it gives you the ability to skip versions while performing upgrade. For instance, you are running a PG version 12 and you want to go to 15, you can skip version 13 and 14 and directly go to 15. And that works just fine. Now let's talk about AI. Azure AI is an extension that allows you to easily integrate artificial intelligence capabilities into your applications and workflows. This extension provides you a consistent experience to access Azure's AI services such as Azure Machine Learning, Azure Bot Services, Azure Language Services, etc. With Azure AI extension, you can use SQL interface to access Azure OpenAI and also create embeddings using SQL statements. One of the other important announcements that we recently made is the general availability of Azure Storage Extension. This allows you to enable import and export of data from Azure Storage. A common use case for Microsoft customers is the ability to export their data between Azure Blob Storage and Azure Database for Postgres Flexible Server instance. Thanks to Azure Storage Extension, our customers are able to do it, and our enterprise customers are already loving these capabilities. Now let's talk about PG Vector, this wonderful extension that became so popular in the last year. PG Vector fundamentally provides 3 distinct capabilities that allow you to take vector, which are numeric representation of text, and store them in Postgres using native vector data types, index them, and then query them to find the distance between them, which is how semantic search fundamentally works. It is a great capability that allows building next generation AI apps directly on your PostgreSQL instance. But there is a problem. Most of the database experts are deep experts in SQL. It is a language of their choice. When we have this ability to index and query them, this is all wonderful, but I can only use it after it is created. And this was basically a fundamental gap that we had. So in November, we shipped Azure AI extension, and I'm going to walk you through how that works. Imagine I got this simple table with some recipe data in it. I have this product ID, product name, product description, and product brand. Most of them are varchar columns. And I would like to add a new column using the vector data type. This is where I want to store the embeddings for this text data. How can I do this in Flexible Server? I can basically create an extension called as Azure AI. And once I do this, I can configure the endpoint to Azure OpenAI service, which will give you access to all the capabilities. Basically, in this case, I'm looking for, the capability to directly access the embedding models. Using an underlying REST API, I can pass the data from the database and get the embedding back and store them locally in the vector data type, as shown here. So once I configured it, then I can simply run a very simple SQL statement to update the data in the table, which are basically null columns previously, with these embeddings directly into the table. So this is what's happening. So now that I have created embeddings, this is fundamentally what is happening under the hood. I'm running an update statement, and I'm passing that update statement to Azure OpenAI, and Azure OpenAI runs it. Typically, the response time is anywhere from 50 to 60 milliseconds. So this API call does introduce some latency. So you need to think about how you want to architect the application if you're thinking about putting this on a critical path of inserting or modifying the data in the database. So if you see here, the data is in the table. I have the embedding on the right side of the table, and I can now use these embeddings to perform semantic searches. Now let's dive into security and connectivity. With Azure Database for Postgres Flexible Server, you now have the ability to configure networking using public access or private access. Even with public access, you can restrict the access to your flexible server by using network security firewalls and client access list. And with private access, you have the ability to use virtual network, which is basically VNet injection and private endpoint. And you can either use a CM VNet or VNet, different VNet. And we also support VNet peering with flexible server. Entra ID authentication is one of the most asked used features by enterprise customers, especially the financial companies such as banks, as they have a strict compliance requirement to disable local password-based authentication that comes with Postgres. So with Entra-based authentication, customers can now use Entra IDs to log into Postgres instances. Apart from this, additionally, they can use Microsoft Entra ID groups and Sunrise principles to access the flexible server databases. So we also rolled out another important capability last year, which is customer managed key. Now customers can use their own managed keys to encrypt the data as rest, and they can store these keys either using Azure Key Vault or using hardware security models from Azure. Finally, we recently announced the general availability of Microsoft Defender, and this helps you to protect against brute force attack. It allows you to, detect anomalous login patterns, and you can directly enable it by going to Security Blade on our flexible server blade. Coming to monitoring and observability, we have Azure Database for Postgres Flexible Server supports more than 60 extensions, and we have documented all the versions, all the extension versions that each Postgres instance supports. Apart from this, we give the customer the ability to customize their maintenance window. Usually, we have a 30 days gap between two scheduled maintenance, and we give our customers an advanced 5 days notification. And one of the most important items that I would like to add here is all of our minor version upgrades are part of our monthly maintenance. And we usually recommend our customers to schedule their production instances using custom schedule and leave the non-production instances to use system managed schedule. This ensures that their non-production instances are patched first before the production instances. Finally, we have server parameter control. Usually, these server parameter controls the default settings are suitable for most of the workloads, but if you have a requirement to tweak these parameters, we do give the customer the ability to tweak some of the server parameters, and you can do it based upon your application testing. We emit more than 70 monitoring metrics, and which are retained for 93 days. And all these metrics can be used for alerting. So you have metrics to report your IOPS, throughput, bandwidth, CPU consumed, etc. And one of the great capabilities is these monitoring metrics are directly integrated into, can be directly integrated to Grafana. So you can have your application, database, all in one Grafana dashboard. And if you want to retain it for a longer duration, you can do it using log analytics as compliance research. Then enhanced login. Now we give our customer the ability to store server logs directly, in the form of text files, and you can use Azure Storage Explorer to view this file. Apart from this, you can send this, log file directly to Log Analytics workspace, or to an Azure Storage account, or even to, just stream it to Event Hub. So I would like to leave you with some of Azure Postgres resources. So these are some of important resources that I would like you guys to, bookmark. So if you see here, aks.ms/Postgres is our Postgres, documentation. You can follow us on Twitter and LinkedIn. But one of the most important items is this Azure Postgres Feedback Forum, aks.ms/PG feedback. This is really important. You can actually, influence the product roadmap. There are many customers who are actually submitting whatever feature they would like to see in Azure Postgres Flexible Server. You can always submit your new request, or, plus one the existing one. So this is a great way to, influence the product roadmap. Then if you have any questions, don't hesitate to reach out at Ask Azure DB for PostgreSQL. Finally, thank you. I hope this session was useful for you, and I really appreciate you all joining in here. Thank you.
Hey, thank you, Kanchan. This was interesting talk. Claire, I hope you enjoyed the talk as well. So the few aspects which I felt like came out, right, like how enterprises really work in the cloud, and what sort of features are needed for enterprises in PostgreSQL. How to have the scaffolding around that. All of that popped out in various forms of features in Kanchan's conversation. A lot of these aspects is just not possible without the foundational Postgres open source core that we built on top of. So that is another angle which comes out from Kanchan's talk as well. So it was quite insightful for anyone from the enterprise world looking at this. Please tune in to Kanchan's talk. Cool.
Yeah, I don't know if I've seen the metrics. When you think about the Postgres user community worldwide, globally, like I'd be curious to see how many people use it running on a hyperscaler, right? Running on a public cloud versus how many people run it on-prem, right? Or manage it themselves as opposed to using a managed service. But obviously more and more people are running on the various clouds. And it's a great service if you want to focus on your application. But I still am friends with a lot of people who, work on-prem Postgres as well. And so I think there's probably as many different ways to use Postgres as there are people.
And one additional thing here is that a lot of the enterprises also have, Postgres in every cloud provider, right? Like there's that angle too, right? Which comes across on how Postgres is becoming this multi-cloud like environment which enterprises are catering to, and that's driven by their users, right, at the end.
So since Kanchan just gave this talk about Azure Database for Postgres, I thought I would pop up the Cloud Skills Challenge again. Obviously, there's a whole bunch of open source users who are attending the live stream, and maybe they're not looking to skill up on Azure, or maybe they are, right? Because skilling up in the cloud and seeing what that user experience is like for people is obviously useful, regardless of where you run your applications. So there are 2 Cloud Skills Challenges available with an opportunity to win the cool hoodies and t-shirts that you see on the screen. And the URL to get to them is aka.ms/Posette CSC. All one word. It shows in the lower bottom left of the screen. So please join in if it's something that you are looking to learn about. And I think then we should introduce our next speaker.
One quick question, Claire, like those ones, is it like a quiz kind of thing? Like I have not taken it myself, just for the viewers. Like
it's created by Microsoft Learn. And so you walk through kind of step by step to build up those skills. So all I can say is try it out and see what it's like. The deadline is June 24th because some people won't even start until after the event is going, and some people like to kind of proceed slowly. But I did notice somebody on Discord saying they'd already completed one of these earlier this morning. So it sounds like it is something that you can move quickly on, particularly if you're already familiar. So next talk, Richard Yan. So I first met Richard Yan back at PG Day San Francisco in 2020, where I believe he gave an in-person talk, and he's a principal support engineer at EDB, has been working in Postgres for over 20 years, a big fan of Explain Analyze, which I think for understandable reasons, a lot of people are. And because of his work in support engineering, I think that means he has a very good understanding of the user experience for Postgres. And his talk today is all about logging. So scaling the wall of text, logging best practices in Postgres. Play on.
Cool. Yep.
Hi, my name is Richard Yan. Welcome to Scaling the Wall of Text, Best Practices for Logging in PostgreSQL. This talk is for people who are new to Postgres, but also for those who want to improve their experience administering Postgres databases. Okay, so just a little bit about myself. I am a software developer and previously a support engineer for Enterprise DB. I've been working there since 2015, and currently I work with Postgres to build Golang and Python apps. I was also previously a pro web developer and eventually became a Postgres DBA. I've been working with Postgres since 2002, and it is my favorite database, and I really feel privileged to be able to share some of my experiences with you. So you might be wondering why we're doing a logging talk. It seems like logging is just something that just happens, but in Postgres, there are some things that need to be configured. Now, logging is important and often overlooked. Most people are interested in security, or maybe they're interested in performance. But the reality of working with databases is that bad stuff does happen. So in my experiences as a developer and also as a DBA and more recently as a support engineer, I've come across many customers and people who have experienced problems with their database, and because they need to investigate what's going on, they actually end up spending a lot of time. So when bad stuff happens, like a database crashes or the data gets corrupt, there is an investigation that needs to happen, and we have to answer certain questions like who caused it, or what happened, when did it happen, why did it happen, how did it happen, all these kind of things that you want to figure out so that you can prevent it from happening again. And this process, it could take hours, it could even take days, and that amount of time is a cost to the company or the organization, which is why we have to configure logging well. And when we are able to configure logging well, we can recover and move on quickly. As the saying goes, an ounce of prevention is worth more than a pound of cure. So spending a few minutes or hours configuring your logging well will save you a ton of hours later on to investigate into a root cause. Now, working as a support engineer, I've come across many different situations with customers, things like database crashing, replication being broken, inability to install some extension, or having problems with the upgrade. And all of these things we were able to resolve when the logging was configured well. Not only that, just as a person of curiosity, or a person who's responsible for database, logging can tell you a lot of things. It can tell you, things like how long the query takes. Maybe if you have a history of logs, you can actually kind of see how query time has changed over the past few months or over the past few years. It can tell you things like maintenance activities, like out of vacuum, performance bottlenecks, like lock contention, or maybe missing queries and stuff, missing indexes and stuff like that. So the log can tell you a lot of things that are useful, and if you have them available, it could actually be a very valuable thing for not only you, but also for your organization. So let's dive in. Let's talk about what Postgres has to offer. So the Postgres logging parameters, if you look in the PostgreSQL.conf file, you'll see that it's divided into 3 sections. First, it talks about where to log, and then then you can configure things about when to log, and then finally you can configure things about what to log. So I'm going to go through each of these step by step. Where to log. So this is a brief summary of parameters that are related to where to log things. So, for example, like log destination, you want to send things to a std out, like a log file on your server, or you want to integrate it into things like syslog or some other event logger. The logging collector is actually something that you can turn on and off, and that is sometimes useful in case it's just too many things are getting generated at once and you're trying to do an investigation and new information is coming in and preventing you from reading things well. So you can turn that off temporarily, you turn it back on without having to restart the database. Log directory and file name, these things are basically what you would expect. Now, the thing about log directory is that it logs things into Postgres, the same directory as PostgreSQL.conf and pgxlog by default. So it's that pgdata directory. I've seen many people use a separate partition for the log directory, and this is a good idea because some of that I/O that's used to write to the log, you don't want that to be interfering with the I/O that's being used for retrieving data from the database. So a custom partition is a good idea. By default, the log file name is just PostgreSQL-year, month, day, hour, minute, second .log. For some people, that might be a little too granular, so they just do year, month, day. Some people may need to prefix it with something else besides PostgreSQL. Maybe they want to have a log name include their application or their product name, depending on what their needs are. So you can configure that as well. Log file mode is basically like the chmod. It allows you to change who gets to access the log and who gets to write to it, things like that. The last 3 are related to rotation. So for some, having too many log files around might be a bit excessive. So they will rotate once a day or rotate, maybe they don't want the files to get too big, so they rotate at a certain size. And depending on those, the rotation, once the rotation happens, the new location may be the same file name as something that already exists. And depending on your needs, you can tell it to truncate that file. So like, let's say today's Thursday, and I set my log file as PostgreSQL-thu.log. If I rotate and it's Thursday again, do I want to truncate that or do I want to append to it? That log truncate on rotation is the parameter that allows you to control that. Okay, so that is where to log. The what to log, I'm going to go into that now. Things like log min messages and log min error statement. It allows you to have some control about when the message gets logged into the file. Log min messages will print a message saying like index was created or this person logged in. So these kind of messages get printed. Log min error statement, this is the level at which not only is that message written, but also the statement that caused that message to be written. So like, for example, like if you have a syntax error, instead of just saying, a syntax error, it would say syntax error, and then the query that caused the syntax error. So that way you can actually figure out what caused that syntax error. Okay. Log min duration statement is a parameter that allows you to filter out the slow queries. So anything that takes more than this minimum time, so like let's say 1 second, any query that took more than 1 second will get logged as the statement itself will get logged. The last three that I have to share here are involve sampling. So these are kind of newer. They were introduced in versions 12 and 13, and this is for commonly logged queries. So like, let's say you're logging everything. Now, if you're logging everything, it could be very noisy, and especially for the very commonly run queries like select everything from users list or something like that. These three parameters allow you to say, hey, I'm only gonna sample stuff that's that maybe like 50% of those times, right? The sampling rate, I'm going to sample only a certain percentage of those queries. So that way you don't actually create too much noise in the log. Okay. Finally, the when to log section. So I'm going to give you I'm going to give you some examples of the when to logs. So if you can see these two log message samples, it says a time and then a particular number, and then it also says this fatal roles, some users do not exist. The next one says warning, right? So this word fatal and this word warning, this is the logging level, and the logging level are the things that we set for log min messages and log min error statement. So like I mentioned earlier, log min messages will print out the message, there is no transaction in progress, or role some user that does not exist. And the log min error statement will also provide any query that was issued to print those two messages. Now, the other values that you can use are debug, info, notice, warning, error, log, fail, and panic. Now, that's a lot of different options. And how do we choose? So the debug level, so you can see debug 1, debug 2, those levels are primarily for PostgreSQL developers. We're trying to figure out what a variable's value is, or where a bug might be. So for most users, we don't need to use debug. Info is something that is implicitly requested by the user. So let's say I say vacuum verbose. Now, because I said verbose, it's going to vacuum and print other stuff in addition to the vacuum. Now, that stuff is going to be written to the log as info messages because I requested a verbose vacuum. So it'll provide that information for me. Now, notice level is Postgres trying to provide proactively some information that might be useful to the user. So let's say I created a primary key. So if I create a primary key, it's a constraint. So when I say I want to create a primary key, Postgres says, "Oh, I have created this constraint for you." But because I wanted the notice level, it'll also print saying, "Oh, by the way, I created an index because in order to have a primary key, we need to have an index. So I created an index for you." So that notice, it provides that extra bit of information for something that I wanted to do. Okay. Warnings are things that are potentially dangerous, but not at a database level. Like, for example, if I actually have a commit statement, but I didn't begin a transaction. So let's say I updated some tables and then I hit commit. Because I didn't begin the transaction, Postgres will say, warning, no transaction is progress. So just as you see on the screen. So that could actually be a signal to me as a developer hey, I need to begin a transaction somewhere in my Python code or my Java code or whatnot. Because if I inadvertently do something like I update all the tables, all the rows of a table, then I might introduce some data corruption by inadvertently updating more than I should. So that warning tells me, the developer, hey, go look somewhere for something that if you don't fix and something bad happens later, it might cause widespread chaos. The error level is any kind of command that any kind of situation where the command had to abort. So, like for example, like a syntax error. Because I can't finish a query with a syntax error, it prints out an error message to the log. The fatal and panic are similar. Fatal is any kind of situation which caused the current session to abort. So, like let's say I try to log in with some user. The some user doesn't exist, so therefore the session has to end. So that's why it gets logged as fatal. And panic is the one that causes the entire database to crash. So let's say something is missing or some kind of segmentation fault happens, then a panic will be printed to the log. The one I haven't mentioned is the log level. So the log level is any kind of information that is interesting to the administrator. So for example, like let's say I had a checkpoint. The checkpoint, when that happens, a log level message will be put into the log. So that way, later on, if I want to find out when the last checkpoint happened, I'll see, oh, this is when the last consistent state is available. Okay, so that's when to log. So by setting the logmin messages and logmin error statement, you get to these particular levels, you get the behavior that you want. Okay. Now, finally, the what to log section. The what to log section is things like log duration and log statement. Now, we don't want to be confused with log min duration statement for these two, which I'll explain to you very shortly. And then the last two, log replication commands, yes or no. And then finally, what I think is the most important parameter, which I'll talk about in a few seconds, is log line prefix. Okay, so just a quick bit of clarification of log min duration statement versus log statement and log duration. Like I mentioned earlier, log min duration statement logs the statement and duration, but it does that after the query has finished. So, so like let's say this query took 1 second. Now, it's only going to know that it took 1 second. Then it can actually print this, right? So it has to wait till it finishes to be able to write, hey, this query took this many seconds. And because it happens at the end, it doesn't, I think Postgres community has decided that it's not really that relevant to log the parameters. So it just says, hey, this query took this long. So if you have any placeholders in there, they won't get logged. Now, on the other hand, log statement will log the statement before the query is executed. And then in addition to logging that statement, it will log all the parameters that you passed in to that query. Now, the thing is, because you don't know when, how long it took to run the statement, because you're printing it before it ran, we can't filter. So we can't only filter the ones that are slow. However, the nice thing about this this parameter is that when it's turned on, because it's logging everything before the query is executed, you'll be able to track, let's say the query causes the database to crash, or the query causes a fatal error. Then you can actually go back and say, oh, this is the last query that happened before the crash or before this person was kicked out. So that's actually very useful. So it is a give and take. It's nice to be able to log both of these, to use both of these parameters, but knowing that log statement logs everything because it can't filter, you may or may not want to have that on all the time. Having said that, log statement does allow you to filter on all statements, including reads and writes, but you can also set it to only log write statements, anything that modifies the database, and then you can tell it to only log DDL changes to your tables and your indexes and stuff like that. Okay. I mentioned earlier what I think is the most important parameter, which is logline prefix. And this is the value that I think everyone should use. Basically, it is a timestamp, a process ID, line number in the session, transaction ID, username, database name, application name, and client host address or host name. There are other values that you can use as part of this logline prefix. So every line in the log will be prefixed with whatever you set it to be. And this is a list of what available wildcards there are. I know it's a bit small to see on the screen, but this is something that's completely screenshotted off the documentation. So please take a look at the documentation if you want some more information about how to use logline prefix. Now, the nice thing about providing more information to logline prefix is that it provides more clarity to anyone who's reading the log. So you can get more information about who did what happened, when did it happen, where did it come from. It also gives you control over filtering and sorting, grouping different lines together because like let's say you have several users using a database at once. Somebody might log in and then a lot of other activity might happen by someone else. And then finally that first person issues a query maybe like a minute or two later. To be able to use logline prefix with Unix tools like sed and awk or grep, it will allow you to be able to sort that all out and say, hey, this user did this stuff in this session, and this other user did this stuff in this other session. So it does give you that kind of flexibility. The reason why I want to make a big point about this is because the default value for logline prefix is just two wildcards. It's just basically a timestamp and a backend PID. And before Postgres 10, which is already obsolete, it's actually blank. So it's really up to the users and administrators to be able to set this properly so that you actually have ability to do good research on a log later on. In my experience as a Postgres support engineer, I actually compiled a list of different PostgreSQL.conf files that our customers were using. And I discovered that only 40% of the users, actually 40% of the users are keeping the default. So 60% users change it, but 60% is actually not everybody. So some people out there might not be aware of the importance of logline prefix. So don't neglect this parameter. Now, just to give you an example of some of the things that I mentioned earlier about logline prefix, here's an example of somebody dropping a table. Now, the default only shows the timestamp and the PID, right? And it doesn't show you who. So it could be a bit tricky to figure out who dropped this table. However, if you actually have the logline prefix like I had mentioned earlier, you'll see the timestamp, PID. This is the second entry of this person in the session. The first entry would be connection received. So second entry, this person was authorized to use the database. Third entry, this person actually dropped the table. Right? Transaction ID, it shows you that it wasn't done within a transaction. It was just issued straight into PSQL or by some application. Username, database, and then the client IP address. So where this query came from. So as you do research onto who dropped this database, you can actually pinpoint it down to this server or this laptop or whatnot. So again, logline prefix is very, very useful and important. Okay, so I've talked about the different parts of the PostgreSQL.conf, what the logging parameters are, which ones to focus on. in the remaining time that I have, I want to just share with you some tips on what to look for. And I know I don't have a lot of time, but I'll try to quickly go through them. So first, try to look for spikes in different logging levels. Warning, fatal, and error are the ones that you want to kind of pay attention to. If you use something like Splunk or some other log aggregator, try to filter on these keywords. So that way, if you ever see a spike on them, like maybe right around the time of release of an app, you'll discover, oh, hey, actually, I got a spike on errors. And then when you actually look into it, oh, maybe this person had a typo with their table name or had a syntax error in their query. So that logging level is actually logging based on the level, the keywords are actually very helpful. Pay attention to hints. So if you look for the word hint in a log, it actually might give you some ideas into what some performance issues are being encountered by the database. And then, again, like I mentioned earlier, be sure to use Unix tools like grep and sed to be able to figure out different patterns, group the entries together, so that way you can see what different users are doing, and that'll definitely speed up your investigation after an incident. Pay attention to application bugs. Like I mentioned earlier, like with logging levels, if you have application bugs, you'll probably see a lot more of that keyword error. Okay. If you ever see anything about replication, be sure to check your replication slots. Be sure to check your wall keep segments parameter to make sure that these are set properly. And then look for keywords like dead but not yet removable when you're working with auto vacuum. So if you see this might indicate that there might be some kind of idle transaction somewhere or some really, really long running query that's preventing auto vacuum from working properly and completing its job. Look for temp files. When you see temp files being created, that probably indicates that work mem is too low, and you might need to increase your work mem so that your sorts may be done faster and all within memory. And then finally, look for things like locks and deadlocks, and cross-reference them with PG site activity to see maybe some kind of queries are holding locks too long. Maybe you're forgetting to roll back or commit a transaction. Okay. So in summary, be sure to set your logline prefix. That's the most important variable. And then log as much as you can. You can use a separate partition if you have to. And then be sure to look for spikes, look for keywords, and see if they correlate with any kind of change within your application stack. And pay attention to patterns. And then there's some additional tools out there that I didn't get to talk about. Things like PG Badger and AutoExplain. These are actually very helpful, especially AutoExplain. It gives you some window into nested queries. So if you ever have sub-selects or queries that are run within a function, AutoExplain will actually give you some additional information to be able to do some investigation into any kind of performance issues. Okay, so with that, that's the end of my talk. I'm really thankful. Thank you for joining. Glad you were able to come listen. I really hope that it was useful to you, and looking forward to, I hope that you guys, you can also find other presentations at Posette very useful. Have a good time.
Another useful, actionable talk full of practical tips. One of my teammates, Alicia Kuharczyk, I think I said her name right. I had mispronounced it for years before I realized I was mispronouncing it. Anyway, she's a big fan of PG Badger. And I know other folks who strongly advocate for using AutoExplain. So it was good to see Richard include those in his wrap up at the end.
Yep. And also some of the tips on, the pitfalls that you get into, right? Enabling logging and, out of disk, and how to make sure that doesn't happen to you. And also getting more insights by specific tips that we got, just reflecting on what you just said, Claire, in sync there. Cool.
Okay, so quick reminder, if you want to give feedback on Richard's talk, the survey link is in the lower left-hand side of the screen. The event survey is separate, right? And so that's on the lower right-hand side of the screen. People love feedback, so just wanted to drop that in there. If you've been here on the entire live stream and you're rolling your eyes because Claire, you said that 5 times already, I just recognize that some people just come for 1 or 2 talks and then they plan to watch the other talks on YouTube later at 1.5x speed or while they're walking the dog or whatever. So that's why I keep seeming to repeat myself. Apologies for that. And then the other thing I wanted to do is say, if you did want to submit you want the codes in order to fill in the form, in order to get some of the cool Postgres community swag, you can just go to aka.ms/Posette-swag. And I believe the codes that are showing on the screen should work. If not, just go to the Discord, to the Posette Conf channel and tag Aaron W. and he'll get you some new codes. So that's what I have in terms of reminders. And then I think we should dive into our next talk.
Yep. I'm so happy to introduce Gayathri Paderla, who works in the Postgres performance team in Microsoft. I've been working with her on a number of incidents, customer situations, and the kind of depth and details that she brings to performance, understanding it from a customer angle, not really getting influenced by, okay, let's do something different kind of thing, but like very, very focused on customer angle when it comes to improving performance. So I'm looking forward to this talk on making Postgres inserts faster on Azure. Also, I just wanted to give a shout out to Gayathri. Like, she likes hiking, camping, and cooking. And she's also involved in a non-profit organization called Team Asha, which is a running-based non-profit organization. Would like to highlight that as well. Let's get into the talk. Let's go.
Hi all, I'm Gayathri Paderla. This talk is about how you could make your inserts faster. And any PostgreSQL developer who's dealing with data uploads, this is the best talk for them to go through. I'm Gayathri Paderla. I work with Microsoft as a PostgreSQL performance expert. This talk is coming from the experience of multiple customers who have come to us asking why their inserts are slower. So to improve performance, what all we did, what all suggestions we have provided them based on their workload is what is driving this talk. I'm a mom of 2, happily married, and have a pet named Bruno, who is a chocolate Labrador. I love hiking and cooking. And I have been in Seattle for a long time, and I love hikes in Seattle. Currently, I'm living in Atlanta, and I'm exploring hikes over here. Thank you. Moving on to the talk. The talk is going to flow through these items, like how using unlock tables is going to help inserts, using copy command, how it's going to help, using batch inserts compared to single row commits, how that will faster your inserts, how disabling constraints, triggers, and indexes are going to help you with faster, improved performance of your inserts. Partitioning a table. Most of the times we think partitioning a table is going to help us with the selects, but now it also helps with the inserts. Coming to HA and RAID replica. What is the best time to enable your HA and create your RAID replica is what going to be presented here. And last but not the least, tuning server parameters. So some of the key scenarios where we have seen customers coming to us asking for help is during bulk uploads, daily imports or incremental uploads, and transactional inserts from different applications. And this is what I'm going to cover, all these 3 scenarios in all the proposals or suggestions which I'm going to present to you in this talk. Going ahead with unlock tables. So unlock tables are a best approach when you go for one-time bulk uploads or incremental uploads where you are using some staging tables. So because it's a staging table, you don't need the data to be stored there. So in such cases, you could use unlock tables. Unlock tables are the tables which do not generate any wall files, which means there is no delay or latency of generating the wall file, putting it in the buffer, flushing it to the disk. All this overhead is removed. So below is the syntax to create an unlock table. Create unlock table name, and you can automatically convert a log table to a unlock table and vice versa using the alter table command. Normally, I would suggest people, if it's not a staging table, but you want your inserts to be faster, I would suggest them to go ahead with an unlock table. And then when it is a quiet time for the server, then change it back to log table. Changing an unlock table to a log table would take a lot of time, but because it's in the slow impact period of your server, that might really help you. There are some pros and cons leading to unlock tables. The pros, as we have already seen, that it's gonna be very fast. This I have run a performance test, and I have seen that the inserts are 5 times faster and your copy command is going to be 10 times faster. Whereas the second pro is that it does not generate any wall files, which means all the overhead on the server, which these wall files causes by utilizing the buffers or by utilizing the IO resources, using which it flushes these wall files to the disk, is all removed. However, the con here is if there is any crash happening, you're going to lose all the data in the unlock tables. And also, if you have HA or replication slot, or if you have a read replica, your data will not be reflected in those scenarios in your standbys or in any of your logical replication slots or in your read replica. So if you have any of these and you want the data to be replicated, you should convert the unlock table to a log table during your low performance time. Coming to using a copy command over insert, whether it's a bulk upload or an incremental upload, you can always choose to go to a copy command. Even the transactional, instead of using inserts from your application, you can use a copy command to push the data into the database, because it avoids all the SQL processes in between. The inserts uses the SQL process where it goes through the optimizer and stuff. That is avoided here. And it will import directly from the file system to the database table. So the transfer is pretty fast and more efficient. It reduces the stress on the database server, and the logging is also reduced because one copy command is going to generate one single log file. And once that log file is generated and your copy command is completed, then the log entry is gone. And there is no network latency involved here. It might be risky using a copy command because it's just one single log. However, keeping the atomicity of the table, I feel this is the best approach, instead of not understanding with an insert how many inserts were completed or how many were not completed. So this is the best approach. Coming to batch inserts versus single commits. In most of your OLTP applications, you would end up seeing single inserts coming from the application. Suppose it's a medical or it's an insurance or any sort of domain, right? If you're adding one single customer by customer, then single commits happen. So in such cases, what you could do is you could do some micro batches, like batching up 10 records at a time, or batching records with all records submitted in 1 minute and then submitting it to the database server improves your inserts performance 100 folds. So when it is a multi-row insert compared to a single row insert, your number of IO resources being used for a multi-row insert is very less compared to a multiple single row inserts which is happening. So inserting 100K records in one single transaction is very, very fast compared to performing 100K separate transactions with single row inserts. So that is going to be a big hindrance for the server performance because each transaction is using up the CPU resources and the IO resources. And in this case, in single row inserts, the IO resources are going back and forth between the buffers and the disks and using up all the IO resources. Removing and disabling constraints, triggers, or indexes. When you're doing a one-time bulk data load, we suggest you to drop the indexes, drop the constraints, and drop the triggers associated with the tables to which your data is being loaded. So once the data is loaded, then you can recreate the indexes or constraints or triggers back. Specifically, when it comes to constraints, the unique constraints and the foreign key constraints are a big hindrance to the data loads. When it comes to incremental daily loads, we would say remove any unused indexes, because any insert you do, it's going to go and update all the indexes. The PG engine is going to go and update all the indexes available on that specific table. So be very careful on how many indexes you have in the table and how many columns are there in those indexes, because that will help you to judicially understand how you want to build your index. And based on that, automatically your insert performance is going to be very performant compared to the way if you have tens of indexes and if you are not using most of those indexes. So that's a big hindrance on the performance. So post all the data load is done, I would say create your indexes, create your constraints, create your triggers. And because these are maintenance activities, you could update some of your server parameters like maintenance workmem, max parallel workers, and max parallel maintenance workers based on your server config. Partitioning a table. How partitioning a table is going to help us when it comes to incremental daily loads. Having a partition table and inserting the data into those partitions is going to be much faster. One, because it's targeting one single partition. Second, it's parallelizing the data flow and the data load to multiple different partitions. Third, if an auto vacuum is running, it's running only on the partitions for which a change has been made. Also, there is one more thing where if you have some data to be deleted from the partition, then that partition alone is being dropped. But the rest of the tasks for uploading the data into other partitions is still continuing. So instead of inserting a data into a 20 GB huge table, if you partition it into 10 different tables, then each table is only 2 GB, and activating and inserting the data in those partitions is much faster. Coming to HA and read replica, we suggest during migrations or one-time bulk uploads to enable HA after the upload is done, and then creating the read replicas and setting up the logical replication slot. HA is nothing but having a primary and a standby server. So whenever you enable the HA and then do a data load, what happens is whatever the data is loaded into primary, its WAL files are taken and implemented on the standby. And then once the primary gets an acknowledgement from the standby, then only the next set of transactions happen. So to avoid this all round trip, we suggest customers to enable HA later in the game after the data load is done. Creating read replicas, though it's an asynchronously replicated, but that replication again uses up some of the CPU resources and IO resources. And again, here also we suggest going ahead with doing the bulk upload first and then going ahead with creating the read replica. Coming to setting up the logical replication, it's always suggested to do it after one whole bulk upload or after the migration is complete. Moving forward to tuning the server parameters. Given all the above suggestions would have improved your server performance, inserts performance already a lot better. To further dig into it, we could tune some of the parameters like wall buffers, shared buffers, max wall size, auto vacuum, and checkpoint timeout. Let's start with wall buffers. What does the wall buffers do? Why do we need this parameter? What does it do? How is it going to impact our inserts performance? Let's talk about it. What does this do? So based on whatever, suppose you give 16 MB as a value for wall buffers. So here the PG writes the walls to the buffers until it reaches 16 MB and then it starts flushing the wall files to the disks. So which means with 16 MB, if your transaction is huge like 20 MB, you end up frequently flushing the wall buffers to the disk, which means there is usage of IO resources. And as your buffers are filling up, the next transaction will not happen until the buffers are emptied. So that's again causing a delay. So to avoid all that, you could increase your wall buffers and it would be based on your server config. It could go to a higher value of 128 MB. And if you set it lower, we know what the problems are going to be. So it's always recommended to set it to a higher value, whether it be one-time uploads or incremental uploads. Coming to shared buffers. Shared buffers are currently set at 25% of your RAM in Azure database for PostgreSQL flexible server. However, to improve your data upload and the incremental daily imports, you can change or increase your shared buffer values to 40% of your RAM, and you could go a bit further up on that, but beware that these are the same buffers which are used for other maintenance activities too. So please be very judicious in using the shared buffers or increasing the shared buffers parameter. Next, coming to max wall size. So max wall size and checkpoint timeout are very much interlinked. Both of them trigger the checkpointer. So the max wall size is determines how many wall files need to be filled in before the wall files are getting flushed to the disk. So normally the max wall size is set up based on your server config. So you could increase it up to 64 GB. However, I wouldn't suggest, if you have a very low RAM size, we wouldn't suggest you to go for that. Normally 2 to 4 terabytes storage size would use a 64 GB of max wall size. So during bulk uploads, based on how many wall files are getting generated, you could tweak this parameter to accommodate the number of wall files and then dump it to the disk. So this reduces, by increasing the max wall size, you're reducing the IO resources and also you're avoiding the checkpointer to run frequently. Coming to auto vacuum. With all the above scenarios like bulk uploads and incremental loads, we suggest you to turn off the auto vacuum, load the data, run a manual vacuum, analyze on the tables which have been inserted with data, and then turn on the auto vacuum. This way, we are avoiding any hurdle or any utilization of CPU or IO during a bulk load happening. This will help us with conserving all the resources towards the data load rather than on the maintenance activity like auto vacuum. Now tuning the checkpoint timeout. Suppose in a bulk upload, your bulk upload is going to take 1 hour time. To make sure your checkpointer is not running in between that 1 hour time, you can increase your checkpoint timeout to 1 hour. By default in Azure PostgreSQL, it's set to 10 minutes. And you could set it back to the default value once your one-time bulk upload is done, which means your checkpointer is not using up the CPU and IO resources when your data load is happening. Thank you.
Wow, this blew my mind away completely. Like the insights just, shines out of the blue, comes out, and like really, really, like critical insights are there as part of these.
So I was on the talk selection team for Posette this year, along with, 3 of my amazing teammates. And you always want, I think, when you're involved in Postgres events, there's a commitment, and this is true across all the community events I've been involved with. There's a commitment to try to make sure that you accept and welcome some first-time speakers. And I believe this is Gayathri's first time public speaking about Postgres.
Wow, that's actually unbelievable, because in a short window, Gayathri took us through a major problem or like a major challenge, and then like resource usage corresponding to that. If you use this feature, what happens? If you don't use this feature, what happens? Pitfalls to fall in, server parameters that could be used, auto vacuum configuration, checkpointer configuration, all like in a way that we can understand. All right, like that was the whole secret of the thing. It's really awesome. Thanks, Claire, for bringing all these speakers into picture. This is thanks to Gayathri for an awesome talk.
Yes. And if I know from paying attention to the Discord that Gayathri is on the Microsoft open source Discord right now. So if you have any questions based on the talk you just listened to, just pop on over there, aka.ms/open source Discord, and just go to the Posette Conf channel once you get there. So before we dive into the last talk of the day, there were 2 things that you and I were preparing that we decided that we wanted to talk about briefly. And the first is, for those of you who've listened to these speakers today and who plan to listen to the other live streams tomorrow and the next day, if you've ever wondered, should I submit a talk proposal? Should I try my hand at getting up on stage and sharing my experiences, my failures, my successes, my takeaways? I'm always encouraging people to give it a try, because it is a great way to solidify your expertise. There's so many benefits. I've given a whole lightning talk about the benefits of like fighting the butterflies and submitting a proposal. But what was really interesting, I'm just going to tell this story about chickens. This year, Teresa Giacomini, who is the chair of the organizing event, she got advice from Flor Dre saying, hey, I was part of this other event. They did a virtual meet and greet. And so instead of just here's what you need to know to be a good virtual speaker, Teresa made it a social meet and greet. And as they were doing it, there were 2 of them, of course, because time zones, right? So one early in the morning Pacific, one in the evening Pacific. And Teresa went first to demonstrate like how quick these virtual meet and greet introductions should be. And she said, I'm Teresa, I'm the chair of Posette, and I love to garden and have chickens. So that's not me, that's quoting Teresa. But, then the next person spoke up. Flor Drace is like, oh, I have chickens. And then somebody else is like, I have chickens. And then before you know it, so many of the speakers actually have chickens. Or people would say, hey, I don't have chickens, but I have children. Or I don't have chickens, but I have a dog. And it just became a thing. So that's why if you see, if you know, comments over on the Discord, it's because there's this chicken theme that has gone throughout Posette 2024. But more seriously, like you are also a speaker this year at Posette, and your talk is in one of the upcoming live streams, right?
Yes. It is a physical replication talk that Meli and I did is coming in one of the live streams.
And that's Meli Mutlu. He's one of the open source contributors to Postgres, right? Based in Turkey? Okay.
Yes, exactly. So we had a lot of fun. First of all, some of the things that happened during these talks is that you kind of, when you prepare, you learn more than what you are doing before, right? Like kind of thing. Even though you have seen the code, you have done stuff, but then when you prepare and present, it's a different sort of learning, and you get to learn more. There's more clarity. But then one thing that I couldn't really gauge before was that the energy that we deal with when you are in a virtual format is different from the energy that you deal with when you are in a physical like conference, right? Like when you are giving the talk, there's sometimes energy flowing across the audience, right? Like there's like high energy people interested, then you are also like up, but then it goes down, you are also like, so in the virtual thing, it you had to do a lot more practice. I'm not saying I got a lot of practice yet, but me and Meli, because we were co-presenting, it was a little more like easier, and Teresa helped us a lot and producers helped us a lot. But at the end of the day, that was one difference that I felt was, how to think about this in terms of a virtual format was something to learn and take forward and, keep pitching at it, right? Like.
It's definitely a slightly different skill set. You have to look at the camera, and some people tape a photo of someone they love right next to the camera so that they have a look that is of affection as they look at the camera. So it is a different skill set. And I definitely know people, myself included, who get energy from the audience. So when there is this in-person audience and they're sitting on the edge of their chairs, that's really motivating, and your adrenaline starts running, and it contributes to, the experience. But I think the cool thing, of course, if it's virtual, is all the people that you're going to reach online. And the long tail of it too, not just during the live stream, but afterwards on YouTube.
The barriers are so low that, as you mentioned, Claire, in the beginning, right? Anyone with internet access, they get access to this, and we can spread this wider. It's available right away, and a lot of those things where we can have folks more engaged into this, and they can all learn.
So the other thing that I wanted to pop up here, if I can, is to look at, and let's see how I can do this. Go like this. Talk a little bit about pgconf.dev. That happened just a couple weeks ago.
Yeah, but by far the most exciting conference that I've gone to in my, I would claim, in my 22 years of the software part of it. The people, right? Like hallway tracks were so awesome, right? Like you get to meet people. Like there's a virtual thing. There's also that meeting people physically and stuff like that, like directly. But it's also, there's so much of discussion that is floating around, right? Like technical parts of this. There's this open source. Hey, how is open source carriers, how they emerge? There's aspects of how open source people, like what they like, what they don't like, and also getting to know some of them who have really been like, okay, you look at them and think, oh, what an amazing job they're doing. Just having to talk to them, right? Like, and getting their views. And the most important thing, or like the most exciting thing for me, was that when I went and spoke to some of those folks, right, it was not like I didn't feel like I was taking their bandwidth, right? It was more like they were also learning, and we were both learning together, right, from that experience that was there. So that was really exciting. And then in the photo, right, like the skateboard that Thomas bought, that was I would say an exciting part of what happens. Claire, you want to talk about it?
Well, Thomas Monroe is the engineer on the left-hand side. I took all these photos at the conference, and I was not an organizer or didn't have an official role. I helped a bit in the background, but I did not have an official role. But I was a speaker, so I got to go up there and spend about 4 days. Thomas Monroe he's actually giving one of the keynotes here at Posette on day 4. He's based in New Zealand, and he brought that skateboard all the way from New Zealand. There are hills in Vancouver, so he used the skateboard to get to and from the conference every day. But what's cool about it is he calls it like his, I don't know what the name is. Is it his conference skateboard? He puts a sticker on it.
Stickers. Yeah.
Sticker on it from every conference he's been to. And the cool thing is he was a guest on that podcast I mentioned earlier, Path to CitusCon, which I hope more of you check out and listen to because it is pretty awesome. I'm biased, but it is. And he was a guest on it as well. So he put one of the new stickers with the new name on the back of the skateboard, which was kind of cool. But
the Talking Postgres sticker, it was there? Wow.
Yeah. I was giving him out.
Nice.
Margot Seltzer was the keynote speaker. The organizers, Melanie Plegman and Jonathan Katz, I'm not sure which one of them, probably Melanie, reached out, invited her. She came and gave a keynote. It was absolutely brilliant.
Yep.
The middle picture is of the unconference day and the last day of the conference. And people were collaborating and discussing, I forget which topic it was at that point.
There was multi-threading, there was extensions, there was like a lot of those things which that discussion actually moves things forward by a lot than, many months of actually work in itself, right? Like that was what I took away from those unconference sessions.
Bottom line, I think those of you who are here for the Posette live stream probably want us to move on from PGConf Dev, which is now in our rearview mirror, and introduce the next speaker. But what we wanted to do is just give a shout out to the organizers of PGConf Dev. It's a bit of a reboot. It's a new incarnation, a version 2.0, if you will, of a long-standing PGCon developer conference that has happened in Canada for many years. And I just think they did an amazing job. And I had a wonderful time. So shout out to them and to all of you when it comes next year, because I'm sure this event will happen again next year. Think about attending. And there was a lot to learn, a lot of great people to meet. Okay, so why do I have the Cloud Skills Challenge here? I think just a final reminder, because Gayathri was giving a talk about tips relating to Azure Database for Postgres. So if you want to skill up and a chance to earn this swag, the URL is in the bottom left of the screen. Okay, so I'm about to introduce David, but what I want to say before I do is that at the end of David's talk, and he is the last speaker of today's live stream, KK and I are going to stay on for about 10, 15 minutes, maybe 20. We'll see, probably 15. And just recap a few things. So if you want to know where to find the replays or where things are going to be on YouTube after the event is over or what's coming up in the upcoming live streams, just stay on for a few more minutes and we'll share all of that logistical information with everybody. Sound good?
Cool.
All right. So David Wheeler, welcome. He works at Tembo, where David leads the extension ecosystem initiative for Postgres. He, until recently, worked at the New York Times, is a longtime Postgres contributor and creator of the PGXN extension network, and also the PG TAP extension, which is super popular among developers for testing in Postgres. And a few weeks ago at pgconf.dev that we were just talking about, David also facilitated a whole extension ecosystem summit that happened on day one. It took up a whole half day. And he's been leading this conversation on a regular basis, like every 2 weeks, I think, about Postgres extensions. And based on all the collaboration across different companies, he's proposed a V2 future architecture for the PGXN extension network. And so the title of his talk is all about this topic. It's the state of the Postgres extension ecosystem. So without further ado, let's dive in.
Let's go.
Good day, everyone. I'm David Wheeler, creator of PGXN and principal architect at Tembo. Today, I'd like to talk about the state of the Postgres extension ecosystem, its past, its present, and the future. Now, what I mean by the extension ecosystem is how one discovers extensions, learns about them, and installs them, and the challenges that have hindered broad adoption to date. So let's go back to the beginning. Postgres has a long history of extensibility. In the old days, there were two basic approaches to extending Postgres without forking it. One was loading dynamic shared objects into the shared preload libraries configuration variable. and the other was pure SQL extensions and stored and procedural languages and SQL features that used procedural languages and SQL features to create objects. Now, there were quite a few intrepid early adopters in those years, including PostGIS, BioPostgres, PLR, PLProxy, PGTAP, and more. Then Dimitri Fontaine submitted a patch for formal extension support, which was committed and released in Postgres 9.1 back in 2011. This work built on those existing patterns for extending Postgres, but formalized things through 3 key features: tooling to compile and install extensions, both DSOs and pure SQL, new SQL commands to create, update, and drop extensions, which bundle together objects into named units, and backup and restore support to ensure consistent versioning and behavior when upgrading Postgres itself. The artifact that holds these pieces together is the control file, named for the extension it manages. This file tells Postgres the default or latest released version of an extension, the path to any DSO modules and other configuration data, like whether the extension can be moved from one schema to another. The Postgres build system was also optimized for extensions. One need only create a make file with the extension name and, for DSOs, the module directory, a list of documentation files and SQL files to deploy versions of the extension, as well as the paths of the DSOs to be built, and configuration for testing and the pgregress utility. Now, the user who's building an extension can point to the pgconfig utility relevant for their Postgres version, and the makefile simply loads the pgxs make configuration and runs it, taking advantage of all these variables to do the right thing. So this setup enables straightforward compilation of C and SQL extensions by running make. Then make install installs all the relevant files, including the control file, SQL files, and DSOs. And finally, make install check runs the pgregress tests against the newly installed extension. And now the user can use create extension to add the extension to a database. And thanks to the bundling features into a single unit, pgdump output can likewise simply install the extension as before. So this new infrastructure created new opportunities for the extensibility of Postgres. I was pretty excited about the possibilities around that time, publicly claiming that PostgreSQL today is not merely a database, it's an application development platform. As a result, I proposed to create PGXN, a service for distributing Postgres extensions, with the goal to be the canonical source for all publicly available extensions. The features were to include distribution of source code, as well as user registration and namespace management, so there would be no conflict between named extensions. PGXN also aimed to provide comprehensive search features and the ability to browse and read well-written documentation. Individual releases could also be tagged for better discoverability. A command line client, meanwhile, would provide a simple interface to download, compile, and install extensions. Now, a number of features were out of scope of this vision. These included binary packaging. PGXN would be for source code distribution only. It seemed too much to take on support for a wide variety of platforms, so we deferred binary distribution to the community apt and Yum repositories. PGXN also would not include developer tooling or build tooling. These were already solutions for building extensions, most notably PGXS and whatever future directions the core project might take to support extension authors. So I launched the project in 2010, around the same time Dimitri started developing formal extension support. And by December, the little fundraiser I'd set up had met its goal and it was time to get to work. The site, pgxn.org, launched in April of 2011 with the first few extensions and a public REST API. Meanwhile, Daniel Varazzo took it upon himself to write the command line client. It was on my list, but he beat me to it, which was cool because he wrote it in Python, deftly demonstrating that any language could use the APIs and interfaces. And almost to prove the point, Dixon Guedes released a suite of dev utils written in Ruby in June 2011. The community involvement was really great. So here's what PGXN looks like today on pgxn.org. It currently hosts over 2,200 releases of almost 400 extensions amongst 430 users. It's pretty cool, I think, so you should check it out if you're interested in extensions at all. As I said, there's also a robust REST API documented in the GitHub wiki for the PGXN API project. In this example of the docs, the distribution API allows a client to find the latest release of an extension or the latest version. Now, the CLI that Daniela wrote uses that API. Here we ask it to install the Semver extension. It uses the API to find the latest stable version and a second to download the zip file. Then it uses the core provided PGXN pipeline to compile the extension and then to install the parts where Postgres wants to find it. That's it. Now, over time, we've recognized a number of shortcomings to PGXN. First and foremost, there's been little work on it since 2012. Over the years, I've kept it running and tweaked a few things here and there. A couple of years ago, for example, I finally made it look decent on mobile devices. Another problem is that PGXN has always suffered from significant search limitations. Namely, it has defaulted to searching extension documentation, but most distributions don't provide documentation separate from a README, and a README at best. Sadly, PGXN has also not become the source of record for Postgres extensions. It contains at most 40% of publicly available extensions. And furthermore, releases of those extensions have been uneven and many abandoned, in part because the release process was quite manual until I developed a GitHub test and release workflow a few years ago. In other words, I would say that in classic SDLC fashion, the PGXN POC shipped as an MVP and was neglected. I hope you enjoy acronyms. Meanwhile, things have not stood still in the rest of the Postgres extension ecosystem. Chief among the changes has been the emergence of Postgres as a service providers. These services provide and curate extensions for their users. As of this spring, a month or so ago, Azure provides 25 non-core extensions, GCP provides 29, AWS provides 48. PGXN, meanwhile, as I said before, has 369 distributions with 396, almost 400 extensions. But those are just a fraction of those available. Joel and SQL has inventoried almost 1,200 publicly available extensions in a wide variety of locations, especially on GitHub. So this leads me to wonder, why has uptake been so modest? Despite the best of the intentions, some opportunities were never met. Postgres extensions remain quite difficult to find and discover, since they're scattered to the internet winds. Most that one can find, including on PGXN, are underdocumented and difficult to understand. And when you do find them, it can be tricky to gauge the maturity, reliability, and stability of an extension, especially if there isn't much documentation. Furthermore, they're difficult to configure and install. Most users just want to add them to their dev or production clusters and not have to install a bunch of tooling like compilers and developer packages on those servers. Now, a lot of this has to do with there being no comprehensive binary packaging system covering a wide variety of platforms, architectures, and Postgres versions. It's catch as catch can between the community apt and yum repositories and tools like Homebrew. And Windows is pretty much omitted altogether. Now, clearly, the centralized distribution of source code has been insufficient to meet the needs of people who just want to quickly find, install, and use extensions. Part of the problem, I think, is insufficient developer tooling. One has to suss out how to create and maintain extensions by following scattered blogs and example repositories, and the lack of features like documentation standards increase the difficulty in providing consistent product. But as I said, things haven't stood still. A number of new projects have emerged in the last couple of years that attempted to fill some of the development and distribution gaps. One such development is trusted language extensions, or TLEs. The TLE project wants to empower application developers to build database functionality without having to do the full compile install dance on their servers. By supporting only trusted languages, TLEs eliminate the need to install files on the server file system like C extensions require. Any trusted language works, including SQL, PLPGSQL, PL Perl, PL V8, PL Rust, and more. The PGTLE extension provides functions for easy installation, and TLEs can be ported between systems and architectures since they require no compilation. Now, once an extension is installed, PGTLE has hooks into the create extension command to allow seamless loading of the extension. And the system supports custom data types via its API, which exposes the underlying Postgres APIs without requiring C access. This pattern will be used to add support for other hooks in the future, those not normally possible without C, including foreign data wrappers and background workers. The project also aims to inspire or at least inform designs for adding SQL-only extensions to the core. Our friends at AWS and Supabase steer this project. So here's a TLE example that installs an extension named pair. Note that the first few arguments to install extension function are pretty much identical to the contents of the control file that we saw earlier. We pass the contents of the normal SQL files that create the extension objects as subsequent arguments. And then once installed, thanks to PGTLE's hooks into the guts of Postgres, a normal create extension command will automatically load the extension, just as if it had been installed via the file system, as we saw earlier. Another recent source of excitement is PGRX, a framework for building extensions in Rust. It's like C in that it builds shared object libraries to be loaded into Postgres, but provides fairly transparent bridges from the Postgres C APIs to Rust. This allows full access to nearly all Postgres features, including custom data types, functions, triggers, foreign data wrappers, background workers, and more. And since PGRX is just Rust, it's easy to quickly add functionality from Rust crates without having to write something from scratch. PGRX also provides developer-friendly tooling to manage test clusters, run tests, install packages, install and package the extension, and more, as well as automatic schema generation, simplifying the management of the SQL used to create an extension. There's a ton of community excitement and a slew of Rust extensions released every month. The project itself is under active development, thanks to our friends at ZomboDB and the PG Central Foundation. So let's take a look at this, an example here. I recently created a PGRX project to do JSON schema validation, add JSON schema validating functions. This uses the Boon crate from crates.io to do full JSON schema version 2020 validation. These functions define the Postgres interface. Now note the type of the function signature. The JSON type here transparently maps JSON, Postgres JSON to Rust Serde objects. And a second function does the same for JSONB. All the core types have corresponding PGRX types, including arrays, ranges, and variadic arguments to functions. The pgxturn macro tells PGRX how to define the SQL function. Here it's named JSON schema validates, which differs from its Rust name, as you can see. An identical macro for the JSONB version uses the same name, mapping the Rust functions to polymorphic Postgres functions. The resulting SQL looks like this. Note the JSONB arguments. The same goes for the JSONB version. Using the same function name, PGRX automatically generates this SQL code from the Rust source code. Meanwhile, a number of projects have cropped up to try to improve upon the PGXN discovery and installation issues. Database.dev, or dbdev, is a new packaging registry for trusted language extensions. The service makes it super easy to download and install TLEs right from in the database. Tembo, meanwhile, developed Trunk, hosted at pgt.dev, which provides binary packaging for over 200 extensions. Today, it supports only AMD64 Linux, but plans to support a wide variety of platforms and OSs in the future. Similarly, PGXman from Hydra provides Debian packages for many extensions and plans to support macOS packages. And these binary registries have all emphasized features that PGXN have not. These include ease of use, as in this demonstration of installing PGXman and a first extension in just 2 commands. Platform neutrality, as in Trunk showing the available platforms for an extension. Statistics, such as dbdev listing download numbers for an extension, which can be helpful for evaluating maturity and community acceptance. And curation, as in Trunk's use of categories for extensions, which have proven a popular vector for discovering extensions to address particular issues in specific problem domains. Now, all these recent developments have invigorated the broader extension ecosystem, but many of the promises we saw early on, sadly, have yet to be fulfilled. To wit, there is no single source for a complete list of all extensions, or a single registry of all extensions. Every attempt at doing so remains incomplete. This makes discovery difficult, as one has to know to search PGXN, GitHub, GitLab, Bitbucket, the Postgres Wiki, various cloud providers, specific websites like postgis.org, some of those other binary registries, and more, just to find what they're looking for. And installation is difficult outside of the packages provided by your chosen installer, if you can find a list of them. No one wants to compile extensions in a production database server. And most extensions that do exist have very little documentation, usually just a README. And the lack of documentation standard means that docs, when they exist, vary tremendously in quality and format. And all this has led to some pretty low adoption rates. Few databases use extensions at all, and the number using more than one is vanishingly small. Still, as we've seen, there sure has been a lot of excitement around extensions lately. Which brings us to the future. What new opportunities are there to improve the extension ecosystem for developers and for users? To answer those questions, we've launched a project codenamed PGXN V2 to find out and make it happen. Now, this came about thanks to Tembo, the creators of Trunk, who hired me specifically to consider emerging patterns like binary registries and development frameworks, to meditate on the deficiencies, including discovery and ease of installation, to engage deeply with the broader community of Postgres developers, extension authors, and users, in order to understand the use cases well enough to design and implement a new architecture that will serve the community for the next decade or more. And one of the key points of community engagement has been the Extension Ecosystem Summit. We had 6 virtual mini summits to share ideas, discover patterns, discuss issues, as well as an in-person summit at pgconf.dev on May 28th. And the summit took place after the recording of this talk, so ask me how it went on the Discord. We've also worked to identify the key jobs to be done for the PGXN extension ecosystem. To wit, one job is that it must be authoritative, to be the official canonical source of record for all Postgres extensions. It has to be beneficial, in that it's expected that extension authors will benefit from developing and publishing their extensions there. It needs to be integrated, so it's easier for developers to start writing and publishing their extensions. It, of course, has to be discoverable, to make extensions easy to find and understand, and informative, to make extension documentation consistent, standardized, and comprehensive. Another job is for the services in this ecosystem to be programmable, where distribution services provide stable, easy to use, and comprehensive APIs with which downstream developers can build other tools and products that we can't even imagine. Another job is to be installable, to provide automatic binary packaging for a wide variety of platforms for as many of the extensions indexed by the service as possible. And furthermore, it needs to be trusted. To build, we need to build in some validation of extensions to protect from supply chain vulnerabilities. And finally, another job is for it to be manageable, to provide intuitive, powerful interfaces for installing and managing extensions. So I've made a high-level architectural sketch to capture some of the categories and tools of service, the categories of tools and services to fulfill these jobs. Let's take a look. At root, of course, is the root registry, where authors register accounts and release extension source code. This is complemented by a well-known website for users to find those extensions, read docs, look at curation information, and download them. Next is a command line client, which allows one to quickly find, download, compile, and install any of the indexed extensions. Now, these 3 bits are inspired by PGXN and other precedents. But brand new is the idea of interactions. These services stream changes like new releases, which subscribers can use for their own purposes. It will also provide write APIs where trusted clients can submit reports, badges, stats, and other metadata about extensions. Think test matrices or security scores. Stats and reports are the categories of services that provide this kind of data, getting notifications from interactions for recent releases, downloading sources from the root registry, and submitting results to their analysis to the interaction service, which then publishes them in the root registry. From there, the web UX can pick them up and show the links and badges and simple stats to help users to evaluate extension quality and availability. And last but not least, we have the binary packaging services that support a wide variety of operating systems, architectures, and Postgres versions. They subscribe to the interactions to learn about new releases, pull source code from the root registry, and then use the client to build and package them. Then push the packages back to the root registry so the appropriate availability data can be visible in the UX. The CLI then can install from the registry, eliminating the need for DBAs to compile from source on their production servers. So that's the overall high-level architectural vision. Let's imagine now what it would look like. Here's a mock-up that imagines using the CLI to manage extensions. First, let's see what Postgres installs we can manage. This host has 4 installs, 1 from Homebrew, 2 from pgenv, and the Postgres app. The manage list command also shows the root directory for each installation, like this one for the pgenv installed Postgres 16.3. So let's tell the CLI to manage that install. Now use the package list command to show the extension packages that the CLI manages for that install. Here we see there are 3 extensions from the Postgres core, plus the Semver package from pgxn user theory. Note the latest version listed here. That means there is a newer version available to be installed from the ecosystem. So let's use the upgrade command to upgrade it. Note that it found a binary package for Postgres 16, macOS Darwin, and the ARM64 architecture. It then installs the DSO and the libdir for that Postgres install. There's no compilation. The remaining SQL, control, and documentation files also go where they belong, and that's it. We plan to support at least Linux, BSD, and Windows, and likely others in the future. Now, let's say we want to do some JSON validation. We search the registry for JSON to see what's what. It shows the search results, including some stats. In this mockup, there are some averages of some sort of rating service. This one looks decent. It has 4 stars, does the JSON schema validation, and has a pretty recent release. So let's install it. As before, the CLI finds the binary package appropriate for the system of Postgres version, once again just installing the precompiled DSO, as well as the control, SQL, and documentation files. So what does the list of packages look like now? There we go. Note that Semver and JSON schema are now the latest versions. Now, a crucial idea is that all of this is driven by RESTful APIs. So the functionality isn't limited to the CLI. Anyone can use it. For example, a Postgres as a service provider like Tembo will integrate the API to enable easy installation of binaries into their clusters from a web UX. So perhaps we use that UI to search for Semver among all the pgxn extensions. And then, having found it, click the install button and get the extension. This functionality is identical to the CLI installation example and uses all the APIs. All public and private Postgres services will be able to use this service or to federate or curate extensions for their customers. So that's the vision. We'd love to have you join the effort. Feedback and ideas in particular are greatly appreciated. The homepage for the project is on the Postgres wiki, as is a document that goes into much more detail on the proposed high-level architecture. The project to build all this is managed in a pgxn GitHub project, as are the tasks to be carried out for each service, tool, and feature. And I've also blogged extensively about the project and questions and things I'm thinking through since the beginning of the year at my blog, justatheory.com. And the best place to stay in the loop and to get involved is in the extensions channel on the community Slack. And you can join it here at pgtreats.info/Slack invite. So that's it for the state of the Postgres extension ecosystem. Thank you for tuning in, and I hope to chat with you soon.
Okay, so that was also super fascinating for me.
Yes.
Because I started in Postgres, I got my start at Citus Data, so working with an extension. And I think so many people will often comment that the extensibility of Postgres is one of the things that makes it so special.
Exactly.
This ability for startups to innovate, right, without having to wait for changes in the core, right? It enables experiments.
That spans across small users, enterprises, everybody kind of benefits from this, right? And not having, like a structure around this is the kind of problem that he was talking about in the talk, and hopefully we'll start to see more and more of that, emerging as the days go.
So big thank you to David Wheeler for leaving the New York Times and going to Tembo and starting to lead this extension ecosystem re-architecture. I'm expecting to see great things, and I think we all are appreciating the collaboration on it. We are done with our talks for today, and KK and I have first of all, our thanks to everybody who has been with us throughout the entire live stream. And we have just a few logistical things. And I think
before we get there, Claire, I just want to thank you directly here because this is my first co-anchoring and you just helped me so much during this. Thank you, Claire. And thank you for organizing, the overall thing as well. Just wanted to put that out first before we move on.
It's a lot of fun. People consume information in different ways. And I obviously have friends who are engineers who like to learn completely asynchronously, completely by, say, reading and documentation. But then, there's a lot of people who like learning through video and who like the conversational aspect of a live stream. So yeah, this has been a lot of fun. Thank you for working with me on it. Okay, so reminder about the surveys. Speakers really appreciate it. It is a gift you can give them. So while it's all fresh in your mind, if you have feedback about any of the talks you've watched on this live stream, you can use the survey link. The deadline, the surveys will both be open for all attendee talk event surveys until next Tuesday, the 18th of June. So 1 week from today at 11:59 p.m. AOE, which stands for, do you know, KK?
Anywhere on earth. I just, like the PGConf NY, I just went around the globe.
I know. Like, where is it still 11:59 p.m.? Hawaii. Okay, let's pretend I'm in Hawaii. So yeah, the speakers would love your feedback. Our event organizers would love your feedback on the event as well. That's what the URL is on the right.
I think the surveys shouldn't be taking much time to fill up as well, right? It should be quick, so it
super easy.
Won't take much time. Super easy. Let's just get feedback and go there.
That would be great. Now, reminder, this is just live stream 1. We have 3 more live streams to go. Same time tomorrow in America's friendly time zones is live stream 3. So that's happening on Wednesday, the 12th, starting at 8 a.m. Pacific. But starting tonight for me in California, but morning time for Central European summertime is live stream 2. And then the next day on Thursday, live stream 4. So I hope I didn't confuse you with my jumping around between these numbers, but we're trying to hit as many time zones as possible.
Like one in PST and then next in the CST and then again the same time and then repeat.
Yeah.
Right?
Yes. You just have to be careful when you say CEST that you put that E in there for Central European.
Yes. CEST, okay.
Not to be confused with Central in the US. Anyway, you can look at the schedule at aka.ms Posette-schedule. And then what's next? Obviously, you can attend those upcoming live streams or parts of them that are relevant, that are interesting for you. Join the conversation, that virtual hallway track on Discord. The URL is in the upper right for that, aka.ms/open source Discord. Go to the Posette Conf channel. I already mentioned the surveys. And then you can replay parts of this live stream. So the YouTube link is in the bottom right. But actually, in a few minutes, if you reload the aka.ms Posette URL, for the Posette website, the banner will be updated and the YouTube replay will be available up until the time that Livestream 2 needs to take over that space. And
I see. Okay.
and the website will be updated to embed
Got it.
the Livestream 2. So basic logistics. If you missed your chance to ask the speakers questions, because most of the speakers were present on Discord while their talk was live streamed, I bet they're still going to be around. I bet they're going to pop back. No guarantees, but Discord chit chat can be asynchronous. So go ahead and ask your question anyway, and just be sure to tag them so that way they get a notification. Because otherwise, amongst all the chatter, they're probably not going to see your question.
And just to remind everybody, right, what Claire mentioned earlier as well, no question is small question or bad question. Just go ahead and ask those questions. Let's just get the discussion going.
Yeah, I'm one of those people that sometimes suffers from imposter syndrome, and I have started many times in my life with okay, I have a dumb question for you. But yeah, you're right. No question is a dumb question.
And one technique I use is I type in stuff, don't send it, and then take a break and come back and push the press button, right? And just the question goes out into the world. Let's get more discussions. Cool.
Okay, so what I want to do really quickly is just pop up the schedule page so that we can look at the schedules for the upcoming live streams. So I believe I'm scrolling. Am I on the right screen? And I'm going to click live stream 2.
Yep.
And this is the one. I'm actually co-hosting this along with Flor Derez. So I will be there. I'm going to go take a little nap first.
Wow. This is okay.
I'm going to maybe maybe a 3-hour nap in between. But Regina Obey, absolutely brilliant technologist, book author, PostGIS expert on the executive steering committee, has been a guest on the podcast that I host along with Paul Ramsey, and so excited that she's our keynoter for Livestream 2. And then Heiki from Neon is giving a talk about vector data in Postgres. Adam Vogt will be talking about RAG in Postgres and Azure database for Postgres. Lottie Filius is, and I probably mispronounced her last name, Flor will get it right. She's a PhD student in the Netherlands working in a database group, and is a former engineering intern from the Citus team. And so she's going to talk about performance benchmarking and profiling distributed Postgres and Citus. So I'm looking forward to that. Marco Slot is also going to talk about data-intensive Postgres.
Yep.
Yeah, look at all these. I feel like I'm taking over here. Do you have comments on?
No, it's just the content of the talks and where it comes from, right? Some of the folks we already know, some of them are at least new to me, but then look at the contents, right? It's incredible, right? We are in for a great show.
Silvano is an expert in HA and DR. He's based in Italy and works in the Azure database for Postgres team. So I'm really excited to hear about that. Chris Ellis is a dream of a human being and knows a lot about using Postgres. He's just an expert user. And so I'm eager to learn from him about JSONB and schemas being used together. And then Boris Mejias is a brilliant storyteller, in addition to being a good Postgres technologist. He works at EDB. I think I first met him back in 2018. And so he'll be talking about synchronous replication. And I'm hoping to give a talk on replication later this year. So I want to learn from him to get better myself. Jimmy.
That I'm looking forward to that talk too, Claire, from you. But this is going to be interesting. What's going to come in this? Yeah.
And then Jimmy Angelikos and Flor Derez are co-presenting a talk about how to work with other people, specifically focused on neurodiversity in the IT space. And I think that's super important too. Everybody who works on Postgres, we don't just work on the technology alone. We are human beings, and sometimes it's the human element that's kind of the most complicated, frankly.
I mean, the good and the bad, right? So there is always the upside of that human, a community feeling. There is also other things that we need to deal with in itself, right? So I hope there will be more light shed during this talk.
And then Deepak Maddow is giving a talk about PL/PG-SQL, migrating from Oracle to Postgres. And Ryan Booz is a really good explainer, and he'll be talking about partitioning. So this live stream too is an all-star lineup. And I feel like we probably don't have cycles to go through talk by talk, live stream 3 and live stream 4, but just encourage everybody to go check it out. And there's nice little add to calendar buttons in the upper right of each live stream tab. So if you do see things, a particular live stream that you want to block your calendar for, that's a good way to do it. And there's join the Discord links all over the place. So let me see if I can find my way back to the StreamYard and go back to the slides. Okay, some of you have asked, where are the Posette talks going to be after the event is over? And so they're not publishing all of the talks after each live stream, but rather are waiting until all 4 live streams are over. So after the event is entirely over later this week, so I presume on Thursday, maybe Friday, but probably Thursday, the Posette schedule page will be updated with YouTube embeds for every single one of the talks. And there's also going to be a playlist on YouTube, aka.ms/Posette-playlist, which if you go to it now, you're going to see the playlist for last year's CitusCon 2023 talks. But that link will get updated as soon as
even that would be interesting to ramp up to the new talks, last year's one too. But
I completely agree. And I think I have a slide about that in just a second. Reminder that there are captions, not just in English once these get published on YouTube, but in 13 other languages as well. No, I don't have the list of languages in front of me. I can see by the look on your face.
I was going to ask the question. Anyway,
okay.
Let's move
All
on.
right. Next week, I am hosting another podcast recording. We do our recordings live and on Discord. And so it's kind of cool. And we copy the Oxide and Friends podcast people for this, but we record the live audio track with the guest and the host. But in parallel, there's a whole back channel of chit chat on the Discord text chat that's happening live. And that inspires our conversation, but it can be very fun and interesting to be a part of. And so next week's episode is titled The Making of Posette. And our guests are Teresa Giacomini and Aaron Wislang from the organizing team. So if you want to block your calendars for that, it happens on Wednesday at 10 o'clock Pacific Daylight Time. You can go in the upper right, you'll see a URL, aka.ms/path-to-CitusCon EP16Cal. And then if you want to know the languages, Teresa Giacomini, our chair of the event, is dropping messages. So the languages that the captions will be translated into include, in no particular order, French, Spanish, German, Italian, Turkish, Polish, Chinese simplified, Chinese traditional, Korean, Japanese. I am sure Dutch is on the list. Dutch has got to be on the list, right, Teresa? Talk to me backstage. Let me know. Okay, well, it'll be a total of 14 languages. I also wanted to say, for those of you who are looking for swag, I wanted to pop up really quickly one of those sets of codes. So you can go to aka.ms/Posette-swag and enter the codes that you see on the bottom of the screen right now. It's Posette-stickers-mumble. You can see the numbers. And hopefully those codes are still valid and you can get yourselves either some sticker packs, maybe some socks, whatever's available at this point. But people like swag, so we wanted to share that with you. Then let's see. Oh, we wanted to highlight some upcoming Postgres events. Swiss PG Day is happening next week or in 2 weeks. I think it's in 2 weeks, right?
Yeah.
June 27th.
June 27th.
It's in Rapperswil, Switzerland. It's right on a lake. It's on a university campus. I gave a talk there about 4 years ago. It was magical. Really, really a wonderful event. In September, PG Day UK and PG Day Lowlands are happening. And those are kind of meant to be sister events, I think.
Okay.
And the CFP will be opening soon, if not already. for PG Day Lowlands. And then there's also PG Ibiza happening in Spain on a beautiful magical island. And that CFP is still open too. It closes
June
shortly,
23rd. Yeah.
June 23rd.
Okay.
So, and then of course we have PGConf New York City. That CFP is closed, but obviously you can go register and plan to attend. And it's Midtown New York City, really great, convenient location, lots of easy access in terms of hotels nearby, great food, wonderful people. I want more people who work with Postgres in the New York area to discover this fabulous event, which is, I think, going into its 3rd or 4th year. And then PGConf EU is amazing. And I'm half Greek. So
This time, yeah.
I really, really want to go this year. We'll see.
Awesome. Yeah.
Happening in October. Probably possibly the largest in-person Postgres community event.
I see. Okay. Interesting.
Unless you count the geospatial events, which are also all based on Postgres too, right? Because those are probably even bigger. Oh, you mentioned the CitusCon playlist. Here's the URLs for year 1 of this particular event. We renamed it. It's called Posette, an event for Postgres now.
Yep.
But it used to be called CitusCon.
Yeah. But still, playlist is available, right? Like that's what.
Yeah, and we kept the old names on the old playlist because that's what all the branding, everything is still CitusCon for year 1 and year 2. And there's some great speakers and some great talks among them, and most of it is still quite relevant,
Definitely, some of those ones, like over the years, I've gone back to them, like to learn something specific too, right? Like then you get to learn something that definitely happens in, especially in the CitusCon playlist. It's a great collection of talks.
So before we sign off, I just want to say thank you to all the amazing speakers one more time. You can't have a great event without great speakers. So, and you're one of them, KK, along with Melly. But look at these faces, just such great expertise, dedication, commitment, work ethic. And so, yeah, thank you very much, as well as to the organizing team who made this whole thing happen. And I think it's a wrap.
Cool.
Thank you all very much.
Really awesome. Thank you, all of you.
Let's see if we can go like this and just wave goodbye. Yes. Sorry, Dwight, for taking over there. I just wanted to end with a human element as opposed to the PowerPoint element. Even though I do like PowerPoint. Oh, well, shoot me now. Thank you.
Thank you. Bye-bye. Bye-bye.